All right, everybody, welcome to the week one lecture for 8340 mobile application development. This is section 5210. I am very happy to be with you all. If you don't know who I am, if this is the first time you're seeing my face, I am Nate Ebel. I will be your instructor for this quarter. And before we really get into the bulk of the new content for this week one lecture, I want to take a little bit of time, since this is our first kind of official lecture, and just review a little bit about kind of the week zero stuff, our syllabus, and just kind of get us all on the same page. So if we go here, week zero review. If you're not familiar with week zero, hopefully, if you're finding this, you've been into Canvas. Week zero is just a little bit of housekeeping stuff, trying to get us familiar with Canvas, with the structure of the course, all of that. So in particular, for week zero here, I want us to make sure we review the syllabus. The syllabus you can find by going into Canvas and clicking the home section here on the left, or explicitly going to the syllabus section. They'll both take you to the same place. So please take some time, review the syllabus, specifically kind of the summary, required materials, which we'll really be getting into today. That's kind of the purpose of week one. Also the class structure, topics, grading, all that good stuff is in the syllabus. So please review that if you haven't already. And again, I want to explore the week zero module as part of this as well. So come over to the module section, and week zero, you see this start here, hopefully a nice indicator of where we should all start. But take a look at this, watch the welcome video if you haven't, check out the week zero lecture video as well. It gets more in detail into kind of the syllabus and some of that stuff. In particular, the class communication section is really important. And again, required tools we'll kind of talk about now. And then also just want to draw your attention one more time to our first homework assignment, which is really just this welcome discussion, introduce yourselves, and just share what one of your first mobile or favorite mobile apps is. This is really just meant to be a simple discussion to get us all chatting and familiar with the tooling and everything. Now, a couple announcements for week one. I know we're just really starting, but there are a couple things I wanted to call out already. So first off is that all official announcements, they'll all be made within Canvas. So you will see announcement posts related to these items as well. And that will be the place to go. All official communication will happen there. That said, I do want to call these out. So first off, office hours are going to be moved to Monday evening, I think. It sounds like there were some scheduling conflicts with people on the Thursday time that I had initially called out in the syllabus. So that will all be updated, and hopefully Monday evening works better for people. And then also want to clarify a point that was in the syllabus as well. There was an optional item in there about a $25 Google developer account fee. And I just want to point out that that is completely optional. It will not have any kind of impact on your grade or assignments or anything like that. Basically, just at the end of this course, we're going to have kind of a bonus lecture about how to actually take the apps we've built and upload those to the Google Play Store. And to do that, if you want to do that with your app, you will need that $25 account. But that will be optional, like I said. And if for some reason you do want to do that and that $25 is, just a bit of a challenge right now, especially with everything going on. I know a lot of people are, out of work right now, things like that. Money's tight. Let me know and we'll work something out. Okay. Week one here. Let's just jump into this. So week one assignments. We just want to call this out up front so you kind of know what to have in mind as we're going through this. Both of these assignments for week one will be in Canvas. There will be go to this here. There we go. So there will be a discussion assignment again for week one, and then there will be an app assignment. The discussion assignment here, again, just another simple discussion. but basically want to get you thinking about what makes a great mobile app. Does it solve a particular problem for you? Does it entertain you? Is it fast? Does it require an internet connection? We'll talk about some of these types of things later on in the lecture, but these are just some of the things to keep in mind for that assignment. And then the app assignment this week, which will likely make more sense once we get into the lecture, but essentially we're going to build our first simple Android app and then basically change just a single text item in that app, customize it a little bit, and then be able to run that app. So again, we're gonna walk through all of that in the demo later, but this is essentially what the homework assignment will be. So take a look at both of these. These will be due Wednesday the 22nd. And yeah, we'll just take a look at those. Now that we're on the same page, we can move on with the rest of the lecture. Okay, so as I mentioned here, we have our discussion assignment, what makes a great mobile app, features, price, all that kind of stuff. Our app assignment, creating our first Android app. Yep, all of that's good. All right, here we go. We can finally start off now. Introducing mobile app development. So why should we learn app development in the first place? Why pick app development as opposed to desktop development or backend development or machine learning, anything like that? Well, there's a few things that kind of stick out about app development that I find particularly interesting, and also just think kind of place it uniquely within some of these other disciplines. So first off, there are an estimated 3.5 billion smartphones in the world. So that's obviously a huge number of devices. That's something like one smartphone for every 2 people in the world. But then if you add in tablets, smartwatches, IoT devices, that number becomes much larger. Finally, also, mobile devices, they tend to just be less expensive and more portable than, let's say, a laptop or a desktop computer. So this makes them easier to carry around, easier to sort of buy and sell. This also means that smart devices have become ubiquitous. It's very common, particularly in the United States, much of Europe. It's very common for basically just everybody you meet to have a cell phone. Even in sort of emerging markets, places, South America, Africa, very much it's a mobile first sort of mindset where people will pretty much all have a mobile device, but maybe not have a laptop or something. So app development is something that we can build that pretty much everybody can take advantage of. And then, like I said here, we saw those numbers in the last slide. You know, the majority of people in the world have at least one smart device. I don't know about you. I personally have several smart devices, particularly as an app developer myself. I've got testing devices, personal devices. So yeah, there's just a lot of smart devices out there. With this huge number of devices out there, this presents a really large market opportunity for businesses and for software developers like myself and like you all. If you pull up a LinkedIn and just do a quick search for mobile developer, there's over 30,000 jobs that pop up there. Those numbers change and grow and shrink depending on what type of mobile developer. So maybe it's native, Android, iOS, all those. But basically it points out that there are a lot of jobs available right now for mobile developers. It's a big need for businesses. And there's many more opportunities for indie developers or freelancers. If you want to build your own app, you want to build your own game, or if you want to contract out to people, there's many more opportunities for all of that. So mobile's a great place to be if you're looking to kind of make money or build a career as an app developer. Some really unique challenges with app development as well. There are unique interactions that really didn't even exist before the move to mobile apps. So we have to account for things like touch, rotation, gestures. There's many different form factors, you know, phones, tablets, smartwatches, they all look different sizes, shapes, all that. And we have to account for that. There's varying performance of these devices. They might have limited network connectivity or memory. So all of these are things that we have to keep in mind. So if we look specifically at user interactions, like we already mentioned, mobile apps require touch input. But that can mean a variety of different things. So if I pull out my phone here, I might do a one finger swipe. I might use two fingers. I might swipe left or right. If I'm on a larger tablet, I might even do bigger gestures with multiple fingers. All of that is pretty complex. And then there's just like the shape and direction of the gestures. We have to be able to recognize those consistently and respond to them. We have different touch input. So, my finger when I touch the screen might be a different size than your finger. That might be a different size than a stylus. And we have to be able to, again, recognize all of those different things because they might mean different things depending on how we code for that. Another interesting thing is when we look at a mobile app, we don't generally have a lot of tooltips. And we don't have a mouse to kind of scroll around and highlight things to give us hints as to what a button might do. So we have to build really intuitive UIs that kind of help guide the user into common interactions and functionality. Like I mentioned before, mobile devices have a ton of different form factors. We have small phones, really large phones, tablets, phablets, weird sort of hybrids. We have folding devices now. There's a lot out there that we have to account for, and our apps have to be able to grow and shrink and resize accordingly to take advantage of those sizes. Similarly, there's not even a standard orientation. Some apps might be run really well in portrait, but not in landscape. Folding devices bring a whole new element to this because you can have portrait and landscape sort of intermixed very quickly with each other. Something like a Chromebook that's running an Android device might have resizable windows, and that orientation might change really quickly depending on how you scale it. So again, another challenge there. And there's no standard really hardware in these devices. You don't have a standard resolution, processor speed, amount of memory, amount of storage space. All of these things have to be accounted for to provide the best user experience possible for app users. So as I mentioned, limited resources, mobile apps go anywhere. That's really probably their biggest strength, that we can take our mobile devices with us anywhere. And most people do take them with us anywhere. Even if we're going out camping, going on vacation, we have our phone, even if we maybe don't have a laptop or a desktop computer with us. This makes it challenging. We might not have internet, or we might have internet and it might be really slow. So how will our app respond to that? We might be on a data plan where internet is really expensive. This is particularly important in emerging markets like Africa or South America. You might have to actually walk several miles to an internet cafe just to sit down and pay for some internet to, check your apps. So you have to be really mindful of that and try and design and build applications that are memory efficient and data efficient. And all of that said is really the devices themselves. We haven't even talked about the people yet. And honestly, the people are oftentimes the biggest challenge in app development. A few things here. People are impatient. We might pull out our phone and check 6 different apps within a minute. So our apps have to be really quick. They have to be snappy. They have to be performant. We get distracted. We have lots of notifications coming in. We have all different kinds of content. We might jump to music, to YouTube, to Instagram, to Twitter, to our email. All of those things, again, are keeping us distracted, keeping us jumping around. So we have to provide quick, functional experiences for our users if our apps are going to have a chance of making it. And even then, even if we provide a good experience, there's tons of competition from other developers out there, from other companies that are all trying to do the same thing. So we have to, again, provide a great experience if we want to kind of rise to the top of that competition. And then finally, building software is challenging. Regardless of whether it's mobile or machine learning or backend development, software is challenging in of itself. And we can't minimize just the complexities involved with building a working piece of software. So yeah, we talked a bit about this, some of the different types of things that kind of distract people, checking a calendar, playing music, ordering food, skimming social media. All of these things can distract us, and they also mean that we expect really quick, useful functionality. Reasons why we want to have quick, useful functionality. Well, people will uninstall your app if it's slow or unresponsive. People will abandon your app if they don't think it's immediately useful. Mobile app development. Now I want to talk just a little bit about the different types of mobile app development we have out there. And when I say different types of mobile app development, I'm really referring to sort of the technologies used to build them. In a perfect world, any of these technologies would build an app and a user experience that was really transparent to the users. Ideally, your users shouldn't be able to use your app and tell what technology you use to build it. However, that's often not the case. So we'll talk a little bit about these. So first off, we have native app development. So this is iOS development or Android development. We have this is iOS development or Android development using the native tooling coming straight from Apple and Android, and we'll talk a bit about that in a second. We have cross-platform development. These are frameworks that you might have heard of, such as React Native, Flutter, Xamarin, things like that. And then we have the mobile web. So let's talk a bit about each of these. Native app development. So when we say native app development, people typically mean kind of the standard tooling and processes coming straight from Apple for iOS or from Google for Android. Native experiences, native apps give you the most control over the user experience. When you pull out an Android device, for example, from Google, it looks a certain way. And many apps actually follow very similar visual guidelines, and there's common interactions. Those are all things that you expect from a native experience. Native applications also tend to give you the best access to hardware, to sensors, to APIs. They bring you the closest you can down to really the hardware level, so you have full control over what the device can do. So these are all good things. There are some challenges though with native development. Because iOS and Android require different tooling, different languages, different operating systems, all of that, it means that to build native mobile applications for both platforms, this typically requires multiple code bases and usually multiple teams as well. So if you're a single person wanting to build apps, or if you're even a company wanting to build apps, you have to take that into account. And then additionally, because these are different platforms, skill sets, all of that, it means it requires specialized skill sets. So you have to learn different sets of skills and tools to build an iOS app natively versus an Android app natively. Now, next up is cross-platform development. Cross-platform development aims to write a single code base, really a single app that can be used on both iOS and Android. And this is a great way to leverage skills of web developers in particular for something like React Native, or just other developers on your team, because they can learn kind of a single language and set of tools and build apps for both platforms. This has the potential to be a lot faster for certain types of projects. Now, there's a lot of debate in the community about what's better, cross-platform or native. I don't really want to get into that too much. But my personal preference is it just sort of depends on your needs for the project. But definitely for small one-off projects, cross-platform can be a really great option. One of the drawbacks to cross-platform applications is that you have less direct access to the hardwares and sensors. Usually cross-platform sits on the native code. So you might have like the hardware right here at the bottom, followed by the native operating system, so maybe Android, and then you might have something like Flutter that sits on top of that. So it kind of adds another layer, and each layer you add sort of abstracts things and makes it more difficult to get to that low-level performance and sensors and all of that. And then one of the biggest challenges with cross-platform development is building user experiences that look and feel native. You know, when I pull out an Android app, I expect it to behave a certain way. If I pull out an iOS app, I expect it to behave a certain way. And cross-platform makes that challenging since you're kind of building a single code base and experience for both. So that's one of the big things to keep in mind when building for cross-platform. And now the third option we'll talk about here is mobile web. So mobile web is essentially regular web development that's optimized to work well on mobile devices. And that can even, to some extent, give you access to certain sensors and stuff on the device. So this is a great way to leverage your existing web developers and even a lot of your existing web code, because a lot of it will just run natively. So there's less unique code to have to write. It's also extremely fast to ship and distribute web code because you can just deploy it directly to your website or your APIs, anything like that, which means users immediately have access to it. This is in direct contrast with native or cross-platform apps that have to be distributed through the app stores and can sometimes take quite a bit longer. The least amount of access to low-level hardware and sensors. So that's to low-level hardware and sensors. So that can be a big challenge if you're building an app that uses a lot of that stuff. And then just widely varying user experiences. There really aren't a lot of standards for mobile web experiences. It's really just like the web. It's kind of the Wild West. You can sort of do whatever you want. So this can present unique challenges if those mobile web experiences aren't taking into account the mobile experience as well, not taking account the sizes and the resolutions and the orientations and all that stuff. So it can be tricky. Picking a mobile technology is a complex decision. People get paid. Mobile technology is a complex decision. People get paid lots of money to make these types of decisions. It takes a lot of experience, maybe some instincts. It takes a lot of domain knowledge. You have to understand your project's capabilities, your company's needs. There's a lot that goes into that, and we're only going to have a limited time this quarter, so we're not really going to get into any of this outside of native Android development. So why then are we going to choose native Android development? Android devices account for over 70% of all mobile devices in the world. I think it's something like 72% of all mobile devices are using the Android operating system. As of 2019, Google announced at their big Google I/O conference that there were over 2.5 billion Android devices out there in the world. We're another year removed from that, essentially. So I'm sure that number has gone up quite a bit. So obviously Android out here is just a huge market share and so many devices. Android is also much more approachable. The devices tend to be less expensive. Certainly they have high-end expensive devices, but they also have many, many low-end, cheap, affordable devices. And these devices really make Android, again, ubiquitous in all parts of the world. You know, if you go to somewhere like China, Brazil, Nigeria, those places are all Android first. And they're using these lower end devices typically just because they're more affordable. They're easier for them to get their hands on. Additionally, not just the devices are cheaper, but it's actually cheaper to even just be an Android developer. To be an iOS developer, you have to pay, I think, roughly $100 a year to keep your account active. For Android developers, you pay $25 once, and that's just to be able to upload it to the Play Store. You can actually build the apps and deploy them and distribute them on your own without paying any fee. And you only pay the fee once. So that part's much easier as well. Also, Android apps can be developed on pretty much any operating system. So whether your machine is a Windows machine, Mac, Linux, or even Chrome OS to some extent, you can download and install the Android SDK and build tooling and start building Android apps. This means that the devices to build them, the laptops, the desktop computers, they're much cheaper compared to building for iOS, which requires a Mac. I already mentioned the cost of the developer account, so $25 for life, much cheaper than $100 a year. And another nice thing is that Android app reviews are much quicker. Apple is notoriously frustrating to deal with when submitting application reviews. It does keep their bar really high for the quality, but also sometimes it can be really frustrating to work with them as an app developer. Android, on the other side, they don't do as much in reviews, so it makes it much faster for you to be able to ship an app out to the Play Store. So all of that said, Android it's approachable, it's cheaper, it's really easy to get up and running. The tooling and stuff is free. So that's why we're going to be exploring Android development this quarter in this course. So now let's plan our step forward, or plan our path forward a little bit. I just want to frame again where we're going and what you can expect in this course. So my goal for you all is to really go from wherever you're at now in terms of experience with app development. So that might be 0, that might be, you've dabbled a little bit, but want to go from where you are now to essentially being app developers. And my definition of an app developer is just someone that's built an app. So really after this first week, you will all be app developers based on my definition. And hopefully by the end of this quarter, we're going to have built an app similar to what is often expected for take-home job assignments during an interview process. So by the end of this quarter, hopefully you'll have the experience needed to actually work on and complete a take-home assignment for an Android job interview. So we're going to start early in this quarter, as early as really this week. We're going to create our first simple Android app. We're going to then, add functionality to it throughout the quarter. We'll learn to deploy the app, to test it, to actually play with it on our device. And then at the very end, like I mentioned before, I'll even show you kind of in a bonus lecture how to actually upload that app to the Play Store and be able to download it from Google Play, show it off to your family, your friends, all of that. Or more importantly, probably show it off to people when you're interviewing for a job. So, all of that said, the first step really for us starting to become Android developers here is we need to set up our development environment. And so our development environment for this course is going to be pretty much comprised of 3 things. It's going to be Android Studio, which is going to be our IDE, Git, which we will use for version control, and GitHub, which we will be using to store our code, and also will be needed for submitting homework assignments. So now hopefully you're all somewhat familiar with Git and GitHub. If you are not, I have included resources in the module for this week on how to get set up and running with those. I have a couple tutorial videos linked to help you. And I'll also be going through some of that in the demo for this week's lecture as well, which will come a bit later in this recording. Now, to start, Android Studio is an integrated development environment for Android. If you're not familiar with integrated development environment, it basically means that it's a really fancy text editor that has a lot of built-in tooling to make building for Android easier. It's technically possible to build an Android app just using a plain text editor and the command line basically, but it would be a lot more work and hassle. So Android Studio is a way to just make that easier for us. Android Studio is built officially by Google, so that team maintains that tooling and makes sure there's really tight integration with all of the APIs and everything. And then Android Studio is actually built on top of another IDE called IntelliJ, built by JetBrains. And JetBrains is known in the industry for having really best-in-class tooling. And so that means that Android Studio gets to take advantage of all of that tooling and is really a really nice tool for us. It's made Android development much nicer since it was introduced several years ago. Oh, and before kind of moving on, the demo will walk through in great detail how to download and install and set up Android Studio. I'll be doing it on a Mac, but I also have linked to some video resources on how to do this for Windows too. And the general idea is very much the same. There'll also be some links in the module for how to walk through the setup process that comes straight from Google. So you'll have kind of several resources there to help you get this set up. So in addition to Android Studio, there's some Android Studio kind of tools that we'll need, specifically the Android SDK, which is all of the kind of the libraries, the code, the APIs, the tools, everything that'll help us actually build the app. There's the Android emulator, which is essentially just a virtual device that lives on our development machine that lets us test our Android apps without having to use a physical device. And then there's the platform and build tools that, again, just kind of go into making the building of the app simpler. So all of those, again, we'll walk through how to set those up in the tutorial video or demo video a little bit later on. So before we kind of get into the demo, if you want to kind of go out and explore on your own, this is the link for installing Android Studio. Basically developer.android.com/studio/install. Pretty straightforward there. That'll show you a nice download link. You can get started there. And that pretty much takes us now to the demo. So we'll kind of cut over to that video, walk through that process. Okay, so to start, just open up Google and we'll search for install Android Studio. We'll see the first link there is the one we want. It says download Android Studio and SDK tools. We'll go ahead and click on that, and it should take us to developer.android.com/studio. This is the landing page for all things Android Studio. And what we're looking for here is the big green button that says download Android Studio. Now below that, you notice here it points out 3.6.2 for Mac. So it's saying, the current version is 3.6.2, and it's also recognized my operating system. If you click on the more download options, it'll take you to this section here that shows that we have downloads for Windows, for Mac, and for some different Linux distributions. So whatever your development machine is, Android Studio should run on it just fine. And like I mentioned before, it'll even run on Chrome OS with a little bit of finagling. So if I scroll back up to the top, we're going to go ahead and click Download Android Studio. I'm going to accept the terms and conditions. And once you've satisfied those terms and conditions, we'll click Download. And this will kick off the download process. It's a pretty big download, so it'll take some time. Here I've sped it up, and I've double-clicked on that downloaded DMG file. If you're downloading this on Windows, it'll probably be a .exe file. Once that's kind of extracted, here on Mac, it's going to ask me to drag this over to my applications folder, and then I'll double click on it. On Windows, it should have a similar sort of installer process that kicks off. Once it's done kind of extracting files, I'm going to go ahead and open it up. Now, once Android Studio is opened for the first time, it should look for any available Android SDK. And so in this case, because I don't have one, it's going to say missing SDK. So we want to install some version of the SDK now. And by default, it's going to download Android SDK for version 10, as well as some of the associated tools. And we'll go ahead and leave the SDK location as the default in this case. Once we're satisfied, we'll click Next. And so here it'll actually review what's going to be installed. So that'll include the Android emulator, the build tools, the platform APIs, the platform tools, basically everything we need to get started building our first Android app. Once we've kind of reviewed this, we can go ahead and click Finish to continue on with the install process. That'll take some time, but once it's done, you can click Finish. Here, we next want to go to the Configure section. And we want to open up the SDK Manager. Now that might be a little bit different on Windows, but what you're looking for is SDK Manager. Now here we can see that we have the Android 10 APIs installed. But you see we have a lot of other versions too. So you might want to install some of those if you were doing this professionally, but for now, just the one is fine. If we tab over to Build Tools, SDK Tools, we'll see there we have an update available for our build tools. So in this case, I'll go ahead and click that so I can get the updated build tools. We'll see that we already have the emulator installed as well as the platform tools. Now there's a couple other things we're going to want to go ahead and download as well, just to be safe. The first one, down at the bottom, we see the Intel Emulator Accelerator, the Haxum installer. If you have an Intel processor that supports it, this really speeds up your emulator. So I suggest downloading that if you can. And then we'll download the Android documentation. We'll go ahead and click Apply, then hit OK. This should bring us to a license agreement page. We'll click on each license and click Accept. Once we're done with that, we'll click Next, and that'll kick off the install here. Once again, this will go fast. I've sped it up. Eventually, you'll get to this emulator section. Here you can define your settings for your emulator. Now, by default on my machine, it recommends 4 gigs of memory. You can slide this to be whatever you want, but I recommend just clicking the Use Recommended Size option because that'll take into account your machine's specs, and go ahead and click Next. So here now it's installing the Haxum accelerator for me, so I'll authenticate it if it needs. And then at the end of this, you should be able to go ahead and click Finish a couple times. And now we should have essentially the first round of tools and SDKs all installed on our machine. Now we can go ahead and click Start a New Android Studio Project. And we're opened up into this little creation wizard. And we see we have several tabs. We're started on the phone and tablet tab, and we have templates for a variety of different sort of starter projects. But you also notice the other tabs. We have Wear OS if we wanted to build a watch application. We have TV for Android TV applications. We also have Android Auto and Android Things for IoT and automotive. All of those are great, but we're not going to use them in this course. So we'll go back to the phone and tablet section, and we're just going to click on the empty activity section for now and click Next. On this next screen, we get to name our new app. So in my case, I'm going to update the name, and instead of my application, I'm going to call this something like AD340. Feel free to name your application anything you want, but if you name it AD340, it'll be easier to follow along. Next, the package name. This is kind of like your personal identifier. So for me, by default, I use com.goobar.io since that kind of matches the domain of my website. However, you could do something else like com your name or com something, anything you want really. So in this case, I'll go back to com.goobar.io.AD340, but that package name is the unique identifier for your app. Next, I'll go ahead and update the save location of my project. I recommend you define a new folder for your course. In my case, I already have done that. I have one called AD340. Now within that directory, I'm going to create a folder called App. For language, we're going to go ahead and leave it as Kotlin since that's the default. And for minimum SDK, go ahead and leave it as Kotlin since that's the default. And for minimum SDK, we could leave it at Android 5.0, but I'm going to actually update it to Marshmallow, and I recommend you do the same. This makes it a little bit easier to develop for and still accounts for about 85% of all Android devices. After that, we'll go ahead and click Finish. And you have now successfully created your first Android project. Now that might take a little bit of time to finish indexing and kind of setting things up. So you might see that little progress indicator in the bottom right. But this is really it. We now have a working Android application that we'll be able to actually install to our emulator in just a little bit. So again, notice the progress indicator in the bottom right. Now we're going to go up to our menu and we're going to click the little button that looks like a phone with an Android in front of it that says AVD Manager. Or we can go up to our menu, go to Tools, AVD Manager. AVD stands for Android Virtual Device. So this is where we'll create our first emulator so we can test our app on our computer without needing a real device. So we'll click Create Device. And now in this case, you can choose what type of device you want to emulate. So I'm going to choose a Pixel 3 XL device since it's one of the more new high-end devices. I'll then click Next. Now we have to download a system image that basically defines the version of Android and what operating system that device will be running. So you see we have a number of different image types here that are kind of customized based on what's pre-installed on them and what processor your computer has. Now, by default, I would recommend just sticking with the options on the left-hand side under the recommended section. So you see here on recommended, we have Android R, which is the pre-release version they're working on, or Android Q, which is the latest stable version. So I'm going to go ahead and click download on the Q, and this will start off the download, which again will take a while. I've sped it up. And so now, once that's done, we can click Finish. We can click Finish. There we go. Click Finish. There we go. Click Finish. And so now we can go ahead and select Q for our new Android emulator settings, and then click Next. Here you can further configure and name it, but I'm going to leave the default and click Finish. And you'll see here, now we have a configured virtual device. So now we have our new Android app. When you look over on the left-hand side of the screen here, this is the project pane. This is where the files and the resources and the build configuration all live. Now, by default, it uses this Android drop-down section, which hides a little bit of the complexity of the build, which is actually really nice in some sense. But for now, we're going to switch over to the project pane. The project option shows you the files exactly as they look on your file system. So if you opened up the directory that this project was created in, it would look just like the project pane does right now. Under this app directory, we can navigate to source, main, Java, and we'll see here we have one file called main activity. Now we're going to get more into what this all means next week, but for now, main activity is a class that represents what we see on the screen. Now, if we go ahead and click the green arrow, we can deploy this to our newly created emulator. Now, after a few moments, that emulator should appear on your screen, and Android Studio will install that app to the emulator. So here my emulator is now opened up, and after a few moments, we see here we have a new app. You see 8340 at the top, that's my app name, and Hello World printed on the screen. Now this is basically what our homework assignment is. You're going to be tasked with customizing the text printed out to the screen. So let's quickly review kind of where that text is actually coming from. Everything we see here on our screen, all this colored stuff, the message, our screen, all this colored stuff, the message, that's all defined by main activity in this case, which again is just a simple Kotlin class. We'll talk more about exactly how to define a class in later lectures, but for now, we can notice the class and then this onCreate method that says when this is created, define this view that will be displayed on the screen. So notice the setContentView method call here. Now that method is referring to a layout called ActivityMain. So once we open that up, we'll see that a layout in Android is defined using XML. And again, we'll get into what this really means and is doing next week. But I just want to call your attention to this text view element down below, specifically this line that says Android:text equals hello world. This is the line that is defining what we see on our screen. So instead of hello world, let's type hello 8340. Once I've updated that line, I can once again run the app by pressing the green arrow in the toolbar, and it should redeploy our app to our emulator with that new text included. So I've clicked the green arrow, it's reinstalling, and now we see hello 8340 printed out to our emulator. And now once again, this time I'll change it hello 8340 to something like my name is Nate. I will rerun this once again. And now again, you can see that the text has changed. So this is what you're going to have to do for the first part of your homework assignment. You'll create this project, and then you're going to modify that text to say, hello AD340. And then if you want to throw something extra in there like your name, feel free. Okay, so now we have our simple Android app ready to go. We want to walk through just how to get this into GitHub. Now there's a variety of ways you could do this. You could do this from the command line using Git. You could cd into your current project directory, initialize that directory as a Git repo, and then push that up to your GitHub remote. If none of that makes sense, if you're not familiar with that workflow, totally fine. We're going to walk through in the demo how to push the code to GitHub directly from Android Studio. Okay, so in Android Studio, we'll go to the menu and click on the VCS tab, which stands for Version Control System. And we'll scroll to the bottom. And so first we're going to click on Enable Version Control. And it's going to ask you what type we want. And we're going to enable Git, since we're going to be using Git and GitHub for this course. Once we select a Git, hit OK. So now this project has been initialized as a Git repository. If we go back to the VCS menu, now we can click Import into Version Control, and then we can click on Share Project on GitHub. Now it might ask you to authenticate at some point during this, in which case you will enter your GitHub username and password. Here, it's now asking me to fill in the details for this repository. So I have, by default, it's picked up the app name as a repository name. The remote will just default to origin. Just leave that as it is. Now we can fill in a description. I really encourage you to put at least something in here. So I'm going to put a project code for 8340. And then you can go ahead and click Share, and it will create a new repository on GitHub. You notice here that it'll point out if your name is incorrect or not. In this case, it complains because I had a space. I'll change that. I'll click Share. Now it's going to ask you to create a commit if you don't have one. If you don't have one, just leave the defaults and go ahead and create that initial commit and click Commit. You should see a dialog that says Successfully Shared Project on GitHub. Once you've done that, you can open up a web browser, navigate to github.com. You'll want to sign into your GitHub account. So here my GitHub username is N8EBEL. I'll enter my password. I actually enter the wrong password there. I'll enter the correct password this time and go ahead and click Sign In. Bear with me. There we go. Now I have two-factor authentication set up for my GitHub account since I use it for work. So I'll go ahead and enter the temporary auth code here. All right, so now I'm into my GitHub profile, and under my repository section, I now see an AD340 repository, which was just created from Android Studio. And so I can see all of my app code was just pushed 1 minute ago, it says. So that's it. So now we have our code in GitHub. So now the next thing we want to do for our homework is create a README. READMEs are really important because they help sort of other people know what to expect in this. So by default, I want to have you create some type of README that just says this is for AD340 and include your name for now. And then as we go through the course, we will update this README as we go. Once you've added that text within the GitHub editor, go ahead and add a commit message that says something like add project README. And then we'll go ahead and click on commit new file, and we'll leave it as committing directly to master. So now we have successfully added that file, and we see that GitHub is rendering our README. Now, if we go back to Android Studio, we don't have the README present yet because our Git history has not synced up with our remote on GitHub. So we can go up to our version control options in the menu, and we can click Update Project. this is going to do a pull command from Git and then merge those changes in if needed. So now it says one file updated, one commit. And we'll see now that we have our README present on our local version of the repository. So that is kind of a basic flow there for updating your README in GitHub and pulling those changes down. Now, any way you want to do that is fine. If you want to work with Git and GitHub from the command line, that's great. And we'll kind of review that in a later lecture. But for now, working from Android Studio is quite likely the easiest way to get going. Okay, now for our homework assignments, I'm going to require that you submit an APK. An APK is essentially the application package file. Essentially, it's a zip file of everything that goes into making the app run on a device. So now I'm going to walk through what that process looks like within Android Studio and where that file actually is located so that you'll know where to look for it when it's time to submit your first homework assignment. Okay, so now we're back in Android Studio. Go up to the Build tab and click on Build Bundles/APKs. Now, after a few moments, you should see a notification in Android Studio that says Build APKs, basically saying like the APKs were successfully completed. Now we'll navigate to our app directory, go app, build, we'll go app, build, outputs, and you'll see the debug APK there called app-debug APK. So now one more time, let's just kind of walk through where that lives. So I'm going to go back to the root level project directory. So for me, this is called app. So I'll open up the project directory. Then I'll navigate inside of that into the app directory once again. Open the build directory. Click on Outputs, APK, debug, app-debug.apk. Now we'll kind of talk more about what that structure means later, but for now, this is where you can find that debug APK to submit for your first app assignment. Okay, that is it for the week 1 lecture materials here. If you have questions, please email me. I'll have office hours next Monday, and also have time during our live class session on Wednesday to ask questions. So if you watch this ahead of time, have questions, you can ask me and I can cover those Wednesday as well. And with that, we'll go ahead and end this video, and I will see you all on Canvas or in our live Zoom session. Hey class, welcome back for week 2's lecture content. Now, if I jump over here to the slides once again, as we see here on the slides this week, we're going to be looking at activities, activity life cycles, interactive UI, and really some more, diving deeper into what actually makes an Android app tick. So if we kind of look at our outline here for this week's content, we have kind of our first section here is going to be talking about the Android framework components. What are the building blocks of an Android app? The next section is going to be a review of the project we created last week. We'll be diving deeper into that project and looking more closely at what exactly is created when you create a new Android project and how those pieces work together and kind of what their purpose is. The next section will be diving deeper into working specifically with activities. How does an activity control what is on our screen? That's kind of the question we're going to be asking there. Then we're going to jump into creating interactive user interfaces. We're going to start actually putting different UI elements together and receiving input from those elements. So specifically, we'll look at how to define and interact UI elements. And then just at the end, we're going to do a little bit of an overview on just how to start testing on a real Android device. So this would be useful maybe if you want to actually show an app off to friends and family, if you want to just see what it's actually like to interact with the app you're building, or maybe you just want to try and see if a real device is faster for testing than an emulator is. All of those are great use cases, and we'll get in specifically on how to start doing that. So as we start off here, we want to frame this question of kind of what goes into an Android app. And a great place to start for this is to start with the Android framework components. And the question to keep in mind for this is, what are the building blocks of an Android app? So before we even get that far, maybe take a step back. Let's think about, what is Android? Well, Android is a multi-user Linux-based operating system for mobile devices. These include phones, tablets, Chromebooks, watches, TVs, IoT devices, cars. The Android runs in a huge variety of different types of devices. Now, Android apps all run in their own Linux process, and each process has a unique virtual machine to keep it isolated from other apps. So this is one way in which Android apps really try and secure themselves. They run in their own virtual machine so that they're isolated from one another, and then there are very clearly defined boundaries and mechanisms for sharing information between apps. And now when we spin up a virtual machine, a process is created anytime an Android component needs to be run. So anytime an Android app is run, that process is going to be contained within a virtual machine, and that process will be created in response so that one of the Android app components can run. So what are the Android app components? Well, you can think of these as the core foundational building blocks of an Android app. These are the things that really can trigger your application to start running. So first off, we have an activity. Now, we saw an activity last week, although we didn't talk about it in too much depth. But an activity is a class that represents what is on the screen, and it is an entry point for user interaction. So an activity is really something that's on the screen that users can interact with. You can display information to users. It has that interactive and visual element to it. A service is the next Android app component. Now, a service does not include any type of user interface to it. And services are really there to enable us to do long-running tasks that need to run in the background. So a great example for this is downloading a movie, for example, or any other large file. Typically, we might kick off a download and then move on to some other app, or even just turn our phone screen off while we go about our business. In situations like that, we don't have any UI present anymore, but we want that download to continue running in the background. That's where a service comes in. The next Android app component is a broadcast receiver. Broadcast receivers enable sort of messaging across components and applications and the operating system. They enable the operating system to deliver those event messages and inform our applications that it's time to respond to certain events. So this could be a connectivity change event. Maybe the Wi-Fi comes back on. We can respond to that. This could be for an event like a new contact being added or something, or a new notification coming in, and we need to respond to that. There's lots of different types of messages that we can register for and then respond to using a broadcast receiver. And once again, I'll just call out, broadcast receiver doesn't include any type of user interface. If we needed to respond to some type of message with the user interface, it would likely go through a broadcast receiver, and the broadcast receiver would then tell us how to launch an activity, which would then contain some user interface. And now the last app component is a content provider. Now, a content provider is a class that manages app data shared with other apps. So again, this doesn't include any type of user interface, and it's really here to define clear boundaries for how data can be shared from one app to another. How these components can work together, and a little bit about their responsibilities. Now, these components can communicate with one another, and this communication generally happens using an intent. An intent enables communication between activities, services, and broadcast receivers. Intents can specify a specific component, such as a specific activity in your application. An intent can also specify a general action that it wants to take. You could create an intent, for example, to send an email, and the operating system will then choose from a variety of options, all of which can handle that email. That's why sometimes if you try to share a message, for example, or share a link, you might get a lot of different apps that you could share that through. That's because those all know how to handle the email intent, or maybe a link intent. You can also put sort of somewhat arbitrary data within an intent, and this is particularly useful for messaging between, let's say, an activity and another activity, or an activity and a service, because you might need to pass an identifier around, or some type of result code. This type of communication specifically, we will get into in this course. Now, the next thing you want to take a look at here is the Android manifest. And if the Android manifest sounds familiar, that's because we have an Android manifest in the application we created last week. Now, what exactly does an Android manifest do for us? Well, an app's manifest is responsible for registering core components with the operating system. So any of those components we just talked about, content provider, broadcast receiver, activity, service, those all have to be registered in the manifest so that the operating system knows about them. If the operating system doesn't know about them, then it can't route messages to them. It can't instantiate them properly when it needs to. Essentially, your app will not run properly if those components are not registered. So the Android manifest is very, very important. The manifest also serves a couple other purposes. It allows us to identify what permissions our app is going to require. It allows us to declare certain specific types of hardware features that we might need for our app as well. We also can use the manifest to define certain deep links that our app is responsible for. And if you're not familiar with a deep link, think of it basically as a URL that you want your app to respond to. And so if you register that deep link, your app then knows which activity to run in response to that link being clicked, or what service or something to kick off. So the manifest does a lot of things for us, and we are going to explore exactly what is in the manifest of the project we created a little bit later in this week's lecture. Now, just for a quick overview here too, here is an Android manifest example. So the manifest is defined using XML. That XML typically has a kind of a top level manifest tag followed by an application tag. Within the application tag, we'll see things like app icon or app title. We'll look at those later in our demo. But then you can see here an example of an activity being registered in the manifest. In this example, the activity is called example activity, and we can provide a label to it, which is the label that might get displayed in the task switcher or in the toolbar when you run your activity. Now, similarly, like I mentioned, you can define a service or a receiver or a content provider. And these are just small examples of what tags you would use to define all of those within the manifest. So an Android app then could be defined as a combination of app components that receive events from the system, communicate with one another in a secure fashion, and include some type of interactive user elements. Those types of elements are essentially what we see and work with on a daily basis when we use any app. All of the other stuff, the communication, the messaging, all of that type of stuff is really happening in the background and is hopefully pretty transparent. We don't want our users typically to know how things are working in the background. So if we build our apps in the right way, all they have to care about is the nice user experience that we're hopefully providing to them. Now, so as we mentioned a little bit previously, in an Android app, the activities are responsible for what you see on the screen and what the user interacts with. We saw this last week in our example. We had a main activity, and that activity had a layout within it. And in that layout, we had a text element that said, "Hello 8340." That's generally how that process works for getting something from an activity onto the screen. Now, any activity must define a layout, and that layout can contain really any number of layout containers and views. Now, views could be things like buttons, text, a toggle, a progress bar, something custom that you build for your specific application, anything that really can be drawn to the screen. Now, an app can also have any number of activities and can transition between those activities as needed. So we don't have to build our entire application within a single activity. And in fact, you generally want to think about how you can break things up. You might have very specific entry points into your application. Maybe you have a browse experience and an edit experience. You might want those to be in separate activities because you might be able to jump straight into editing if you click on a specific deep link, for example. So it's a good idea to think about conceptually, how could you break a task down or break some functionality down and group it into activities or other types of logical containers that we'll get into throughout the course of this course. Okay, so now we have a basic understanding of the core Android app components, how those are registered in the Android manifest, and a little bit of their responsibilities and how the Android operating system can route messages to those components, and then how ultimately we can use an activity to actually show something on the screen and interact with our users. So now that we have a little bit of this fundamental understanding, let's think about reviewing the project that we created last week. So specifically, what was generated in our new project? And how do those files and classes and resources all work together to basically build the application that you submitted in your homework assignment? So a few of the things that we're going to look at here, and hopefully some of these maybe jog your memory and seem a little familiar from what you were working with last week. So we're going to look at main activity and also activity_main.xml. We're then going to review the project structure a little bit and see a little bit more closely how we can view these files. We're going to review the Android manifest for our app. Then we're going to look at our strings XML file, colors, styles, and we'll also look at a build.gradle file. And these Gradle files are kind of the build configuration for our project and help the Android tooling compose everything together and spit out the APK file that you submitted as part of the homework assignment. So real quick, the main activity is what we're seeing on our screen. The activity_main XML defines the layout. Set content view is a method on the activity that sets the layout into the activity, and then main activity is declared in the Android manifest. Now, if that all sounds a little abstract, that's okay, because we're going to jump over to Android Studio. There we go. So let's kind of run through that one more time, but this time we can look more specifically at the code. So like we said, we have our main activity. And this is the same main activity that we saw last week. So main activity here is a class, and it extends app_compat activity. So in this sense, we're thinking object-oriented programming here. Main activity inherits everything from app_compat activity, and then we can override certain methods to customize the functionality. So in main activity, we are overriding the onCreate method. Now, onCreate is an activity lifecycle method, and we're going to talk more specifically about the activity lifecycle in a little bit. But in this case, onCreate is the perfect place for us to define the layout XML of our app. So like I mentioned, we call set content view. and you have to pass a layout file into set content view. So in our case, our.layout.activityMain represents the layout that we want to use for this. Now let's talk quickly about the syntax here. R basically is a generated class. R stands for resources. Layout is meaning that this is a layout resource. And then this is the specific identifier. So if we click into activity main here, we'll see over here on the left hand side of the screen in my project window, I have this layout directory. And as I expand that, I see the activity_main XML is within that layout directory. So that's why we end up with this very specific convention for referencing our layout resources, as well as any other types of resources. And again, we'll see examples of that down below. But so if we had a string, it would be r.string and then the name of the string resource. If we had a color, it's r.color and the name of the resource. So here we have activity main. And if I come over here to my XML version of this, we see just what we saw last week. We see a text view here, and back over in our blueprint view here, or the design view, we see that we have this single line of text outputted to our screen. And if we were to deploy this, as you all know from the homework assignment, we would see this text printed out to our screen. So now that's how we get the element defined by the activity. Now to actually get the activity onto the screen and registered by the operating system, we have to register it in the manifest like we talked about. So if we look at our app here again, under the source directory, we come down here into source main, and right here we see Android manifest.xml. This is the common convention. Within any type of app directory, you have the module. In this case, we have a single module called app, and it's always under source, main, and then Android manifest.xml. So if we open up our specific manifest from this homework assignment, we see our top level manifest property here. We then see the application tag. And like I mentioned, we can define a number of things here. We have an icon. This is the icon that you actually would see in your app launcher when you go to actually open up an app. We have the app label. This is the app name when you would see it in your apps launcher. We have some other properties here like round icon, supports RTL. This stands for supports right to left. And this is for locales that read from right to left. And then we have an app theme. We'll mention a little bit more of the app theme later, but if we quickly kind of open up the app theme, a theme is just another resource type here. See here, this theme is defined in the styles.xml file. And basically we define a new style called app theme. It inherits from this predefined app compat theme. This is a great starting point. We're not going to get too much into the theming this week, but app compat basically is a series of libraries, resources that help make sure your app looks great on all different versions of Android. The key thing I want to point out here, because it will be a part of the homework assignment this week, is that we have 3 different colors defined in here. These colors are color primary dark, and color accent. And as you tweak these, your app will begin to look different. So now we go back over to our Android manifest here, and we see that we have registered our activity using this activity element. We've provided the name, which in this case is just .main activity. We could fully qualify this by saying com.goobar.io and provide the full name here. However, that is not typically necessary if you're only really dealing with like one module or one grouping of files. So if you want to just leave it as .main activity, that should be perfectly fine. And now the last thing I want to point out here is this intent filter. Intent filters are a means of sort of signaling to the system that, hey, I handle certain types of actions. This is one of those things where if you're sending a message out that says, how do I handle sending a tweet? You might define an intent filter that helps you say to the operating system, hey, I know how to handle that. So in this case, we have a very special intent filter applied. We have an action of main and a category of launcher. These basically define the entry point into your app. So whatever activity has this specific intent filter will be the activity that the operating system starts when it launches your activity from the app launcher. And so just a little bit more on that. So like I mentioned, intent filter is included to indicate what activity to start on launch. Intent filters describe categories, actions, basically things that can be handled by the specific component that the intent filter is registered to. And then we saw that the title, icon, and theme are all defined in the manifest for the application. So now let's review the project structure a little bit. So we'll go back over to Android Studio. And the first thing I just want to call out is, again, the project window over here on the left-hand side. So you see right now I have this in this dropdown, I have this marked to project. And the way this is laid out right here, these files, the resource, everything, this is exactly how it looks on the file system. So if you open up a new file browser, you would see in your application directory, everything laid out exactly the same way. And so if I go into this again, like we saw before, within the app module here, or the app directory, I see this structure. I see a build, I see libs. Most importantly, I see source. And if I continue to scroll down in this, I see source, I see main, Java, and then eventually I see my class, my main activity in this case. I also see my resources in here. And you can see we have multiple sort of directories. So for example, we have mitmap HDPI, mitmap MDPI, mitmap XHDPI. These are basically specific resource directories for different resolutions of screen. And I point these out specifically because this is one of the key differences between this and the Android project view. So if I come back up here to the dropdown and I scroll to the bottom and I click Android, this is going to reorganize how all these files are presented. They're still organized the same way on the file system, but they're organized differently here on the left-hand side. So the first thing you might notice is we have this folder here specifically for manifests. So it shows us all the manifests present currently in this project. You also notice here we have res. So this is the resources. It pulls those resources up and makes them easier to find. And now notice here, instead of having 4 or 5 different mitmap folders, we have a single mitmap folder. And if you drop that down, we'll see that it kind of consolidates all of them. So instead of having IC launcher PNG defined in 5 different directories that we have to look through, it kind of includes them all into a single place here that we can view a little bit more easily. And we can see that they're all related to one another. Now, similarly, if we want to look for our source code, we can come to the Java directory, which I know is confusing since we're writing in Kotlin, but it's just sort of a historical convention that is still in place. So if we open up Java here, we'll see 3 kind of directories. We see this main one here. We see one called Android test and one just called test. So these are kind of by default the 3 source sets that are created. Now, what is a source set? Basically, a source set is a grouping of files that are compiled together and used for building a specific output. So the main one here, if I drop this down, that includes main activity, this is the main source set. And this is what is used to build the APK that we used for the homework. Android test, this is where we would write any test code that is very specific to the Android framework. Now, we're not going to get too much into testing in this course, probably a little bit later. But for now, I just wanted you to recognize what this is for. And then similarly, the test source set, or the test directory in this case, is for unit tests. And if you're not familiar, unit test is just a small test that basically is independent of the framework. So a unit test wouldn't have to know anything about Android, Android tests are where we would write larger tests like what is on the screen or how are my activities transitioning from one another. So we'll get more into testing and the testing pyramid and stuff later, like I mentioned. But for now, the key thing is to notice that we just have the different source sets. And just to call this out one more time, like I mentioned, we have the main source set, Android test, and test. And if we switch this back to our project view, we can see what that looks like. So again, we are in our root level directory here. We expand that. We go to the app module and go to source. And we'll see we have Android test, main, and test. And then if we were to expand the main, eventually, like I said, we find main activity. So this is just a little bit how Android Studio can give you different options for how to present your files. If you find yourself getting overwhelmed with all the different files available to you when you have the project view open, maybe try switching over to the Android view. If you are getting confused because the Android view kind of moves things around, feel free to use the project view. They're both valid. I use them interchangeably throughout my work as an Android developer, and I think they both serve their purposes. Specifically, I think the Android view is really good when working with resources in particular. Yes. So one more thing that I wanted to point out too. So whoops. If we come back over here into Android Studio real quick, I wanted to look at the resources more closely. So if I open up the res directory again here, I'll see different types of resource directories. First, we see drawable. Drawables represent things that can unsurprisingly be drawn to the screen. So this could be an icon. This could be an image. This could potentially be some type of animated GIF or something. Drawables can be used in a number of ways. They could be used in an image view, like we'll see later in the lecture. They also could be used for background of a particular view or view group. Now we've seen the layouts. This is where we define a layout for an activity, and that gets drawn to the screen. Mipmap we saw, this is a special image type, basically reserved only for launcher icons. So we won't really do much with this in this course. I might do a little bonus lecture at some point showing you how to customize your app icon if you want, but not overly exciting there. The last one that is more interesting is the values directory. So if we expand this, we'll see 3 different XML files. If we open up colors XML, this is where we define the colors that we were using in our app theme. And if you click on one of the little color swatches kind of in the left-hand gutter here, you can actually play around and choose a different color. They also have some predefined colors based on material design, and you can come and select one of those and just kind of pick from that palette and use it to customize how your app is going to look. And in fact, this is part of the homework assignment. We'll see it in the week 2 app assignment specification, but I'm going to ask you to come in here and customize the look of your app by changing these colors for your app theme. Now the next file here is strings.xml. Now, some of you asked last week about hard coding strings, and I mentioned that typically we don't want to hard code strings for things that are user facing. This is where we would define those types of strings. By defining a string resource, it lets us do a couple of things. It means we can change the resource, or we can change the value of the string based on app configuration. So this could be things like orientation. This could be things like language or locale. Configurations in Android are basically a whole bunch of different things, like whether your app has a keyboard, like I mentioned, the orientation, whether certain functionality is present or whatnot. And we can respond to those and change the look and feel of our app by defining different resources for those configurations. So for strings, the big one is localization and translation. So if we have our app and we wanted to release our app in Spanish, we could define another strings.xml file specifically for the Spanish locale. Then we could define a resource still called app name, but it would contain the translation of our app name for Spanish. Then when our app is run, it can detect what locale it's in and it'll load the proper resource. So this type of configuration is really important. You can use it for dimensions, sizing of things, of text and view elements. You can use it for layouts. You can use it for colors, strings, really any type of resource file can take advantage of that type of configuration. And we will get into that later. And then finally, we already saw this one again, but styles.xml, this is where you can define your styles and your themes. I mentioned we have a lecture later in the quarter, more specific to kind of styles and themes, but basically you can apply a style or a theme to different views or your application as a whole, and it just changed the look and feel of all of the widgets and how they look by default. So we'll go back over to our notes here. So like I said, we already kind of covered Android versus project view. Both represent your project's files, source code, build files, resources, etc. The project view displays it exactly as it appears on disk. Android view consolidates and reorganizes to match how Android Studio thinks about the project. We saw about our source sets. We had our main source set. This is where we're going to be working most of our time. It's where our main activity is currently defined, and this is what will be bundled by default when we create our APKs. We have the test source set specific for unit testing, and we have our Android test source set specific for Android instrumentation tests. Now, you don't need to really worry too much about tests or Android test right now, but I just wanted to point that out so you have an idea of what those directories are doing when you see them in your project. Now, we also saw the difference between kind of the Java and the res directories. The Java directory was kind of the root level for all of our Java and Kotlin files. And then the res directory was where we put all of our Android resources like layouts, colors, and dimensions. And then we just saw we have the different directory types. We have drawable resources, layout resource, and then value resource directories. And within that values resource directory, that's where we can define things like strings, colors, dimensions, styles, etc. Like we saw, we can define any user visible strings here as string resources. We can then reference those strings elsewhere in our code, and that lets us support localization and configuration changes when something about our app changes, whether that be the defined locale for the app, the orientation, etc. Dimens.xml. This one, I don't think we actually saw this one in the example. So we can come back over to Android Studio real quick. So if we right click on the values directory here on our left side of the screen in the project pane, if we right click on that, we can click new values resource file. Then we'll call that dimens, specifically dimens, which is short for dimensions. And then we'll hit OK. So this creates a resources XML element for us, basically. Now within that, we can define dimensions. So we can do that by typing kind of open bracket dimen, name, and then you might define a dimension for something like title text height. And then you might set that to something like 18 SP. So 18 SP roughly translates conceptually to a 18-point font if you're in, let's say, Microsoft Word. The SP is something a little bit specific. It stands for scale independent pixels. We're going to talk more about that later in the lecture. But this is basically how you could define dimension resources in your resource value folder. So we could then use this title text height to define the size of our text. So if we were to go over to our activity main here, if we came to our text view that we used before, we could change this text size property and set it to that new title text height value that we just defined. And so now our text would be 18 SP, which likely is a bit bigger than default. So here probably might be hard to tell on the recording, but this is definitely a bit bigger than it was before. No. And then colors and styles we've covered a couple times now, but you can define reusable colors and styles for our views and our application. Now there's a couple other files that I want to point out before we move on from kind of reviewing what was in our project. And that is the build.gradle files. And there's actually two of them. We have one at the root level of our project, and we have another one at the app level of our project. So I want to jump over back to Android Studio once again and point those out. So if you are in the Android view here, you'll see that it actually separates out your Gradle scripts into a separate dropdown. And so we can see the two different scripts are here at the top. We have this one that says project : 8340. So this is the root level script that controls configuration for the project as a whole. A Gradle project, which is, let me take a step back. Gradle is a build system, and it's the build system that Android uses to build everything. And what do I mean by build everything? I mean basically take all of the code from all the different directories, all the resources, and it knows how to compile and package them all together and make them into a usable format. In our case, an APK typically. So the project level one lets us configure how all the different sort of modules and directories compile their code together. Now, what is a module? Well, our app folder is a module. It's essentially a grouping of code and functionality. Now, you could have many modules. You might have a module for authentication, a module for your your editing screen and for every different feature, or you can have a single module for everything. The discussion around when and how to modularize is well beyond the scope of this course, so we're going to have a single module for now. But for that one module, in this case our app module, we also have a build.gradle file. This one is much more interesting. So in this one, we are configuring some Android specific things here, like our compile SDK version, the version of our build tools, the application ID, our min and target SDK version. And then down here at the bottom in our apps build.gradle file, this is also where we define new dependencies. And I think it's going to be in week 4, that we'll actually start adding new dependencies to this. But we can see here by our default, our app already has some dependencies pulled in. So we already have a dependency on the Kotlin standard library. We have a dependency on app compat and constraint layout. So these are things that just by default Android Studio brings in because they're so essential. Now, like I said, this is the Android view. This is where those files are located if you're using the Android dropdown here. I want to go back over to the project dropdown and just show that as well. So you see if I have my root level directory here collapsed, you can't see any of them. As soon as I open that up, we'll see the root level directory's build.gradle file is visible. And that's this one here that has less in it. Then if I expand app, I'll see the app level build.gradle file. So the build.gradle file, whether it's in a module or the project as a whole, it's always sort of like one level below that top directory. Okay, now we're going to dive in and we're going to talk a little bit more specifically about activities. And we're going to get into the activity lifecycle, which is a very important concept in Android development. So we're going to look at a couple kind of key questions here. How is an activity defined? We've actually already seen the answer to this as we have been exploring what is created for us in our existing Android project. We're then going to answer the question, how do we specify the UI for an activity? And again, we've really already seen this as well, as we've seen that call to set content view and we pass in a layout resource. And then finally, what is the activity lifecycle? Well, the activity lifecycle looks something like this. And if that looks a little bit intimidating to you, that is perfectly understandable. Quite frankly, it is still very intimidating to me and to other professional Android developers at times. So essentially what this is describing to us is kind of the the setup and initialization process of an activity, the teardown and destruction process of an activity, and then there's sort of a secondary loop of how an activity can be restarted in the case where it's maybe put into the background and then brought back into the foreground. So this is roughly the full activity lifecycle. There's actually a little bit more to this even, but it's rarely that relevant to developers. And even what we see right here is more complicated than we need to worry about most of the time. So for us right now, we're going to simplify our life cycle a little bit more. And we're going to look at these 6 life cycle methods. And really you can think of these as 3 setup methods and then 3 sort of converse teardown methods. So the life cycle that we care about starts with onCreate. And now we've seen onCreate in our main activity that we created last week already. So onCreate is essentially signifies that this activity is created, but it's not yet active on the screen. So this is where we set our layout, for example, and we have to set our layout before it's active on the screen. Otherwise, it wouldn't know how to draw anything to the screen. The next method that we care about is onStart. So this means that the activity is visible on the screen, and yet it's not quite ready to receive focus or interaction. So something could be started, but have something else over the top of it, and meaning you can't quite interact with the activity. Now, typically activities aren't going to be in the started state for very long. Usually onStart will be called, and then very quickly onResume is called. And onResume means the activity is visible and it's active in the app foreground. So when you open up YouTube, for example, and you are watching a video, it's in the resumed state. Now, conversely, when an app is put into the background, say because you turn off your phone, or you switch apps, or you pull open the task switcher, any number of things that might cause something else to become active on your screen can trigger some of these other lifecycle methods in more of the reverse process. So when an activity is visible, but something else has taken the foreground priority from it, that means that onPause has been called. And onPause is kind of the reverse here of onResume. Similarly, onStop is the reverse of onStart. So this means that the activity is no longer even on the screen. And then finally, onDestroy is essentially the opposite of onCreate. This means that the activity is about to be destroyed, either because the user navigated away from it and it's no longer needed, or because the operating system needed to reclaim resources. And so we need to handle these states as application developers so that the operating system can sort of instantiate and set up our activities for us, and so they can tear them down when needed. And the operating system can really do this whenever it needs to. Typically, if your app is in the foreground, it's not going to destroy your app for you because the user is actively using it. But if you put your app into the background by, let's say, opening another app, the operating system might destroy that old activity that is now in the background to free up more resources for the operating system and for the phone. So we need to make sure that we handle the onPause, onStop, onDestroy, and then onCreate, onStart, onResume, so that when we bring that app back into the foreground by clicking on it from the task switcher or from the app icon again, it can refresh that old state and bring it back to where we last had it. So before we jump on anymore, I want to open up Android Studio again and go over to main activity one more time and just kind of walk through this in code as well to give you an example or a more sort of visual example of what we're talking about here. So we saw onCreate is kind of the first method that we care about there. Now, if we start typing onStart and we hit enter, we can override onStart. So this would be the next method that we really care about here. Next, if we want to do onResume, once again, we can come here. We can start typing onResume, and it should sort of highlight that method for us and automatically override it if we hit enter. So now after on resume, our activity would be active and receiving user interaction in the foreground. Now kind of the reverse order. We could say override fun on pause. So you see in this case, I fully typed it out on my own, which is perfectly fine too. Or let the IDE sort of autocomplete for you. Notice in this case, there is this little red squiggling line here. Might be a little bit hard to read, but basically it says overriding method should call super.onPause. So notice that in the other overridden methods here, there's always this call to super dot and then whatever the name. So in onCreate, super.onCreate is called. In onStart, super.onStart is called. What that super call is saying is it's calling through to the implementation provided by the parent class. So going back a little bit again, we've talked a couple times about how in this case, main activity here is extending app_compat activity. App_compat activity is an activity provided through Google that takes care of a lot of boilerplate standard code for us. If we really quickly just kind of click over to that implementation, we see here that this is actually quite a large file. Over 600 lines of code go into this. And so we can make use of that code without having to write it ourselves by just calling super and then whatever relevant method. So we need to make sure that we do that so that these lifecycle processes work correctly. So here in onPause, I'll go ahead and type super.onPause. And now I'll finish this off by adding the onStop method and finally onDestroy. So now we have our methods present here, and we can kind of walk through these processes. And just to kind of illustrate this a little bit more, I will do something here. Region, call this setup methods. And then down here, end region setup methods. And then now we can do region teardown methods. And then one last thing, end region tear down methods. So these are just comments that I've added, and they don't really do anything for us functionally. They're just here to kind of illustrate this. One small Android Studio tip while we're here, if you do write comments in this pattern, so with the 2 forward slashes, a space, and then region, you can actually collapse those regions. And then Android Studio will sort of highlight that as a kind of a contiguous block of code or comments. So it can kind of be nice for organizing code sometimes. So I'm going to expand my my setup methods here. Go ahead and expand the teardown too. Now the next thing I want to do is actually kind of walk through that lifecycle and show you actually what is happening as our app is running. And to do that, we want to talk a little bit about the debugger built into Android Studio. So go back over to our slides. The debugger helps you locate and diagnose problems in your application. It allows you to suspend the running of your app at a specific point and then walk through the execution of your code step by step. So when we're running our apps, we have many instructions that are all being run very quickly one after the other. The debugger basically lets us put a pause on that and run those one at a time and let us inspect the output. We can see what the value of a variable is. We can see what the calculation or see what the result of a calculation is so that we can better understand what's happening in our code. Now, to make this work, to get it to stop at those specific points, we use something called a breakpoint. A breakpoint is a line of code at which the debugger will suspend execution of your code. And we will set a breakpoint in different activity lifecycle methods right now to let us stop in each method and kind of see how that process plays out in Android Studio. So once again, we'll go back over to Android Studio. So how can we then set a breakpoint in our application? Well, you can set a breakpoint
by coming into the editor view here. So the editor view is where we have our code here, main activity. And kind of in just to the left here, where we have this sort of vertical line, we can click in this space here, sometimes referred to as the gutter. We can click on that space and we can basically create a breakpoint. This little red circle signifies that a breakpoint has been set at this point. So at this point, I now have a breakpoint added to onCreate. I'm going to come down here and click just to the left here in onStart. Again here in onResume. And then I'll do onPause, onStop, and onDestroy as well. So now we have breakpoints attached to our code. The next step is to basically start the debugger so that we can run through this. So there's a couple different ways you can start the debugger. The easiest way is to come up into Android Studio here, and there should be an icon probably to the right of the little green arrow a little bit. And if you hover over this one that looks like a bug, it should say Debug App. Up to the Run menu and also select Debug App. Menu and also select Debug App. So we'll go ahead and click Debug App. I'm going to start running our code on the emulator or a real device if you have it, whatever device you're wanting to run on. And it will, give me 1 second here to pull up Android Studio or my emulator. There we go. There we go. So you see, it started installing the app to my emulator here on the left-hand side of the screen. And then now over here in Android Studio, it has stopped running the execution. Notice that nothing has happened on the screen. It's just blank. That's because our app has stopped running here in onCreate. And you can see that it's kind of highlighted this line of code over here as well in onCreate. And also take a look at our bottom window here. So we should see this little debug tool window is now open and active. Well, notice in the bottom left hand, we can see a number of method names here. So we have onCreate on the top, perform create, and it kind of goes on and on. This is the stack trace. This essentially shows all of the methods that have been called leading to this point. Now to move on to the next breakpoint, what we can simply do is click this little green arrow here in the left hand side of this debug tool window. This says resume program. So now I've clicked resume program, and it's go ahead and start running again as normally until it hits the next breakpoint. So in our case, it's now come here and it has now hit our breakpoint and on start. And so if we go back down here again to our stack trace, we'll see, oh yes, on start was called. Over here on the right hand side in this larger window, we see this single line here that says this equals main activity. This is our inspector view. This is where you can check the value of variables and what the current state of your application is. I'm not going to get too far into this at the moment, but basically if you expand that, you can check on the actual state and value. So you can, for example, see the resumed variable on our activity is in the false state, which makes sense because we have not yet resumed running of our activity. And so now we'll go ahead and hit resume again. And so now we have stopped in the resume state. And finally, if I hit resume run one more time, we'll see that my activity here is now fully active on the screen. Now, what will go ahead and trigger the reverse process? Well, if I click kind of the home button here to go back to the home screen of my app, we'll see that that has now triggered on pause, which makes sense because the activity is no longer visible on the screen. If I hit resume, it's going to show that on stop has now been called as well. because the activity is no longer visible on the screen. And one more time, if I click resume, nothing else happens. Notice that onDestroy was not called. So this gets back into what I talked about before. When something goes off the screen, onPause and onStop are called, but the activity isn't necessarily destroyed right away. It's still active in the background. If I, in my emulator, kind of pull up the task switcher here, you see that my activity is still right here. And if I click on this again, it's going to call onStart again. And then if I hit resume, it'll call onResume again. So again, notice there, when I brought it back, it didn't start from onCreate because it hadn't been destroyed. Now, if instead of just putting the app in the background, let's say I actually kill the application. So first I'll need to let this run so that I can interact with the screen again. So I've called onPause, I've called onStop. Now, if I swipe this away, the app should now have been killed. But at that point, it's hard to actually test the onDestroy because the app was killed. So it's no longer active. So once again, if we go ahead and click debug app, we'll just kind of walk through that one more time very quickly. So we see onCreate is called, then onStart, then onResume. Then if we go ahead and kind of pause this, see onPause and onStop, and I can go ahead and swipe this away, and now my activity is destroyed and no longer available to us. So that's just sort of the general outline of the setup and teardown process. Now, where this will really become relevant down the line is if you need to sort of initialize certain things, you need to grab references to a view, maybe you need to start loading tasks for some data. You're going to do all that stuff as the activity is starting, and then you'll want to make sure that you clean any of that stuff up when the activity is being destroyed. If you don't, you can run into what are known as memory leaks. Essentially, you can leak the activity and all the memory it needs to run. And memory leaks lead to really poor performance. They chew up system resources that are not really needed. And eventually they can start to slow down your phone until those things eventually get cleaned up by the system. But that can often take quite some time. So you want to avoid memory leaks whenever possible. Okay, so now that we understand how to get a layout onto the screen with our activity, we understand a little bit about the activity lifecycle. Let's start thinking about how we can actually create interactive user interfaces. And to do that, the first thing we need to do is just start exploring what the different types of view elements are that we can put into our layouts. And so there's really three main types of view elements that we can think about. So the first one is a view group. A view group contains other types of views, and a view group can define how those views should be drawn on screen in relation to one another. So you can think of a view group as a container for other views. Now, a view is a self-contained element that can be drawn to the screen. A view could be something like a button, a text view, a progress bar, an edit text. A view can also just be simply a generic view that just knows how to draw, let's say, a colored rectangle to the screen. And then finally, we can actually define our own custom views. So we can extend the view class and define our own behavior that controls how something gets drawn to the screen. And by combining these types of view groups and views, that essentially builds up the user interfaces that we're used to working with in all of our mobile apps. So we're going to start by taking a look at view groups here. And there's really 5 main view groups that we'll talk about, although through the course of this quarter, we'll likely be using only 1 or 2 of them a lot. But so the first one here is a frame layout. We'll talk about linear layout, relative layout, constraint layout, and then finally coordinator layout. So the first one here that we'll talk a little bit about is frame layout. This is probably the most simple of all the view groups. There's no special ordering of views within a frame layout. Basically, anything you put into a frame layout is going to stack on top of one another, and they're just going to be laid out from the top left by default. This is great when you don't need any complicated ordering or laying out of the child views. Maybe you just have one element that you want to fill the whole screen. A frame layout is a great option for how to put that a view on the screen. And so we'll go over to Android Studio here, and I just want to try and demonstrate what some of these view groups actually do for us. So if we go into our main activity here, and then we're going to open up activity main by shift clicking on it, or excuse me, by command clicking on it on a Mac, and I think it's control click on Windows. I've now opened up activity main. Now, if we go into the XML view here, we can see at the top level, we have a constraint layout view group. That's what Android Studio generates by default. And we will talk about that in a few minutes here, but I want to start off by replacing this with a frame layout. Whoops, I clicked the wrong thing there. Frame layout. There we go. And I will need to make sure I update the closing tag as well. Frame layout. All right, excellent. So now if I come back into my design view, I'll see that the text view that was previously centered nicely in the middle based on the constraint layout, it's now placed in the upper left corner here. And that's what I was getting at before. Frame layout doesn't have any special ordering. So if you don't tell it how to lay out within its parent, it's just going to hang out in the upper left corner. And so now if we were to actually add, let's say another text view, and when you add a new element, the first thing you have to make sure you add are the layout width and layout height so that it knows how to draw it. Now I'll just update the text on this, and I'll just say some text here. I'll close this out. Now if we go back over to our design view, we'll see that those text elements are now overlapping each other. So this illustrates the point of a frame layout. It doesn't do anything special unless you explicitly tell it to. So if we come back over into this new text view we added, just for the sake of demonstration, if we wanted to indicate that it should be placed somewhere else on the screen, we could use the layout gravity property. So that's Android:layout_gravity. And we could use center. Now that second text view element is centered in the screen. So frame layouts still support things being moved around from the upper left corner. You just have to explicitly tell the layout where things should go using the layout gravity property. And so this is useful if you have a very small number of elements, but very quickly falls apart if you need complex ordering of elements in relation to one another. So that brings us then to linear layout. In a linear layout, child views are laid out one after the other in either vertical or horizontal orientation. And these are really common and really great for simple UI. So let's jump back over to Android Studio. We're going to go back into our XML view here. And so now we're going to replace frame layout with a linear layout. And good, the bottom one has been updated for us. So there's one key thing we need to make sure we do with a linear layout. We need to make sure we specify the orientation so that it knows that we want to lay out the elements either horizontally or vertically. We can do that by starting to type orientation, and we'll see that it suggests the Android:orientation property here, and it gives us two options, horizontal or vertical. So in this case, I want to choose vertical. Now, if we come over to our design view here, we'll see that these two text views are now laid out one after the other from the start of the screen. However, there's still a little bit of difference there. We see that our some text here text view is still centered in the middle of the screen, even if vertically it is still right under that. That's because of that property that we added before. So we can start to layer these things. Layout gravity on a child view still can indicate in some sense to the view group how I want it to be laid out. So in this case, this text view is saying I want to be in the center both vertically and horizontally. The linear layout is saying, well, I am going to lay you out vertically based on my own specification, but I will go ahead and honor your request to be centered horizontally. So if we actually remove this layout gravity element here and go back to our design view, we'll see once again, now the text is starting off from the left. So this is again the default behavior, starting things from the upper left. If we come back to that element, we add layout gravity back and maybe this time choose end, and we go back over to our design view. Now this time it's on the far right hand side of the screen. So this is how we can start to define more interesting behaviors here by combining view group layouts and layout gravity on our child elements. And then just for one last demonstration here, we'll change the linear layout orientation from vertical to horizontal. And we'll see here, now they're being laid out one after another along the same horizontal axis. And that's pretty much it for the moment with linear layout. Like I said, this is a very useful one and is something you'll likely want to take advantage of during this quarter. So now the next one we're going to use here is relative layout. Now relative layout is extremely useful. It's very powerful. There is sort of a newer view group that offers a lot of the same benefits, but with better performance. So we might not use a lot of relative layout in this course, but it is a very popular choice. So I do definitely want to cover it. And basically the point of a relative layout, before I move on, is that child views are laid out relative to either the parent view group or other sibling views. So again, back over to Android Studio, back to our XML here. We're going to start by just kind of clearing out the layout gravity property, all of these constraint properties, and also the linear layout orientation, just because those things aren't going to be relevant here. So now we'll replace linear layout with relative layout. And if we go over here to our design view again, we'll see it looks very similar to the frame layout at the moment. Everything is just starting in the upper left corner. Well, this is because it doesn't know how to lay things out relative to the parent or the other views. And so by default, it just leaves them in that upper left corner. So let's start adding some constraints here. So in our first text view, we could tell this thing to lay out align parent. And let's say we wanted to align this to the parent end. So we could use Android : layout align parent end equals true. If we go back over to our design view, we'll now see that that has been shifted over to the right hand side of the screen. Now let's say we wanted to put them on the bottom right hand side of the screen. We could say layout align parent bottom equals true. So now that view is going to be aligned to the bottom and to the right hand side of that parent. Now if we come back and let's go to maybe our second view here, we have some choices if we want to center it. We could choose to center horizontal. We could choose to center in parent or center just vertically. So let's choose center in parent. And once again, we'll mark this as true. We'll jump over to our design view. And now we see that that second text view is centered nicely in the parent. Now, what would happen if we wanted to just always place that second view above the first one? Well, this is where relative layout can get pretty powerful. We can actually make that happen quite easily. We can come down here to our second view and we can start typing layout above. And now with layout above, we can pass in a view identifier and it will lay out above that view anytime it can. So the first thing we have to do then is add layout identifiers to our views. And this is actually a pretty common practice and something we will want to do for our homework and moving forward in the course. So to add a view or add an ID to a view, you come within that view tag within the XML, and you can just start typing ID and you'll end up with Android:ID. And then you need to type @+ID/, and in this case, I'll just call this text view1. Now this is kind of a weird syntax. @+ID basically says I'm going to create a new ID, and then everything after the slash is the ID of that view. Now down here, I'm going to do the same thing, and I'm going to call this text view2. Now in layout above, I can reference that ID. So I want to reference the text view1 ID because I want text view2 to always be laid out above it. So here I see @ID/text view1. Now notice in this case, I didn't use the @+ sign. I just said @ID and then the name. So when you're referencing an ID and you don't want to create a new one, you don't need to add the plus. So now I've indicated that text view2 should always be laid out above text view1, but also centered in parent. So it's going to come down here and kind of reconcile those. So see, text view2 is now still centered at least horizontally in the parent, but the layout above is taking precedent in laying that view out above text view1. So you can start to combine these types of constraints and change how those are laid out with one another. So let's say I'm going to get rid of center and parent, and I want to do layout above text view1, but also maybe layout to left of text view1. Now if I come over here, I'll see that my view is now to the left of the first one and above it. And so we have kind of this staggered effect. So these are the types of sort of laying out of views in relation to one another that you can accomplish using relative layout. Now, constraint layout is essentially a more modern alternative to relative layout. And it actually it makes a lot more things possible than what relative layout can do. So it's not a direct comparison, but pretty much anything you can accomplish with relative layout, you can accomplish with constraint layout. And constraint layout in many, many cases is more efficient. And the tooling these days is also built to really work with constraint layout by default. So constraint layout is understandably kind of what Android Studio generated for us automatically. And it's what we will be using a lot of in this course. And so in a constraint layout, child views are laid out based on a pretty complex series of equations. The layout design view is built to work best with constraint layout. So that cool little interactive editor we've been using works really well with constraint layout. And constraint layout, its whole thing is about letting us build very flat view hierarchies. And because of that, also can enable complex animation, and all of these things happen much more efficiently. So let's go back to Android Studio and let's just take an example of constraint layout. So let's just clean this up a little bit. We'll move these layout properties on our two text views. And then we will replace relative layout with constraint layout. So once again, let's look at how this is laid out by default. And again, no surprise, by default, these things are just laid out on the top left-hand side of the screen. Now, in XML, if we wanted to start adding some of these constraint properties, we could just start typing the word constraint, and it should autocomplete some of the different types of constraints we can apply here. Now, it's somewhat confusing when you first get started here because there are so many different types of constraint properties. And so when we're getting started with constraint layout, the actual the best way to really get started is to actually do it from the visual editor here, which is quite nice. So I'm just going to grab text view 2 here, and I'm just going to drag this down here. Now you see, when I have this selected, I have these like 4 little circles. These basically represent, those edges of the bounding rectangle. And so if I want to constrain this so that it's centered in the screen, for example, what I can do is start dragging from one of those circles to different edges of the parent. So you see here, as soon as I grabbed the edge and connected it to the right-hand screen, it snapped to that side. Now, if I come over here and I connect the left-hand side, now it's constrained to both the left and right-hand side, and so it splits the difference and sits in the middle. Similarly, if I connect the top or bottom, now all of a sudden that view is constrained to the center of the parent. Now let's go over to the XML and let's see what that looks like in the XML. So you can see here in the XML, that gets translated into things like layout, constrain the bottom to the bottom of the parent, or constrain the end to the end of the parent, constrain the start to the start of the parent, and top to top of the parent. So this is sort of the general syntax in the XML for constraining things. Now let's go back to our design view. Let's say we want to constrain text view 1 here that says hello 8340. We want to make that always be below some text here. So in this case, I'm going to grab the top circle here of text view 1, and I'm going to connect it to the bottom circle of text view 2. And you see now it's brought that down, and vertically it's always going to be below. And now I could connect that to the parent. And so now it's going to be centered horizontally, but always below that first one. And if we go over to the XML again, we can kind of see that. We constrained the end to the end of the parent. We did layout constraint start to start of parent. So that was the left and right constraints to the left and right edges. And then we said constrain the top of this view to the bottom of, and then we referenced that view ID. So you can constrain these things to the parent or to specific views using those view IDs. Now, if we go back over here, we can start to do some cool things here. Now, because text view 1 is bound to text view 2, it means that if we move text view 2, text view 1 will move with it automatically. So I've selected text view 2, that's our some text here one, and we pull over our property or our attributes panel on the right-hand side of the screen. And in this layout dropdown, we have some controls here for the constraint layout. And I just want to draw your attention to these two sliders. We have a horizontal slider and a vertical slider. Those basically define what are called the bias, vertical bias or horizontal bias. And the bias is a weighting of sort of, do you want to be centered or do you want to be to more one end or the other? So in this case, I can be constrained to the top and bottom, but have a vertical bias. And you see, as I change the vertical bias on some text here, because hello 8340 is connected to it, it moves as well. So it lets us to start doing some pretty interesting things. You see here, hello 8340 is not connected on the horizontal axis. So as I move some text here horizontally, the other one doesn't move. But if I move it vertically, it does. So that's some of the kinds of stuff that constraint layout lets us do. We will talk more in depth about building specific types of layouts with constraint layout, but I just wanted to sort of give you an overview of it and indicate that constraint layout in particular works quite well with this visual editor in the design view, and I recommend starting out with that for sure when playing with constraint layout for the first time. So let's go back over to our notes one more time. Okay, so yeah, that's it. The only other one, I'll back up just a moment. The only other one that we'll talk about a little bit is coordinator layout. Basically, a coordinator layout is a special view group that is mainly used when you have scrolling lists of data. We're going to get into scrolling lists in the next week or two, so it'll come up a little bit more there. But a coordinator basically lets you move certain types of elements on and off the screen in response to scrolls. So it might be something like the app toolbar that hides as you start scrolling and then returns when you scroll in the opposite direction. So coordinator layout is useful, but for like a very specific type of use case. So we won't be using it a ton in this course. Now, we've talked about view groups. Now it's time to talk about some common view types. We've already seen text view in our examples and our homework, but we're also going to talk about button, edit text, and image view. So text view, unsurprisingly, text view displays text on the screen. You can think of it as a simple label. And it can be customized to display complex formatting if needed. So it can be very, very simple, but it can also represent complex things like bold and italics and hyperlinks and things like that. We're not going to go into an example of that because we've been using lots of text view examples already. So we'll move on to the next one. Now the next one is a button. A button is a clickable view that can contain text and supports a click listener for responding to user interaction. So let's go back over to Android Studio, and we're going to go into our XML real quick, and we're actually going to change text view 2 from a text view to a button. And then I will update the ID here to just button 1. And then I will need to change my constraint on text view 1 to button 1. Whoops, excuse me, button 1. All right, so now everything should be constrained properly again. So now notice here that instead of a text view, I have this sort of this rectangle that represents the button. And this is actually interactable. If I deploy this to the emulator, which should take a second. So now I have my button here, and you can see I can actually click this. If I click down, you see there's a little animation and it changes the color. And as soon as I let off the click, it kind of goes back to normal. So this is our first look at anything really interactive on the Android UI. Now, if we go back to our notes here, next thing we'll look at is an edit text. An edit text is a view for entering and receiving user input. And it can be customized for specific input types, such as if you need to enter an email address or a phone number. So once again, we will go back over to Android Studio. And now we will change button to be an edit text. We're just going to leave the ID for now. It's a good idea to match the ID with kind of the type of view to some extent. But for our example, we don't need to worry about that now. So now if I go back to the design view, we'll see once again that view looks quite different. And if I redeploy this back to our emulator again, we'll see now we see this thing that says some text here. But as soon as I click into that, I get this little cursor and I can actually change the text that is in there, and I can type into that as well. So this lets me actually enter in own custom data. We'll be using this later on to enter a zip code, which will be the beginning of our weather app. There we go. And so now the last one we'll take a look at here is the image view. Image views display a type of image or drawable. It can be loaded from an asset, a URL, a resource file. There's a lot of ways we can get an image into an image view. If we go over to Android Studio one more time, we'll go back to our XML. We will change this over to an image view. The text property doesn't really apply here, but what does apply is the source attribute. The source attribute lets us define some type of drawable to set into our image view here. So in this case, I'm going to just pick, I'll pick Icy Launcher because we have that asset. Later on, I'll show you how to kind of create your own drawable or even, import your own. But for now, we'll use our launcher icon and we'll see that we now have this image on the screen. And if we run this, we can see that on our device, I can't click on this. This image view is not interactable by default, although you can add a click listener to it if you want, but we do have that nice image printed out of the screen. For view types, text view, button, edit text, and image view, those are going to be our primary focus for this week. As we move on, we'll add some more complex view types, but those are really some of the core building blocks of any Android application. Okay, so now that we have an idea of the different types of views and view groups that we're working with, we're going to actually start working towards our first real interactive user interface. This is going to be essentially what the week 2 app assignment is about. So we're going to walk through how to get a reference to a view, how to add a click listener to it, how to get user input, and then display some type of interactive message to the screen. So we'll go back over to Android Studio here. Once again, we're starting off in our main activity, and we're going to go back into activity main here. And now what we ultimately are going to want is a image, an edit text, a button, and I think that will be it. So we're going to walk through how to add some of those elements here and how you can get references to them. So to start, we're gonna leave our text view here, but we're gonna call this text view something like title. And then we're going to change the text of this text view to be something like enter your zip code. And that should be good for the moment there. Then we're going to come down here and we have our button. We're going to change the ID on this button to be something like enter button. And then we will change the referencing ID as well. So enter button. Now, we don't want this to be the simple app icon. We want to do something more interesting here. So what we can do is come over here to the left-hand side of the screen to our project window. Here I'm in the Android drop-down version, but it works the same if you're in the project version here. But basically, I'm going to go to the drawable directory here, right click, go new, and I'm going to scroll down here to vector asset. I'm going to click on vector asset and it brings up this thing called the Asset Studio. This lets us import an image from a local file or use some of the default clip art. Now, if I want to change this, I can click on the clip art icon and it'll bring up this whole set of material design icons that I can use. So in our case, we want to use something that indicates location. So I'm just going to type location and see what comes up. And in this case, we have a number of icons that all seem to indicate location. I think in my case, I just want to select this location on icon that just shows like this little point on a map type of icon. But there's no real right or wrong here. And I'll go ahead and hit OK. And here you could customize the color if you wanted. By default, leaving it black is fine because you can usually change the color in other means down the line. You could also update the name if you wanted, but again, I think the default one here is fine. I'll hit next and then I'll hit finish. and I'll hit add. So now if I go to the drawable directory, I see that it has added this XML, and this XML is a vector drawable essentially. We're not going to get too much into that right now. I don't want that to distract us, but basically what that means is that we can now come here to our source property on our image view and start typing IC location on black. And now we see that we have this little location icon there. So now we have a little icon. We have our title image. We need to update the ID of our image view here. Sorry about that. We're just going to call that icon. Now we're going to go ahead and enter our edit text. So again, we'll do an edit text here. We're going to say wrap content for the height and width. For the height and width, wrap content essentially means I'm going to only be as big as I need to be to contain whatever sort of text or other properties are added to me. So by default, you generally want to go with wrap content. So now for our edit text, what we can do here is supply a hint property. This hint is basically a piece of text that will disappear as soon as the user puts their cursor in there, but it indicates what they want to do with that edit text. So here we're going to say enter zip code. And if I go back to the design view, we now see our edit text right there. I'm not going to worry about constraining this at the moment. I'm going to do that at the end. And we're going to give an ID here of ID zip code edit text. And then one last thing, we're going to change the input type property. So we're going to do input type. And you see here we have a number of different types of input that are available to us. In our case, zip codes are number. So I'm just going to select the number version there. And that should give you some nice things like when you press into that, your keyboard will pop up with only numbers instead of letters and numbers. Now, our last element here that we're going to need is the button. And again, we'll do wrap content for height and width. And for text, we are going to go ahead and just say submit zip code. We're going to hit enter. And we'll see that we have our submit zip code element there. So now we want to actually constrain this in some way. So in our design view here, we can play around. For the homework assignment, there's not going to be any real requirement around what exactly it looks like as long as all the elements are on the screen here. So what I want to do is I want to constrain the icon to the left-hand side of the zip code. And I'm going to constrain its height to the zip code as well. Or I'm going to try and do that here. Actually, it'd probably just be faster to go here. I'm going to remove any of the previous constraints just to make this a little bit simpler on ourselves for the demo. All right, there we go. So everything should be good now. Now we can go in and actually edit this stuff on our own. So I'm going to grab the button and just pull the button down here, kind of get it out of the way. Same thing with the edit text. Want the edit text to always be above the button. So I'm going to constrain the button to the bottom of the edit text, and I'm going to constrain its left and right to the edit text as well. So now the button will be centered based on the edit text. And now I want the title and the icon to also be kind of centered in alignment with that edit text, but also with each other. just going to go down here to my image view. My image view. And delete these again. I think for the interest of keeping this more straightforward, like I said, it doesn't really matter so much what exactly this is going to look like for your homework assignment. So I'll just stack these. I will stack them on top of each other and have it look something like this. And so now this should be roughly centered in the middle of the screen. I'm going to attach the edit text to the parent so I can adjust its sort of vertical weight. And so now I have something like this, where all of these things are constrained together so they move as a group. And now we should be able to enter a zip code, click the button, and actually do something interesting with that. So to do that, we're going to come over here to main activity. And if we want to get a reference to any of these views to actually work with them, the first thing we need to do is come into onCreate, and we need to create a new variable that references that view. Now, how do we do that? Well, let's start off by getting a reference to the edit text. So we're going to create a variable. To create a variable in Kotlin, we can use var or we can use val. The difference being a val cannot change down the road and a var can. So in our case, we're going to do a val and we're going to call this zip code edit text. And we're going to define it as a type of edit text equals, and then we can do find view by ID. Find view by ID lets us pass in a view ID, and it will look for that ID within the current inflated layout of the activity and pass a reference to that view. So in our case, our view is called r.id.zipcode edit text. So now we have a reference to this zip code edit text, and we could manipulate properties on that as needed, which we will look at in just a moment. But first, let's get a reference to our button. So in this case, we'll say val enter button colon button. So once again, this now lets us specify a variable called enter button, and it has the type of button. Notice the types here of edit text and button match exactly the types that we were using in the layout XML. So now again, we'll hit equals, find view by ID, r.id. Yes, I did. So this is actually a nice example. You can't reference a view. So this is actually a nice example. You can't reference a view by ID if it does not have an ID. So here, I'll call this enter button. Come back here. So now I can reference enter button. So now we have references to both of these. We have them as variables, and we want to do something interesting with these buttons. So what we can do is add a click listener to our enter button. So to do that, we can start typing enter button to reference our variable of type button. We then want to call the setOnClickListener method. So to do that, we hit dot. The dot access syntax lets us invoke a method on a object, and then we call setOnClickListener. And you have two options here. They're both effectively the same. The easier syntax is to use this syntax here that has an open and curly brace. In the Kotlin world, this is known as a lambda. Within this lambda, we can now define what happens when our button is clicked. So to start, we're just going to add some very simple feedback. We're going to use something called a toast, which is a funny name, but bear with me. So to add a toast, we'll just start typing toast dot make text. Make text here is essentially a factory method that is going to help us return this toast object, which will display a simple message to the screen. Make text requires 3 arguments. The first one being a context. Now, we haven't really talked about context yet, but essentially a context is a special type of object in Kotlin that knows the certain current configuration of our app. So things like the locale, the orientation, what resources should be loaded. Now, thankfully, an activity is a valid context. To reference our current activity, we can simply type this. This refers to the enclosing class of main activity. Then I'll hit a comma, and now it's going to ask us for some text or a string resource identifier. So for now, I'm just going to pass in a string that says button clicked. I'll hit comma again. And now for duration, there are a couple predefined durations we can use, and we can reference them by typing toast.length short or long. So in this case, I'll do toast.length short. And now after this, and this is very important, we have to go outside of the furthest parenthesis and type dot show. So now this is going to create a toast that will say button clicked, and it will show it. And that should happen anytime our enter button is clicked. So let's test this out real quick by deploying our app to our test device. So we can see here we have our elements on the screen, although notice they're not in quite the same spot we looked at before. We'll come back to that in just a moment. But now, if we click our button there, we see that button clicked was printed out to the bottom of the screen. So that's what a toast does. It's a simple transient message that's a nice way of giving very quick feedback to your users. And we're going to play with that some more in this demo. But first, let's go fix the layout. So if we come back to Android Studio and we come back over here to Activity Main, we'll see here that it looks like it's centered. However, on our emulator, it wasn't centered. It was stuck to the left. So that indicates that there's some type of issue here. Well, if we come back into the XML, if we scroll through this and we look at our edit text, we'll see this little error saying this view is not constrained horizontally. At runtime, it will jump to the left unless you add a horizontal constraint. So that's exactly what we're seeing here. So this is one small thing to be aware of when using this design view, is that there can be certain differences. Thankfully, the key issue here is that everything we have is basically being laid out based on the position of our edit text. Now, our edit text we constrained vertically, but we didn't tell it how to be constrained horizontally, and which is why it's jumping to the left. So to fix it, we simply need to constrain it horizontally to the parent. Now, if we run this one more time and look at our emulator, now we see that it's fixed. It's in the middle, and one more time just for fun, we will click our button. All right. Come back over to Android Studio, go back to main activity. So now we want to do something a little bit more interesting. What if instead of clicking or just displaying the same button clicked message every time, what if we displayed whatever the user had entered into the zip code edit text? So to get the value of whatever is entered in the edit text, we can use a simple property lookup. So within our click listener here, because we want this to happen every time it's clicked, we're going to type val zip code, and it's going to be of type string, equals. Now we're going to reference our zip code element directly, dot text, dot to string. So what we've done here is we've said, go ahead and grab whatever text has been entered into the edit text. So that's this text property. We're going to convert it into a string, and then we're going to save that into this zip code parameter right here. So now, once again, we're going to create a new toast, toast.makeText. This time, instead of passing a string in, we're going to pass in our zip code variable. comma toast dot length short, and then we'll show it. So let's go ahead and rerun this. And if I click submit, we see that a toast was created, but it was empty, which is actually to be expected because we haven't entered anything in zip code. The phrase here, enter zip code, is the hint and doesn't get returned when you use the text property. So if I enter a zip code here, 98119, and I click submit zip code, now we see the toast displayed at the bottom of the screen. And if I change this, 981, we see 981. So that is actually quite helpful for us here. Now, let's do a little bit of user input validation. This will become really important as we start building out our weather app because we're going to want to enforce that our zip code is valid. So we're going to start getting into some conditional logic here. Essentially what we want to do is check the length of the zip code value once we have it, and then display different input to the user based on whether or not it's valid. So to start, we're going to use an if statement. So we'll type if, and then we're going to reference zip code dot length. So that gives us the length of the value stored by the zip code variable. If zip code dot length less than 5, or actually we'll go ahead and rethinking how I want to do the logic here. So let's just say if zip code dot length does not equal 5, in this case, we would want to make this some type of error message. Else, and in the else clause here, this is the successful case. So what we can do is just copy and paste our toast to start. So in the successful case, we'll go ahead and print out the zip code just the same as we did last time. In the error case, instead of passing the zip code, we'll put in a string that says, please enter valid zip code. And now we will run this one more time. And if I enter, let's say just 3 numbers, once again, and if I enter, let's say just 3 numbers, once again, please enter a valid zip code. If I add 2 more numbers, now it's printing out the zip code for us. And so that's exactly what we want there. That has allowed us to provide that conditional validation and give some feedback to our users around what they should expect here. So now let's fix a couple of other small things here. We talked about how we should use strings.xml when presenting user-facing strings. So let's make a user-facing string out of this, please enter a valid zip code. So we'll come over here to values, we'll open up strings.xml, and we'll call this string zip code entry error. Please enter a valid zip code. So that's a good error message for now. If we come back to our main activity, now instead of passing a string directly, we can pass the string resource. All right, so that is one just small update we can make to that. Now, if we go back to main activity here, we notice that everything is roughly the same size. So let's tweak this a little bit by taking advantage of some dimensions. So if we come over to dimens.xml, we have this title text height. Let's change this to something quite a bit bigger, maybe something like 24 SP. We'll go back to activity main, and we'll see now enter zip code is quite a bit larger. If we run this, we see that that's looking a little bit better there. It's spaced out a little bit more nicely on the screen. Now, I want to make the size of the image a little bit bigger here. So if we go into our XML for our activity main layout, we see that the size of this image view is set to just wrap content. And by default, icons are 24 dp. So 24 is pretty small. So I want to maybe change this to something like 40 dp. And like I mentioned before, I believe, remember 40 dp, similar to SP, 40 dp means I want this to be 40 roughly pixels tall, regardless of screen resolution. So DP stands for density independent pixels, and it's just a way of ensuring things are the same height everywhere. So anytime you're specifying a height or width of an element, you should use DP. Anytime you're using size of text, it's SP. So here I've updated the size of my image to 40 dp. And we see now it looks bigger on the preview. And if I run it in the app, we'll see it looks bigger there too. So that's a nice improvement. However, again, this is hard coded here, and it's typically good practice to use dimension resources for this type of thing as well. A good reason is that we might want that icon to be even larger if it's on a large tablet instead of a smaller phone. So we'll come over here to dimensions, and we'll create a new dimension resource, and we'll call this zip code entry icon, and maybe add something like size there. And then we will define 40 dp. If we come back over here, we can now reference that dimension resource by typing @dimen zip code entry icon size. And we want to do it for both height and width. So we'll do it one more time. And now if we preview this one more time, we see that everything looks the same. So that is excellent. Now there's one other thing here I want to just make sure we call out, is that the style of my app is not the greatest right now. I have kind of a weird color palette. This pink, purple, yellow is not the best color palette out there. And so I can see that in my app theme, I'm setting color primary, accent, and primary dark from these color resources here. So I'm going to go over to the colors.xml file, and I'm going to edit these to create a theme that looks a little bit nicer for my liking. So for my color primary, I'm going to come in here to the material 500 range, and I'm going to choose something, probably this yellow. That's fairly close to sort of my personal kind of brand colors I use. So I'm going to go with that. For the color primary dark, I'm going to click here again. And this time, instead of material 500, I'm going to do material 700 and choose kind of that same yellow, but just the 700 variant of it. And now for an accent color, I'm going to choose something, I don't know, let's play around here. Maybe I'll just go back to material 500, but for my accent, I'm going to maybe use this sort of this greenish bluish color here. So if I rerun this now, hopefully my app looks a little bit better. There, to me, that at least looks a little bit more consistent, so I'm happy with that. So that should be about all we need for to get started with these user interactive elements. And just some extra review here, like I said, text sizes should use SP, view sizes should use DP, and colors can be defined in colors XML and then applied to views and styles appropriately. SP stands for scale independent pixels. Defining text size uses SP to enable the operating system to update the text size of elements based on the scale settings of a device. This is done to support users with poor vision. DP stands for density independent pixels. This means that a value defined using DP will be the same size whether on a low pixel density screen or a very high resolution screen. And we should use DP when defining sizes for view groups or views. Colors can be defined as reusable XML elements and can be used things for like background colors on views, for text color, really anywhere we want to color a resource. The last thing I want to cover in this week's lecture is just very quickly how to start testing on a real device. And so testing on a real device is very helpful if you don't have an emulator, or if your computer's a little slow and the emulator doesn't work well, or if you just want that more tactile feedback of what it really feels like using your hands and fingers and input. So if we go to our desktop here, the first thing we need to do to start testing on a real device is enable developer options. Enabling developer options is a little bit different depending on the version of Android that you're using. I've created a previous video on how to do this, and I'll link that in the lecture notes. So if this demo isn't quite what is working on your device, maybe that one will work a little bit better. Ultimately, it all comes down to kind of the same stuff though. So what you need to do is go into your phone's settings. Now, what you want to look for is ultimately kind of in the system settings, possibly under the advanced section. Eventually, we're going to see something called developer options. However, here we don't see that. To enable developer options, there's a bit of an Easter egg in the operating system. So you can go to About Device. I'm doing this on an emulator. It's the same process for a real device though. So you go to About Your Device, and you're going to come down to where it says Build Number. And then you're going to tap that 5 times. 1, 2, 3, 4, 5. Actually, I guess it's more times. But eventually, you'll see this thing that says, "Yay, you are now a developer. Congratulations." Once you've seen the "you are now a developer" thing, come back to System. In this case, I need to expand Advanced. And now I see Developer Options. If I click Developer Options, we now have a whole bunch of options in here that make developing Android apps easier. The one that we're concerned with is USB debugging. So scroll until you find USB debugging, or you can use this little search and just type USB and hit enter. And it'll also find USB debugging, in which case you can just click on that and it'll take you right to the option. You're going to want to make sure USB debugging is turned on. So on the emulator, by default, it's turned on. But when you turn it on, you should see something like this: allow USB debugging, and then blah, 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 blah. You'll hit OK. At this point, you should be able to plug in your real device, connect it with a USB cable. It'll likely prompt you to ask, do you want to use this device for development? That should be a one-time thing. If you say like, don't ask again. Once you've clicked OK on that, Android Studio should recognize your device, and you should be able to now deploy your device just like you would an emulator. So if you go into Android Studio here, and let's try and connect this. I will try and connect my own device here to Android Studio. So as soon as I've connected this, I see a message that says allow USB debugging. And I will go ahead and check the box that says always allow from this computer and click allow. And now in Android Studio, if I go to the device dropdown, I see Google Pixel 2 XL, which is my personal device. And so now I can go ahead and run that directly to my phone. So that is the process for setting up your personal device to test with Android. Like I said, I'll link to my other tutorial that goes a bit more in detail on that. But I just wanted to point that out because a couple people had asked about it. All right. Yeah, just a little bit more about developer options here. We probably won't get too much into it, but there are a couple specific options that I will point out, and I will link to some extra resources for this too, just in case you are curious. And that is it for the week 2 lecture. So as of course, there'll be some more review and stuff in our live class. But this should be pretty much everything you need to help get you through the homework and to continue to build that foundation as we think about building our weather app going forward.
Hey everybody, welcome back to week 3 in our journey into Android development. This week, we're going to be focusing on how we can display dynamic lists of data in our Android applications. So if we come back over to our notes here, we're going to kick it off as usual by just sort of outlining this week's lecture. So to start off, we'll just do a little bit of a project demo showing you where we're going for this week, what you will be building. Then we're going to look a little bit just into the general idea of displaying dynamic data. Why do we need to display dynamic data? How can we display and interact with a varying number of UI elements? Then we're going to start diving deeper into the actual implementation and how we can go about this. So we're going to start by first looking at how we can define a data model, and also a little bit into how we think about structuring our apps and providing data from one layer of our code to the other. And then we're going to get into the nitty-gritty of how we can implement a recycler view as a means of displaying list content that we can then scroll and click on and interact with in a variety of ways. So for our project demo here, we're going to walk through a couple of things, and I just want to point these out before we jump into the app, and then I'll point them out again. So I'm going to just show you how you can easily and quickly rename your app if you want to just add a little bit of a flair and personalize your project a bit on your own. Then we'll show the display of a scrolling list of weather forecast data. Also point out how that data is somewhat pseudo-randomized, and we'll get into how you'll go about that randomization at the tail end of this lecture. And then you'll also see that we respond to click handling in our items, and we will display a toast message when an item is clicked. So if we go over to our Android emulator here, I have sort of the updated version of this app up and running. Now, if you have been following along and you are up to date with last week's lecture and assignment, then this should look pretty much familiar to you. This is basically where we're at the end of last week. So if I now enter in a 5-digit zip code here, and then go ahead and click submit, this week we're going to add this new view here. And actually this is a collection of views. And we'll see each view is displaying what is essentially is a temperature and then a description here. And so it's these descriptions that we're going to somewhat randomize when we get into the code. And you'll be able to have a little bit of fun with that and add the descriptions however you want. But by the end, we should be able to scroll this data. If you click on an item, you should see that we have some feedback there indicating that you have pressed on it. And then if you actually go ahead and click on an item, we should display a toast message displaying the temperature and just the description of that weather item. So this is where we're going this week in week 3 of our course. Now, if we jump back over to our slides, we can think about jumping in to the next section here. So how do we display and interact with a dynamic number of UI elements on our screen? Well, first off, let's just think about the problem here. So modern apps require dynamic data and user interfaces. Think of any app you probably use these days. Email, you're going to have a varying number of items displayed in your inbox. YouTube, you're constantly getting new videos popping up and you can kind of scroll forever. Same thing with Instagram. Twitter. So many apps these days are built around the idea of sort of endless content that constantly has to be pulled in, and the UI for those apps has to be able to adapt to those different content items, and sometimes even different content types. Developers, or maybe the challenge, if you want to frame it that way, is how can we build user interfaces without knowing ahead of time how many items will be on the screen? Well, in Android, we have a number of different sort of views or kind of containers that can potentially help us solve this type of problem. And we just listed off a few right here to start. So scroll view is something you may run across. You may have seen it in the design view. But essentially, a scroll view is a container that allows the user to scroll a layout that is too big to fit on the screen at any given time. So you might imagine instances where this could be helpful. Now, another item or another type of container that can be quite helpful is a list view. And essentially, a list view is specifically designed for displaying scrolling collections of views. So this actually translates really well to the idea of something like YouTube or Twitter, where you're just kind of endlessly scrolling. However, list view is actually a bit of an outdated concept in Android, and we'll actually see essentially what has replaced it as we move forward in the lecture. And then another example just to point out here is a view pager. A view pager enables swiping horizontally through collections of data. And now this is something that you can actually achieve a number of different ways. And that's kind of a theme with building UI for Android, is there's often several ways of achieving the same type of task. But so this view pager might be something more similar to, let's say, Tinder, where you're swiping things left or right and kind of swiping through many different items. Now, the one that I want to spend the most time talking about, because this is the one that we're going to actually be using in this week's project and discussing in the lecture, is Recycler View. Recycler View is a flexible container for efficiently displaying and interacting with large sets of data. And so why Recycler View? Why are we focusing in on this specific container? Well, Recycler View really is kind of the modern way of solving this type of task of displaying large collections of data on the screen, particularly if you need to do it efficiently and you want to have flexibility in how to make those items look and how you're going to interact with them. So just a few of the key elements around a Recycler View. They provide efficient recycling of views. Recycling a view is essentially just means as a view scrolls off the screen, that view will actually be reused potentially for the next item scrolling onto the screen. The reason this is done is because if you have a large set of data, say 1,000 items, it's really inefficient to create a new view for each item if you can only see 10 items at a time. So what happens is, as let's say item 1 scrolls off the screen, its view will be recycled and used to bind item 11. And it's just sort of this continuous recycling. As you scroll up or down, items are moving on and off of the screen and then getting reused. Now, Recycler View also provides a really flexible layout system. This comes in the form of layout managers typically, but essentially Recycler View is very generic in what it does, and it allows layout managers to define how items should actually be laid out on the screen. Meaning a Recycler View can lay things out in a list, in a grid, or something really custom, as we'll talk about a little bit later. And then support for animations and decorations. This one, again, provides some really nice utility to developers, but we'll chat about in just a moment. So like I talked about, efficient recycling here. Basically, the key idea here is that the recycling that Recycler View does lets it be efficient, and it lets your apps be really responsive, even when trying to display hundreds of items, thousands of items. And then, like I talked about, the flexible layout system is driven really by layout managers. And so there's a couple examples of layout managers here. We have a linear layout manager, which will essentially act just like the linear layout we saw last week, in which it will lay things out vertically one after the other or horizontally one after the other. And then you can scroll through those either top to bottom or left to right. Now, grid layout manager lays items out in a grid, and you can customize how that grid is laid out. You might want 2 columns, 3 columns. You might want 2 columns on a phone, but 4 columns on a tablet. You might want certain items to take up all 4 columns and certain items to only take up 1 column. You have a lot of flexibility there to control how that grid might look. And then finally, if you need something really custom that isn't provided out of the box, you can write your own layout manager and define custom code for how individual view items will be laid out on the screen. So it's a nice plug and play system that solves a lot of the challenges that the older list view presented because it was so specialized in how it was created. And then finally, animations and decorations. So Recycler View, one of its really cool properties is that when you add or remove items to the Recycler View, it can automatically animate those changes if you follow certain patterns, which are quite easy to implement. And we'll possibly get into those later in this course. We will not be for this week, a little out of the scope of what I wanted to cover, but basically it just enables you to get really nice sort of insertion and deletion animation, which makes your app just feel a little bit nicer, a little bit more polished. And then kind of along these same lines, sometimes when you're adding these items to your list or to your grid, sometimes you might want to perform some transformations on them in a common way. You might want all of them to have some extra padding. You might want all of them to have some kind of cool looking background or something. This is something that used to be pretty challenging to do when people were relying on list view. However, with Recycler View, we have this concept of an item decoration that can be applied to the Recycler View essentially, and it'll draw some custom background or divider, things like that, to each item in the list. So again, just Recycler View is really flexible and enables developers to kind of do a lot of things that they need, but it doesn't enforce them to do things. So what we'll be working on this week will actually be a pretty simple implementation of Recycler View to start, and then possibly get more advanced further on in this course. So how exactly does the Recycler View work in action? Well, there's 3 kind of key components here. There's the Recycler View itself, which is the kind of view that you will define in your XML. But to actually make the Recycler View work, there are 3 classes we have to pay attention to. So first off, like we mentioned before, there's the layout manager. And the layout manager controls how individual views are laid out on the screen. Next up, there is the adapter. The adapter connects the collection of data to individual views. And then finally, the view holder is able to actually bind the individual pieces of data to the individual view items created by the adapter. So it's sort of a 3-pronged approach here. The layout manager positions the views on the screen. The adapter kind of creates the views and connects the data to them, and the view holder actually binds that data, places it into the individual views, like the text views and the image views, and then the Recycler View can combine all of this to display the list or the grid. And now notice too that all of these classes here, they all start with Recycler View dot. So these are all essentially kind of nested classes on the Recycler View. So it helps you sort of find them. So if you needed to, inherit from Layout Manager, you would inherit from Recycler View dot Layout Manager. If you want to create a new adapter, you can inherit from Recycler View dot Adapter. And similarly, if you're going to create a new view holder, you would inherit from Recycler View dot View Holder. And so here's just an illustration then of that process we just talked about. So on the left-hand side, we imagine we have some collection of items. It could be, 1 to n, any number of items. That list of items is going to then be passed into the adapter. And that adapter is going to create view holders. And the number of view holders that it's going to create is essentially dependent on kind of the size of the views that it creates and the size of the screen. But basically a view holder represents an individual view that will ultimately get drawn to the screen. And the reason it's called the view holder is because it caches references to the individual views. So let's take a step back and review that, because that probably sounds a little bit confusing. So an individual view on our screen might include, an individual list item on the screen might include an image and a text view. So the view holder is going to inflate that list item, and then it's going to create variables referencing the image view and the text view. What that gains for us is that every time we need to bind data to it, we don't have to re-look up the reference to the view. So think back to last week when we were calling find view by ID to get a reference to our button and to our edit text. What the view holder lets us do is perform that find view by ID call one time and then not have to do it every time the data is rebound. And this is really important because find view by ID is a relatively expensive call. So if we had to do that every time the data starts scrolling on and off the screen, it would really slow down performance. So view holder is a nice performance win for us. And don't worry if it still sounds a bit confusing. I think it makes a lot more sense when you see it in code, like we will a little bit later on in the lecture. And then the tail end of this process is that these view holders that know how to bind data into the view ultimately are used to display those list items onto our screen and let us scroll around, collect, interact with them, etc. So next up, we're going to chat about defining our data model. So as I mentioned last week, we're going to be sort of week by week building up a weather application. So ultimately, we're going to be displaying forecast data for probably a daily forecast, maybe a weekly forecast. And so at some level, we need to model this weather data that's coming from, some type of real world service out there, weather stations or whatnot. All of it gets aggregated into some API that we can then call and request data from. How are we going to think about modeling that data so that we can use it in our app and display it into our screen? So that's kind of the question that we're going to start to solve in this question and in this week. So when we think about why we model data, well, the ultimate problem here is we need to represent the real world in code. So we need to somehow translate weather data for a particular location and a particular day into something that we can use in our code within Android Studio. We then are going to want to manipulate that data, store it, and then ultimately display that real world information as we need it. So we want to model it in a way that's easy to use, easy to store, easy to access. And we have a number of ways we could go about modeling data. The one that you're likely already familiar with is object-oriented programming. Object-oriented programming in many ways is built around this idea of modeling data in ways that logically make sense. So for us, we might have something like a forecast item or simply a forecast that knows how to represent the different types of data we'd get back from an API. You could also model data in other ways. And one example of that would be in kind of a functional programming paradigm. If you're not familiar with functional programming, it's a type of programming that it doesn't use objects. So everything is simply data in and outputs. It's very mathematical in the way it works. And you can sort of model data that way with primitive types, but it's quite a bit different. We're not going to get into it. So for the sake of this class, think of it in kind of object-oriented terms. And so specifically, since we're working with Kotlin, we're going to be modeling a lot of our data using what are called data classes. And a data class, as we can see here, is it's a pretty simple concept. It is a special type of class that really is perfect for modeling data. You could think of this as a value class. The idea behind a data class is basically it doesn't have a ton of logic or anything behind it. It's simply there to hold data and it's immutable as well, which is another key factor here. So it's a class that holds data and doesn't change, so that you can rely on that data once it's created. So we will see how we can leverage a data class like this in a little bit, because we will be using it to define sort of our daily forecast. So now the next question, it's not enough that we sort of model our data with a data class, but we have to also think about where this data is coming from and how we're going to communicate it to ultimately our activity or whatever else is controlling our UI. So this kind of gets into the concept of app architectures, which again, I don't want to get into today very much because it's a large topic. You might be familiar with some of the common sort of app architecture acronyms out there. These are things like MVVM, MVP, MVC, MVI. There's a lot of options out there. We'll likely do a small lecture about that some point during this course towards the end. Today, we'll just kind of throw it out there that we are going to be following a pattern essentially that is MVVM, or model view view model. I think this works really well and is pretty simple to understand and set up with modern Android practices. So that's pretty much why we're doing it, is because that is sort of the official recommendation from Google these days. So it's a good place for you to start as you start to explore the idea of app architecture. Essentially in model view view model, it breaks your app into sort of three rough containers of functionality. You have the model, which is where you are kind of modeling your real world data. So the forecast item we just saw could fit into this sort of model domain. You have the view, which is essentially what we're seeing on our screen. So that is kind of our layouts, our activity. And then we have this idea of a view model, which is kind of this intermediate layer. You can think of a view model as basically taking in the model data and spitting out whatever needs to be displayed on the view. So we'll look at how to create a proper view model later. This week, we're going to just start taking the first steps towards that. So it's not going to be fully MVVM yet, but we will get there eventually. And then the last little concept I want to introduce here is the idea of a repository. A repository is a class that you define, and its main purpose is to load and provide data from that kind of single class. Now, within that class, data could be loaded from multiple data sources. You could grab data from the network using the internet connection. You could grab cached data that's on device from a database. But whoever is asking for that data doesn't need to know where it's coming from, which makes it very transparent from the user, and it makes it easy for us to kind of change where the data comes from without having to update a lot of other places in our code. And then ultimately, the UI will be updated based on the data exposed from this repository. So in our case, we're going to ultimately create a repository that will hand us back some forecast items, and then we will use those forecast items to display the list in our activity. So that'll be kind of the basic outline of where we're going with our project this week. And so we can kind of visualize the repository like this. So from our previous example where we had that list of items coming in, that list of items is going to be coming from the repository. The activity is then going to receive updates when those items change, are going to pass it into the recycler view and ultimately create those view holders and ultimately display that onto the UI. So that's kind of the separate layers here. We have the repository, which is kind of coming from this view model layer. We have the activity, which is our view layer, and then ultimately those are displayed onto the screen. Now, to help with this passing of data from the repository to the activity, we're going to be using a special class that comes from sort of Google and the Android architecture components called a live data. Now, a live data is essentially an observable data holder. What that means is that the live data will hold a piece of data, and you can hand it new pieces of data, and somebody else can basically observe changes in that data. So it allows you to have this nice sort of one-way flow of data where you can hand an update to the live data, and anybody that's interested will automatically be notified of it. So it's a really powerful mechanism for writing clean code that's easy to maintain. Now, in our case, we're going to be observing live data from our activity, which will change whenever our repository updates the live data. And another great thing about live data is that live data is lifecycle aware. So as we saw last week, our activities have a life cycle. It has a start, a resume, a pause, a stop, a destroy. And what can sometimes happen if you are loading data is you might start loading data, your activity might stop or go off the screen, the data will finally return, and then at that point, lots of bad things can happen. It might cause a crash. It might try and update and switch you back to a screen when you don't want it to. It might simply just waste a lot of bandwidth because you're loading something that is no longer needed. So live data helps us solve these problems by basically knowing what state the life cycle is in and adjusting itself accordingly. Couple other just quick things about live data before we move on. Like I mentioned, live data must be observed. So we will see how you observe a live data. But basically observing a live data will give you updates anytime that data changes. There are sort of two specific implementations of live data. There's actually more than that, but there's two main ones that we'll be looking at this week. And one of those is called mutable live data. Mutable implies that you can change the value there. So the other one, which is just plain live data, that one by default is immutable, meaning you can't actually change its value. So we'll see how these two play together, but basically what it lets you do is expose a live data to your activity so that the activity can listen for changes, but it can't change the data itself. Internal to the repository, you can use immutable live data to update that data. So it gives you this nice separation of concerns. It makes it very clear who can manipulate what data. And then finally, like I mentioned, live data helps prevent common problems like memory leaks, crashes because you don't handle the lifecycle or configuration changes properly. There's some really nice things that live data does for it. So that's why we're going to start using that in our application. Now it's time to jump back into Android Studio and start implementing our new recycler view, which will take in a dynamic number of these forecast items that we're going to create, and then we'll add things like user interaction and click handling. So we're back over here into Android Studio, and this code should look essentially just like it did at the end of the week 2 lecture. And so to start, I'm just going to clean this up a little bit by getting rid of these extraneous lifecycle methods because we're not going to need them for this week's lecture. So now the first thing that we're going to do here is create a data holder class to hold a daily forecast item. Now to do this, we'll go to the left-hand side of our screen into the project pane again. We're going to click on the package identifier where our main activity is stored. We're going to right click, go to new, Kotlin file or class. We're then going to click on class in the little drop-down menu there, and we're going to type daily forecast. So now this has automatically generated a class for us called daily forecast. Now, because this is going to represent a simple piece of data, and that data won't change, we're not going to add any functionality to it. We can convert this into a a data class by adding the data modifier before the class modifier. And now we will go ahead and add an open and close parentheses because data classes require you to define at least a single property on them. Now, what is a property? A property is like a variable on a class, and we define them basically the same way we defined our variables to reference our views in last week's lecture. So we're going to define a variable or a property, since it's on a class, to hold the current temperature. So to do that, we'll put our cursor in between the open and closed parenthesis, and we'll type val temp colon, and then we will define a type of float, and that's it. We now have a read-only property on our data class of type float. Now we want to add one more property, so we'll type a comma, we'll hit enter to come down to a new line, and then we will type val description colon string. So now we have a read-only property called description of type string. So as you might guess, we're going to use the temp property to hold the current temperature for our forecast item. And we're going to use the description property to hold a simple description like partly cloudy or sunny. Have our value holder or our value holder or our daily forecast item here. It's time to create a repository. So again, we'll go over, we'll click on our package identifier, right click, new Kotlin file or class. Once again, we'll click class. And this time we're going to type forecast repository and hit enter. So now this has created a new class for us called forecast repository. Now, if you remember from previously in the lecture, we talked about a repository essentially doing two things: loading data for us and providing that data out to our activity. So we're going to tackle that second item first. We're going to define how our activity will get data from our repository. So the first thing we're going to do is define a private property that will be internal to our forecast. And this will be the property that we use to update the data. So to do this, we're going to create a private property using the private keyword. Then we'll use val because this will be read only. And we're going to call this underscore weekly forecast. So what this has done is basically started off defining our weekly forecast. So this is going to return a week's worth of our forecast items. Now, this property is going to be a live data. And specifically, it's going to be a mutable live data. Now, as soon as I type mutable live data, it prompts me to import that class. So I can do that by hitting Alt Enter, or I can go up to the top of my file and type import androidx.lifecycle.mutable live data. So now back down here, it's added mutable live data and it has open and closed angled brackets. And there's a little basically squiggly line saying a type is expected. So live data in general is a templated class, meaning it can hold different types of data, and you have to tell it what type of data you want it to hold. So in our case, we want it to hold a list of daily forecast items since we want to represent a week's worth of forecast information. So we're going to type list, and then again, we'll type open and close angle brackets, daily forecast. And then we'll just finish this off by an open and close parenthesis. So what this has done is defined a private read-only property called underscore weekly forecast and assigned it the value of a mutable live data that will hold a list of daily forecast items. So this will let us update that observable value holder internally to this class, but we still need to make a way for our activity to listen for that update. So now we're going to create a public live data. To create a public live data, we simply type val because the property will be public by default. And then we're going to name it essentially the same thing, but without the underscore. So we'll type weekly forecast. The reason for this naming is to indicate that these two are really going to be connected, and you'll see why in just a second. So val weekly forecast, we're going to give it the type of live data list daily forecast. And then now I'm just going to assign it the value of weekly forecast. So these look very much the same. The difference here is that weekly forecast is public, so the activity can get access to it, and it's a live data instead of a mutable live data. What this means is that anything that references it, like our main activity, will be able to get updates, but not to publish its own changes. And that's really important because we want the repository to be the only place that can modify this data. So now that we have a means of updating the activity with the data, we need to actually load the data. To do that, we're going to define a new method on this class, and we'll do that by typing fun, and then we're going to call this method load forecast. We want to pass our zip code into this because eventually that will be important for loading the specific forecast for that zip code. So we're going to add a parameter to this function called zip code colon, and then it will be of type string. So this will let us call load forecast and pass a zip code in. And then we will define the function body by just defining the open and close curly braces. Now within this, we want to start off by defining a list of 7 random values. And those random values are going to represent our temperature values. So again, we'll create a local variable called random values by typing val random values equals, and then we're going to type list 7. So essentially this is going to create a list of 7 items. And then we're going to add an open and closed curly brace after this. What this is going to allow us to do is essentially initialize how these 7 items should be created. So it's basically going to let us define what will be in that list. Now, to create random values, there's a special class in Kotlin called random. So I'll type random dot next float. And now it's going to prompt me to import the random class. So again, I'll wait till it highlights it and type alt enter. And then I'm going to make sure I select kotlin.random and not java.util. So make sure whatever you're importing says kotlin.random. And if you look at the top of your class, you should see it say up here, import kotlin.random.random. So now here, random.nextFloat is going to generate a random floating point number for us. Now we want to sort of limit that to numbers between, let's say, 0 and 100. So we will type rem, which stands for remainder, and we'll pass in 100. So what that's going to do is essentially, it's like a modulus operator. So by calling rem on this, all of the values generated will be essentially between, I think 0 and 1. And then we can just multiply this by 100. And so now all of our values will be between 0 and 100. So this line is a little bit complicated here. That's fair. It's not the main focus of the weekly content. So I just wanted to line that out for you so you have some idea of what that's doing. But basically that now gives us our temperature values. So now we want to essentially convert those temperature values into forecast items. So once again, we're going to create a new local variable here, and we're going to call this one forecast items. We're going to use this to create the items that we're going to send to our live data. So now we're going to reference that list of temperature values by typing random values. And then we're going to use a map function. A map function basically lets us convert one type into another type. So by typing map, open and close curly brace, this now essentially lets me take in each of those individual values and convert it into a different output value. So in our case, we want to convert this into an output value of daily forecast. So I'll type daily forecast. And now I'm going to type it, which might seem a little weird, but bear with me, comma. And then for now, I'm just going to type partly cloudy. Since it's Seattle area, it's always partly cloudy here, right? So what this has done is it's used each one of the individual random values. So we had 7 random values to start. This is now going to create a list of forecast items with 7 items in it. The part that's a little confusing here is it. So within this function, it stands for each individual item. So a better name for that would actually be maybe random value. And now I could replace it with random value when creating our daily forecast. Or an even better name for this would probably be temp. And then I'll pass temp in. So now we have a list of forecast items that all have a random temperature and the same description. We're going to come back to how to update the description later. For now, we just want to send this list to our live data. To do that, we need to reference our underscore weekly forecast property. So I type underscore weekly forecast dot set value. So now set value is basically going to let us update whatever value is currently held by the live data. So I will pass in forecast items. So now what happens here is underscore weekly forecast will be updated with these new items. And because weekly forecast is based on underscore weekly forecast, that means weekly forecast is also updated. So now our next step here is to go into main activity and actually start observing these values. So we'll do that, like I said, by coming into main activity, and we're going to go below the code from last week, a couple lines. And we need to first off create a new repository for our activity. So I'll actually come back up to the top and we're going to create a private val property called forecast repository. And then we're just going to initialize that all in line there. So now we have a forecast repository that we can reference down below in our code. So what we need to do now is add an observer to this repository. The observer is what's going to let us know when updates are made. So I can start trying to do this by typing forecast repository dot weekly forecast. So this is our public live data. So we can reference this. And now if we type dot observe, we can see that there are several different observe methods that will let us listen to changes in this data. So we're going to select one of them here, and each observe method requires a lifecycle owner. A lifecycle owner is just something that knows about the current lifecycle, and thankfully an activity is a lifecycle owner. So we can type this, and once again for review, this references that enclosing outer class, in this case main activity. But now we need to pass in an observer. And there are a few ways that we could pass in and create an observer. The one I'm going to do is maybe the most code, but also the most explicit, the easiest to, I think, understand. So we're going to create a variable using a val called weekly forecast observer. And then we're going to say equals, and then we're going to type observer, which is a special class in the Android X lifecycle package. So now we've added an opening closed angle bracket, again, because we need to tell it what it's going to observe. And once again, it'll be a list of daily forecast items. Now we'll come to the end of that line and we'll add an open and closed curly brace again. So once again, this is a lambda. This is like we saw in the click handler or just a minute ago in our map function. So the items available to us within this lambda are forecast items. And so instead of using it to reference them, which is really confusing, we're going to type forecast items here on that same line, and then we're going to type an arrow. So this lets us rename the receiver of that lambda, and now we can reference forecast items. And all we need to do with forecast items is update our recycler view. Now we don't have the recycler view part of this implemented yet. So for now, we're just going to leave a comment that says update our list adapter. So right now this observer will do nothing anytime it's updated. However, now that we have an observer, we can finish the observe implementation below. So now we've called forecast repository .weekly forecast .observe. We've passed in a lifecycle owner, which in this case is main activity, and we've also passed in weekly forecast observer. So that observer will be updated anytime our live data changes in the repository. And because we've passed in that lifecycle observer, all of these changes will be bound to the lifecycle of the activity. So if any loading is taking too long, it won't return once the activity has been destroyed, which is really helpful for us and helps avoid many types of issues. Now, if we wanted to just test this out real quick, we could add a toast message here in our observer. So let's just say toast.makeText. We'll pass in this again because it needs a context and main activity is a context. And then for the message, we'll just say loaded items, comma. We'll pass in toast.length short for our duration. And then we will call show. So now if I go ahead and run this, we'll jump over to the emulator here. All right. And so now it has redeployed this. So let's see if it does anything. So it didn't do anything to start. Let's see if it does anything in response to clicking the button. No, it doesn't. All we're seeing is the same old toast message we had before. And so why is that? What is going wrong here? Well, the issue that we have is that we have not actually called load forecast anywhere. Remember, we need to call load forecast so that our repository can update the live data and we can update that notification. So what we'll do here is we'll come back over into Android Studio. And instead of showing a toast when our enter button is clicked and we have valid input, we're going to call forecast repository.load forecast, and we'll pass in our zip code. So now this should load the data when we click the button, and then we should get our loaded items toast. So once again, I'm going to click Run App to redeploy. Now I'll switch over to my emulator. And now, if we enter a valid zip code and we click Submit, now we see the loaded items message. So that means we are well on our way. We now are observing the values correctly. And the next step is to take that list of items and display a list in a recycler view. So we're back over now into Android Studio. And now we want to open up our activity main layout XML file. So I'll click over into that file, and we've opened up here into the design view. So now we need to add our recycler view to this layout so that we can start displaying our forecast items. So if we come into the left-hand screen here, we'll come into the palette tool window here. And under this common section, we should see recycler view. So we're going to click on that, and we're going to drag it over here into our design view, and then go ahead and let it go. So now we need to make sure that this is properly constrained. So we're going to click on this top circle here, and we're just going to constrain this so that it sits below the submit button. Then we'll constrain the left-hand side to the left of the parent, the right-hand side to the right of the parent, and the bottom to the bottom of the parent. So now you should notice there's no more little red icon here indicating any kind of an error. And so now, just to kind of illustrate that this view is in fact here, we're going to go over to the XML, scroll down, and we can see, all right, here is our new layout. And we'll actually notice two small problems here. And so this is something important for you to check out. So even though it looked like I properly constrained it to the left and right, it didn't quite work as we wanted to. These values here for the layout width and height, we don't want them to be hard-coded to a specific value. We want those to actually be more generic, like match parent, or in constraint layout, we could set them to 0 dp, which would actually mean that it's going to completely leave it up to the constraints. So if we go back to our design view and make sure the recycler view is clicked, we can view that issue here as well. We can check out the width and height. So I'm just going to update this to 0 dp and 0 dp. So you want to make sure that that is set properly. Once again, let's come back over here into our XML, and just to make sure we're inspecting this properly again. So now this is looking good. And just to test out that this is correctly being laid out on the screen, we're going to add a background color to this by using the Android :background attribute. And then I'm just going to type a color value by using the # and then AB. And you should see that that now resolves to a gray color over here in the left-hand side of the screen. So now I'm going to go ahead and run this so we can see what it looks like in our emulator. So now see that we have an error actually. So let's go back over to Android Studio and try and diagnose that error. So we'll come over here. Now when your app crashes, the best way to figure out what happened is to come to the bottom tool window here and look for logcat. If you open up logcat, you should be able to see a lot of different error messages here. And as you scroll through, you might also be seeing error messages for lots of different applications. Now you want to go ahead and make sure that your application is selected here in this kind of middle dropdown. So here I've selected goobar IO 8340. And then in the second dropdown, I can select error. And here we should now be able to see what the problem is. So the issue that we're getting here is it's saying a class not found exception. Now, if this happens to you, essentially what this means is that when that recycler view was dragged over, the dependency needed for it wasn't pulled over with it. And I illustrate this because it's kind of a frustrating issue where sometimes Android Studio recognizes that you need the dependency and other times it does not. So we'll walk through how to explicitly add that dependency. So to add the new dependency, we're going to go to our build.gradle file in the app module. So in Android View, that should be in this Gradle scripts section at the bottom of the project pane right here. If you're in Project View, that should be in the app directory in that first level. So I will open up build.gradle, scroll down to the bottom to underneath the constraint layout, here. And I'm going to add in this following line. So it should say implementation and then a space, and then in single or double quotes, it doesn't matter. You want to type AndroidX.RecyclerView: RecyclerView: 1.1.0. So this is how to define a dependency for your Android app. Very quickly here, basically what this is saying is that we need to pull in the AndroidX dependency for RecyclerView, and the version of it is going to be 1.1.0. Now, in a couple weeks, we're going to talk more in depth about adding dependencies. But for now, once you've updated the build.gradle file, you should hopefully see a message that looks kind of like this at the top of your screen. It should say Gradle files have changed since last project sync. A project sync may be necessary for the IDE to work properly. So if you see that, go ahead and go over to the right and click Sync Now. You can also come up into your toolbar here and look for an icon that looks like an elephant with a blue arrow. And if you hover over it, it should say Sync Project with Gradle Files. So click on either of those sync buttons, and basically Android Studio is going to pull that dependency in. So now, if we rerun this project, it should rebuild. And so now if we go over to our emulator, we'll see this time we now have this big gray square or rectangle on our screen. So that is now our recycler view. So now we can tell that the recycler view is actually on the screen. Now we want to make a couple small adjustments here. So we're going to go back to our activity main XML file, and we're going to go back over to the design view. So one thing I want to do here is update the margins of this recycler view. Right now, it's going clear to the edges of the screen, both on the left and right and the bottom, and it's also really close to the submit button at the top. So I'd like to kind of update the spacing between that. So to do that, I can click on the recycler view. And if I come to the layout section over here in the right-hand side in the attributes panel, notice that we have this kind of this square looking thing, and it has these 4 drop-downs. And all the drop-downs currently say 0. Those drop-downs represent the margin. And the margin represents the spacing between the current item and other items around it. So, for example, if I select this top drop-down and set it to 16, we'll notice that it now pushes that constraint layout further below the submit button. If I jump that to 32, it pushes it even further down. So I'm going to move this back to 16 because 16 is a pretty common spacing in between Android elements. And so now I'm going to add a spacing to the left and right as well of 16. And then I'm going to just leave the bottom as it is because I want these elements to be able to scroll off of the screen. But so now I've given myself a little bit of spacing around the other elements. Now, one more thing before we redeploy this, we're going to need to reference this recycler view so that we can do things with it like set its adapter and update it. So we're going to need to add an ID to this. So we're going to add an ID to this called, one second, I just need to double check my notes, what I called it, so I can be consistent. Just there. Okay, yeah. So we're going to call this just forecast list. All right. So now we'll go ahead and rerun this one more time. And we'll jump back over to our emulator. And so now we can see that we have that nice spacing between the elements. Now we're back over into Android Studio. And we're going to go to main activity. And now we're ready to create a reference to our recycler view. So very similar to how we did this for button and edit text last week, we're going to come down here and we're going to create a new local variable. So we'll type val forecast list colon recycler view equals find view by ID r.id.forecast list. So hopefully that is a little bit almost of a review at this point. It looks just like it has with those other views, but now this time it is using a recycler view instead of a button or an edit text or any other type. So now the next thing we want to do is make sure that we set a layout manager for our recycler view. Remember from our notes previously, the layout manager is what informs the recycler view how layout items should be laid out on the screen. So we want things to be laid out in a vertically scrolling list. So what we'll do is type forecast list dot layout manager. This is going to allow us to set the value of that layout manager property equals, and then we're going to create a new linear layout manager. And to do that, we simply type linear layout manager. And then to invoke this constructor, we need to pass in a context. So again, we'll pass in this to reference main activity. So now we've set a linear layout manager to our recycler view. So when we populate it with data, it should lay out in a vertically scrolling list. So now the next step and the kind of the most important step here is we need to create our adapter for our recycler view. And now with that adapter, there's really a couple steps there. We're going to have to create the view holder, the adapter, as well as something called an item callback. So we're going to walk through all of those steps right now. To start, we'll come over to our project pane. And again, we're going to create a new Kotlin class. This time, it's going to be called daily forecast adapter, and then we'll hit enter. So daily forecast adapter is going to take in one parameter eventually, but for now we're going to leave it blank. But we do want to inherit from a recycler view adapter class. And now thankfully there is a subclass of recycler view adapter available to us that makes setting this up a little bit easier. It means we have to do a little bit less work. So to do that, we're going to type a colon, which is how we indicate that we're going to inherit from another class. And now we'll type list adapter. And I'll hit Alt Enter just to make sure I import that dependency correctly. And now notice here there's two versions of list adapter. You want to be careful that you import the one that says androidx.recyclerview.widget. So once that's selected, I'll hit enter. Now, before we can continue on defining our adapter here, we need to define two types. First is the type of item that will be passed into this list adapter. And the second is the type of view holder that will be used to bind those items to layouts. Now, the first thing here is quite easy. We know that we are going to be working with daily forecast items. So I can just type in daily forecast right here. So that defines the first type that we need to satisfy here to make our new adapter. Now, the second thing I have to declare is the view holder, but I don't have a view holder yet. So let's go ahead and create one now. So in this same file, we're going to create another class. This class is going to be called daily forecast view holder. It's going to take a view as its single input parameter, and it's going to extend recycler view dot view holder. And now recyclerView.viewHolder, its constructor takes a view. So we're going to pass in the view from the daily forecast view holder constructor. So just notice here that we have this input parameter called view, and we're passing it into the constructor here in the parent class. And then I'll just go ahead and create the open and close curly braces here to complete our class body. So now we have a view holder. We're going to add to it in a minute, but for now, that's enough to come down here and complete the definition of daily forecast adapter. So after daily forecast, I'll type comma, and then I'll type daily forecast view holder. Now that I've typed that, it should probably give you several different red squiggly lines here. So there are a couple things we need to fix. The first thing we need to fix is that the list adapter class has a constructor, and that constructor requires a instance of a class called a item callback. So item callback essentially is just a utility class used to make our recycler view binding a little bit more efficient. There's not a ton of a use for this. It's not a class you'll use very often, only in this one specific use case. So we're not going to dive too deep into the details of it right now, but I will show you how to implement it so that we can take advantage of those efficiencies. So we're going to come down a few lines into our daily forecast adapter, and we're going to type companion object to start, and then open and close curly braces. If you're familiar in Java with the idea of statics, a companion object is kind of bringing that concept to Kotlin. Anything we define in this companion object will sort of exist outside of an explicit instance of this adapter class. So it's just a nice way of defining a type of object or class that is related to our adapter, but doesn't necessarily require an adapter to be relevant. So within this companion object, we're going to type val, and then we're going to call this diff config. I'm typing this in all capitals just to sort of indicate that it's a static, kind of a constant object. And then I'm going to type object colon diff util dot item callback daily forecast, open and close parentheses, and then open and close curly braces. So let's walk through that real quick. So object here basically stands for this is an object expression. It's saying we're defining essentially an anonymous inner class, if you're familiar with that concept from Java. Basically, it just means we're creating a new instance of an unnamed class. And then the colon, again, indicates that we are going to be extending some other class. And in this case, we're extending diffutil.itemCallback. We pass in daily forecast as a templated type to say that this item callback will work on daily forecast items. And now this object line here has a little red squiggly indicating that we need to implement some methods. So I'm going to put my cursor on that. I'm going to hold Alt and then hold Alt and hit Enter, and it should give me the option to implement members. At that point, I'm going to hit Enter, and then I'm going to select both of these member methods here. It should say, are items the same and are contents the same? And then I'll go ahead and hit OK. So that's going to automatically generate these two methods that are needed. And I'm going to delete the code that was automatically generated inside. And now all you need to do to implement this is copy exactly what I'm typing here. So in the first one, are items the same? We're going to type return old item equal new item. So in Kotlin, using 3 equal signs like that essentially is going to tell us whether or not old item and new item are the exact same object reference. Now down below, in our contents the same, we're going to type return old item equal new item. So notice this looks very much the same, but slightly different. We're only using two equal signs. Using two equal signs will return true if the contents of the item are the same, but it doesn't have to be the same object. This is one reason we use data classes, because data classes can have their contents evaluated in this way very easily. So if we have two objects that have the same temperature and the same description, they will essentially be evaluated to true in are contents the same, because they will look the same on the screen. So it is kind of conceptually the same thing for us. So that's how we define our diff config. Now, the whole reason we needed diff config was, again, so that we could complete our list adapter implementation here. So we're going to go back up to daily forecast adapter, go to the end, and we're going to pass in our diff config. And as soon as we pass in diff config, list adapter should no longer have an error. And we should see now just a single squiggly line on daily forecast adapter. Now, similar to with our diff config, we need to implement some methods here. So I'll put my cursor on the daily forecast adapter name, and I'll hit Alt Enter. And again, I'll have the option to implement members, which I will click Enter. And now I have selected both of these as well. So we're going to implement now onCreate view holder and onBind view holder. And I'll hit OK. And so now we are ready to define these two methods. Now, essentially onCreate view holder is going to do just that. It's going to create a new view holder for us. Within that view holder, we will create a new view that will be used to represent each item in our list. And then in onBind view holder, we're going to get each individual element of the forecast items and basically pass that data along to the view holder so the view items can be updated. Now, before we can do that, we need to create a layout to represent our new list items. And so to do that, we're going to create a new layout, and we're going to call it item daily forecast. So we'll come over to our resource directory here. We'll come to the layout folder, right click, new layout resource file. Now within the file name, we're going to type item daily forecast.xml and hit OK. And then go ahead and hit add. So now within this, we're going to keep this pretty simple for now. We are going to leave this as a constraint layout, and we are going to drag over basically just two text views. So I'll drag over text view 1, and I'll drag over text view 2. And now we're going to make sure that these are constrained properly. And then now I'm just going to jump over to the XML to finish this off. So if we scroll up to the top of our constraint layout, we're going to start off by making this height something like 5060p. 5060p is a pretty standard height for a list item when you're just starting. Now for our next text view, I'm going to name this first one temp text. I'm going to leave the width and height both as wrap parent. I'm going to add a margin to the start, and to do that I'll type margin start and select Android : layout margin start, and I'll type 24 dp. Just to have a little preview there, I'll type 70. A little preview there, I'll type 70.0. Now for a text appearance, I am going to use text appearance, and then I think I'll select large. And then now I just want to make sure that all of the constraints are quite right. So I want the bottom to align to the bottom of the parent. So bottom to bottom of parent. I want the start to align to the start of the parent, which it already is. And the top to align to the top of the parent, which again, it already is. So we're good on that first one. Now we'll come to the description view here. So the second text, I'm going to name description text. We're going to use wrap content. I'm going to use 16 for my start margin. For the text, just as a preview, I'm going to type partly cloudy. I'm going to use text appearance medium this time. So that should look like Android : text appearance equals, and then @style / text appearance .appcompat.medium. Again, that's one of those sort of built-in text properties that we can use. Now we want to go ahead and update the constraints here again to make sure it's aligned to that other view as well. So we're going to type app : layout constraint bottom to bottom of, and then we're going to align it to temp text. We're going to align the start to the end of temp text. And then we are going to constrain the top also to the top of temp text. So if I go back to the design view now, we should see that these layouts are sitting more or less right on top of each other. Now let's see, mine is maybe not quite looking right here, so I'm going to just double check here. Let's see, constraint start to start of parent, top to top of, bottom to bottom. Okay, so maybe that is looking okay. Let me check the second one, the description text. Oh, yep. No, there's an issue in my one of my constraints in the second one here. So this should say constraint start to end of. There we go. All right, yep. So now when we come back over here, this looks as we would expect. We see the temperature, and then we see the description. So now that we have created our view layout, we're going to come back over to our forecast adapter, and we're going to specifically work on implementing the view holder for this. Now, like I said before, the view holder is going to be responsible for binding the individual views, so the temp text and the description text. So I'm going to put my cursor inside of the view holder here. I'm going to hit return once just to give me some indentation. And I'm going to create references to the two views we're going to add information to. So to start, I'm going to type private val temp text equals view dot find view by ID text view r.id.temp text. So what did we just do here? Well, it should look somewhat familiar at this point that we created a property called temp text. We used the private modifier since it shouldn't be visible outside of this class. Now this next part was a little bit different. Remember, in our activity, we could just call find view by ID directly. However, daily forecast view holder is not a context, so we can't call find view by ID on it. However, we do have a view, and so from the view, we can call that. So in this case, view, the view that's being passed in, is the view we just created. So that will align with item daily forecast.xml. Now we also specified the type of this view in a little bit different way. instead of defining it right after the variable by saying colon text view, which we could have done, we used the angle brackets after find view by ID to specify the type. Either way is perfectly fine. So in this case, I'm just going to go ahead and remove it from find view by ID. So now let's do the same for description text. Private val description text colon text view equals view dot find view by ID r dot ID dot description text. Perfect. So now we have access to those views. The next thing we're going to do is write a simple method called bind. Bind is going to get called from the adapters on bind method, and it's where we're going to connect the individual daily forecast item to those views we just referenced. So let's create a new method called fun bind, and we're going to pass in a daily forecast item. Now we can connect the information. So we'll say temp text dot text equals daily forecast dot temp dot to string. So this is going to get the temperature float value, convert it to a string, and assign it to that temp or to that text view. And now description text dot text equals daily forecast dot description. Okay. Now we have our bind method ready. We can scroll down to our adapter. First off, we need to create on view holder. So we're going to create a new instance of a view holder, which will then also inflate our layout for those layout items we've been working with. To do that, we'll start by inflating the layout. So we'll say val item view equals, and now we're going to use a class called a layout inflator, which is basically a class that lets you inflate a layout file that you've defined. So we'll type layout inflator dot from, and now we need a context. So this time we're not in an activity. So how will we get a context? Well, views and view groups have a context. So in this case, we have a view group called parent. So we can type parent dot context. So now we have a layout inflator. We're going to call dot inflate, and we're going to pass in the layout we just created, r dot layout dot item daily forecast. And now we still have two more arguments to pass in. The second one is just going to reference the view group. So in this case, parent. And the next one is going to just be false. So pretty much anytime you're inflating something, it's always going to ask for a parent and whether you should automatically attach the new view to the parent. And it's pretty much always going to be parent, comma, false. So don't worry too much about those parameters. Just know to default to parent, comma, false in most situations. Now, after we have that, item view should now reference that layout. So now we can create our view holder. So we'll type return daily forecast view holder, and we'll pass in item view. So now anytime the recycler view needs to create a new view holder, it's going to call this method. And now anytime it needs to bind a view holder so that it can put new information on the screen, it's going to call onBind view holder. Now in onBind view holder, we get passed back an instance of the view holder we just created. So we can type holder dot bind. Now remember, bind is that method we just called up here, which takes a forecast item and then updates the view values. So we need to get access to a daily forecast item. Now, how do we go about doing that? Well, this is where the list adapter that we extended comes in really handy, because to use the list adapter, it will store a list of these daily forecast items. So that's why we define daily forecast item as the type of item list adapter would work with. So there's a convenient way of us getting access to those individual items. So we can type get item, and we'll see here that get item takes an index representing what position in the list, and it's going to return us back an instance of daily forecast. So I'll type get item, and I'm going to pass in position. Now notice here, position is an argument passed into this onBind view holder method. That represents the position that is being bound by the adapter. So now at this point, we should be able to go back to main activity and create an instance of this adapter and connect it to our recycler view. So let's go down here below where we set our layout manager in main activity, and we'll type val daily forecast adapter equals daily forecast adapter. And now for the kind of next step is to actually set that adapter into the recycler view. So we'll type forecast list dot adapter equals daily forecast adapter. Now we'll go up, and in our, excuse me, like we mentioned before or earlier, in our observer for the live data, we made this note to update our list adapter whenever we got a new set of items. So now we can actually come in here and we can implement this. So I'm going to remove the toast that was just temporary. I'm going to come down below the comment, and I'm now going to type daily forecast adapter dot submit list. Submit list will let us send a new list of items, which will then update what's on the screen. And I'll pass in our forecast items here. And so now we've pretty much implemented everything connected together. So let's deploy this and see what happens. So I'll run that, and I'll switch back over to our emulator here. So now if I type in a valid zip code and hit submit, voila, we see items in our recycler view here. However, notice that we don't really have any scrolling action here. And the reason for that is that we don't need to. We don't have enough items printed out to the screen to require it to actually scroll. So let's play with the styling a little bit more. We're going to go back into Android Studio, and we're going to go back to Item Daily Forecast. And we're going to make sure our constraint layout is selected. And instead of 56 dp, I'm going to change this to, let's say, 80 dp. So you see that increases the size just a little bit. Let's see what this does when we redeploy it. So once again, I'll enter in a zip code. And now you see that our list actually scrolls because the items take up enough space that we actually need to scroll them. Now, again, let's jump back over to Android Studio. So now let's update the color of the individual items that we have here. Now to do that, I'm going to jump back to the XML view. I'm going to go to the top of item daily forecast.xml, and I'm going to set the background color of the constraint layout. So again, to do that, I'll type Android:background. And now I'm going to just specify my own background color here. So to do that, I could type pound, and then I'm going to do something like AA. And so you see that gives me this fairly light gray here. Now that's maybe actually a little darker than I want. So I'm just going to adjust this. I want this to be almost white. So you can play with that color however you want. So now I'll redeploy this back to the emulator. one more time, enter a zip code, and there we go. We see now that we have a different color there. And you'll notice that we don't see the dark gray anymore. Because the items fill the available space for the recycler view, they completely cover up the background color of the recycler view parent. So that's something to keep in mind as you're building your UI, and think about the way the background colors interact with one another. Now, back in Android Studio, just to do good practice here, we're going to come to our values directory. We're going to go into colors.xml. I'm going to create a new color dimension resource called forecast item background. And I'm going to pass in that color that we just defined. And now we'll go back over to item daily forecast, and I'll replace the background to use that color resource. Now, like we saw at the beginning of this, we want to display some nice touch feedback whenever the user starts interacting with our list item. It's a really good way to let the users know that they're actually tangibly touching what's on the screen. To do that, we can actually update this quite simply. So once again, we'll make sure that item daily forecast is selected. Now we're going to go to the bottom of the constraint layout tag at the top, and we're going to update two properties. So first, we're going to update the foreground property, and we're going to use a special foreground attribute called $ATTR/selectable item background. Now what's happening here? Because this looks a little bit confusing. So first off, Android foreground, that one makes some amount of sense. So you have a background, which is in the back, and you have a foreground, which sits on top of it. Now the next part is confusing. So first off, $ATTR. Basically, that is a standard convention for referencing a kind of a style or attribute kind of present in the theme. So in our theme, we have this property called the selectable item background. Now that's the part that's confusing because we're actually applying it to the foreground, but it works. And what this will do for us is make sure that we have nice touch feedback whenever we interact with our view item. But before it'll work, we need to update one more thing. We need to say Android : clickable equals true. So if you have a clickable item with selectable item background applied to the foreground, we should now see some nice touch feedback when we interact with our list items. So we will submit a zip code. And you see now, when I press on one of these items, I see that nice looking ripple effect. Now it's a kind of a hallmark of material design. So as you're building out your apps, it's a nice touch to add little things like that to it. Now there's one other thing I want to change here in our formatting before we move on. Notice that the temperature values are really long. They're not being rounded at all. And typically if you're building a weather app, you don't need that level of precision in your floating point temperature values. Usually, to the 10th or 100th is plenty. So let's think about how we can change that formatting. So go back to Android Studio one more time. This time we're going to go to our daily forecast adapter class, and we're going to update the bind method of our view holder. So we'll go back up into onBind, and instead of just setting the temp text to the forecast temp.toString, we're going to actually apply some more interesting formatting here. We're going to use the string.format method, which is available in Java as well as Kotlin. And now we pass in a string template here. And now the string template for this type of format is going to look like %.2f. So all this basically says is we're going to pass in a value, and I want you to display it to the hundredths level of precision, or to 2 decimal places. And then I'll go outside that format string, type comma, and now we'll pass daily forecast dot temp. So now if we go ahead and rerun this yet again and switch back to our emulator, I will enter a zip code, and you'll see now we have our nice formatted temperature to the hundredths level of precision, which looks much nicer. So feel free to kind of play around with the UI of these individual items. But I definitely encourage you to format your string like this, and it will be part of the homework assignment as well. So now we can interact with this. We get the nice touch feedback, but nothing actually happens when we click on it. So we want to actually go back and implement click handling to our adapter and our recycler view. And now to do that, we're going to start off by coming to our adapter, and we want to define a parameter on our adapter that will define the function to be called whenever a list item is clicked. So I'm going to click inside the parentheses on daily forecast adapters constructor, and I'm going to hit enter to give us a new line. And then I'm going to type private val click handler. So I'm creating a private read-only property called click handler, and it is going to be of a type function, which takes a daily forecast item and returns unit. So this is the first time we've really seen functions used in this way. Functions are a valid type in Kotlin. So we can actually pass in parameters or save variables that are functions. So in this case, we will have to pass a function that takes in a forecast item and then returns unit, which is the same as void essentially from Java. Now, what will we do with this click handler? Well, if we go to on bind view holder, after we bind the data, we're going to set a click listener on that item view. So we'll type holder dot item view dot set on click listener, and again, then we're going to use a lambda here. Now within that lambda, which again, inside the lambda is what happens anytime that view is clicked, we're going to invoke the click handler that was passed in to our adapter. And then again, to get the item for that position, we're going to type get item position. So now what'll happen is we will click that item, we'll get the forecast item for that individual view, and that'll be passed back to whoever called it. Now we need to actually pass in that callback within main activity. So we'll come to where we have defined our adapter, and we need to pass in a function. So we could pass that function in by clicking inside the parentheses and doing an open and closed curly brace like this. However, in Kotlin, we actually can take use of a nice language feature, which says that anytime you're passing a function to another function, if the function you're passing is the last argument, you can pass it outside of the parentheses. Now that's kind of a mouthful. Basically, it means if you have a constructor or just a regular method or function like this that only takes a function parameter, then when you pass that function in, you can do it outside of the parentheses like this. This is called trailing lambda syntax, and basically just becomes a more fluent way of passing in these types of callbacks. So now inside of this is where we're going to actually handle our feedback, or the click feedback. So what we're going to do to start is just display a simple toast that says toast.makeText. We'll pass in this. We'll say clicked item, comma, toast.lengthShort dot show. So now let's run this just to validate that everything is connected properly. So again, pass in a zip code. I will click on an item and see each time I click on an item, we're displaying our toast at the bottom of the screen. So that's awesome. That is all working as we would expect. Now I just want to clean that up a little bit by taking advantage of some string templating. So we'll go back over into Android Studio here. Now, I've mentioned previously, it's nice practice to take advantage of string resources anytime you're displaying a user string to the user. This is mostly for localization. So instead of passing a hard-coded string here, let's go into values, strings.xml, and we're going to create a string resource for this. So we'll type string name equals forecast clicked format. Now the reason I added format to the end is that we're going to define this as a formatted resource string so that we can pass in the temperature and description and have a nice consistent formatting to that, and then can also still localize it down the line if needed. So in our formatted message, we want it to say forecast : and now we're going to pass in 2 formatted parameters to this formatting string. Now the syntax for this is a little odd, so we'll walk through it. So to define your first formatting string, we're going to type %1 $.2f. Now that should actually look quite familiar to the string formatting we did previously in our list item. The only real difference here is the addition of the %1 and then the $sign. So %1 says this is the first formatting string, or the first argument should go here. And then the $.2f says we are going to use a float to the precision of 2 decimal points. Now I'll hit space and I'm going to define the second format parameter. So this will be %2 $S. This one simply indicates we're going to use a string for the second one. So now if we go back over into our main activity, we can make use of this new formatting string to get a nicer looking toast message. So instead of just the hard-coded string in the toast, we're going to type val message equals get string. Remember, get string is a special method on an activity that lets you get access to string resources directly. And then to get that, we need to pass in a string identifier. So in this case, it's forecast clicked format, comma. And now we can pass in any number of arguments, and those arguments will be used to fill in the string template parameters. So to start, we're going to type it.temp, comma, it.description. Now, just to review again, remember anytime you see it means that it is referring to whatever value was passed into the lambda. It's an implicit receiver type within that lambda. To be a little bit more explicit, we could call this forecast item with an arrow. By doing that, we rename that implicit receiver type. And so now instead of saying it.temp, we say forecast item.temp. So it's a little bit more code, but much more explicit and easy to read. So now that we have our message, we can create the toast with it. So we'll say toast.makeText, this for the context of main activity, pass in message, toast.lengthShort.show. And let's redeploy. Go back to our emulator here. Submit a zip code. And now we'll click on our list. And we'll see that it is displaying out the specific data that we are calling on it. So that is great. We now have everything clicked up or hooked up properly. Clicks are working properly. Really, that's the key stuff there. That's how Recycler View works. It's how to create an adapter, a view holder, bind the data. All of that's great. So the only other little bit of stuff we want to do here is to pseudo randomize this data just to make it a little bit more interesting. To do that, we are going to go back into our repository. And now this will start to show you the potential value of the repository. So we've done all this work now to bind our data, to update it to handle clicks. So now what we're going to see is that now we can change how the repository data is created and loaded, but it won't matter. The rest of the code won't have to know how it changes, which makes this nicely decoupled, and we can work on them somewhat independently. So what I want to do now is come into our repository, and I'm going to create a new private function, private fun, and it's going to be called get temp description. And it's going to take in a single float parameter called temp, which will represent the current temperature value that we have generated in our previous random number generation. And then it's going to return us back a string. So what we want to do here is basically let us add some interesting flavor text so that our list items look a little bit different. So instead of all of them saying partly cloudy, we can customize our own little messages. So you could start by doing something like 75, it's 275, it's too cold, cold, else it's great. So let's just start with this for now. So how can we make use of this? Well, up above in load forecast, when we're creating our daily forecast items, instead of hard coding in the string partly cloudy, we're going to call this get temp description function and pass in the temperature. So now we're going to rerun that and see what happens. Code. And so now see that any of those temperatures below 75 degrees simply say it's too cold. And the only one in this case that basically is above 75 says it's great. If we were to submit a new list here, we see now we have different values. So let's go back over to Android Studio and expand on this. So this is one way of doing it with a simple kind of single Boolean conditional. Now, what if we wanted to take advantage of more ranges here? We wanted to do something really interesting. Well, in this case, we could take advantage of what's called a when expression. So we'll type return when, and we'll pass in temp, and then use open and close curly braces. When is very similar to a switch statement in Java. It's going to let us evaluate multiple sort of conditions in a more efficient way than using if, else, if clauses. So what we could do here then is actually take advantage of something called ranges in Kotlin. So what I could do here is say in float dot min value dot range to 0, I'm going to assign the value of anything below 0 doesn't make sense. So that's saying is basically in the range of all numbers from the smallest possible float to 0, we're going to return this same string here that says anything below 0 doesn't make sense. Now we could define another range that says in the range of 0 to 32f, cold. And now you could go And now you could go ahead and kind of continue filling that out. I have a version kind of pre-saved, so I'm just going to copy that in here. And then I'll kind of just walk you through this. This is going to be something, though, that feel free to customize to your own liking here. But basically, in mine, I have range that says, from 0 to 32, return one thing, from 32 to 55, 55, 65, 65, 80, 80, 90, 90, 100, and then 100 to maximum. And then at the very bottom, we just have this else clause just as kind of a fallback in case for some reason a value doesn't fit into these other ranges. And so you could customize this really however you want. Ultimately, once you deploy this, it should make your list, though, appear a little bit more interesting because there's going to be just more variation to it. Now, one other thing here that we're going to want to do is just add some more items. So remember before, we started in our load forecast function by creating 7 random values. So this was essentially simulating returning 7 forecast items for the current week. So what if we wanted to do a 10-day forecast? Well, we could simply change that 7 to a 10 and then redeploy. And you see now our list is longer because we now have 10 items instead of 7. So all this right here is simply to illustrate that the repository encapsulates this logic for how many things are actually created, loaded, and returned. Once we are properly consuming the live data coming from the repository, the view layer, which in this case means the activity, it doesn't have to know where that data is coming from. The repository layer is then free to change how that data is created or retrieved any way it needs to, and everything continues to work. So later on in this course, we will eventually update Forecast Repository here to pull from an actual real weather API and potentially handle cached data as well and manage the interplay between returning a cache versus returning the network data. So we'll continue to expand on everything that we've built upon in this week's lecture. But for now, that brings us to the end of the programming content for this week. So if we just go back over to our notes here. So just as a quick review, we implemented a recycler view. We implemented a recycler view adapter using a list adapter. We created our view holder. We created a new layout for our item views. We connected the binding code and we added click listeners as well as touch feedback. And then we added some pseudo randomization in our repository to make our data a little bit more interesting and visually appealing. So we're going to continue to build on all of this as we move forward. But for now, this is the general idea of how to take potentially any number of items, efficiently bind them and display them in your user interface and allow your users to interact with them. So like every week, go ahead and check Canvas in the week 3 module for additional resources related to recycler views, as well as for the assignments, which will essentially outline the steps we walked through in the lecture today, and you will get your own opportunity to create a recycler view and scrolling data in your app. And I will catch you all in the live lecture and next week's week 4 lecture content. Hey everybody, welcome back to week 4 in our ongoing course into Android development. This week, we're going to be taking a look at how we can add a new activity to our application, how we can navigate to that new activity using an intent. We'll also discuss some of the ins and outs of intents, including the difference between an implicit intent and an explicit intent. Then we'll introduce a couple of new UI elements, specifically menus and dialogues, and we'll work with those to build out a simple menu for controlling whether or not to show our temperature data using Fahrenheit or Celsius. And then finally, we will introduce the concept of persistent data storage, and we'll use shared preferences to save a setting that controls whether we show temperature using Fahrenheit or Celsius. So let's go ahead and jump over to our slides for this week's lecture. Just to give us a quick overview, we'll start with a quick project demo showing what we will build this week. Then we'll jump into using multiple activities, how to create and navigate additional activities within our app. Then we'll explore menus and dialogues and see how to create and show each of those types of elements on the screen. And finally, we'll wrap things up by exploring shared preferences and how to save and retrieve simple key value data using the Shared Preferences API on Android. And then finally, at the end, we will walk through the coding assignment for this week and show you how to implement all of this stuff in your weather app. So now let's take a quick look at what we will be building this week. So this is roughly what our app should look like. We're going to create this new activity, this new screen here called Forecast Details, and it's going to display clicked weather data in what's known as a details view. Essentially, this is going to allow us to click on a list item and then expand the data for that forecast and show it all here in the Forecast Details screen. Then we're going to add a menu. And when we click the menu item, we're going to show a dialog like the one in the second image here. And that dialog will allow us to choose between Celsius and Fahrenheit for our display units. We'll then save that setting so that when we restart our app, the app will show the temperature data using either Fahrenheit or Celsius. So for this week's project, we're going to have several key things. We're going to create a new activity called Forecast Details Activity. We're going to pass clicked forecast data to Forecast Details Activity and display it on the screen. We will then create a menu with a single menu item, and that menu item will help us control the temperature display unit. When we click on that menu item, we're going to show an alert dialog. And then finally, we are going to update our UI formatting based on that selected setting. And that will be done using whatever setting is stored in shared preferences. So if I jump over to my emulator here and I open up the app, we can walk through what we'll be building this week. So at the end of week 3, you should have something that looks like this. You should be able to enter a zip code and then display that data in a scrolling list that has some nice touch feedback. This week, when you click on an item, we will open up into our details activity. If you then hit the back button, we'll go back to the main activity. Within the details activity, we're going to display the same weather data that was present on the list. Up here in the right-hand corner, we'll see that we have 3 dots indicating that we have a menu in the app bar. If we click that, we'll see we have added a single menu item with the label Display Units. When we click on that, we're going to show an alert dialog. That alert dialog is going to let us choose between Celsius and Fahrenheit for our display unit. In this case, I'm already showing in Celsius, so I will select Fahrenheit, and I'll see a message saying that that setting will take effect on app restart. So if I then restart my app and enter in a new zip code, we'll see all of this data is now properly showing in Fahrenheit. So that's what we will be working on this week and building up in our assignment. And it's also what we will be demonstrating later on in this lecture when we do the coding portion. So our first topic this week is using multiple activities. and specifically how to create and navigate to additional activities within our application. So how do we navigate to a new screen? Well, there's a few ways we can go about it. But to start, we're going to be using a new activity to navigate to a new screen. So to do that, we will create a new activity class. We will then declare that new activity in our Android manifest file, and then we will navigate to that new activity using an intent. So to create a new activity, we will replicate what we have done with the main activity in our existing application. So we could create a new activity.kt file, and then define a new activity which extends from activity. And within that, we will then go on to overwrite things like onCreate, and we will implement the rest of our activity. So hopefully that should be fairly familiar to you. Next, we will need to declare our new activity in the manifest. So as we talked in the week 1 and 2 content, our manifest defines all of the components that the operating system is aware of. So before we can use our new activity, we need to declare it in the manifest. And that can be done in a single line if we want it to be. And we simply need to add the activity tag and then the name of the activity. And now the more interesting new bit. How do we navigate to this new activity using an intent? Well, in this code sample here, imagine we are navigating to a new activity from within a button click handler. So the first step is to create a new intent using a variable like this. So I've defined a intent variable called intent, and then I've created a new instance of the intent class. The constructor of the intent class takes in a context. So in this case, I've passed in this to reference main activity. And then you pass in the activity that you want to navigate to. So in this case, I've defined new activity, and you need to use a fully qualified class name here. So I've said new activity : class.java. This is just a special syntax you typically need to use only really when working with activities. So once we have our intent defined, we can navigate to that new activity by calling start activity. So what is an intent? Well, an intent is an object that helps communicate to the system that some action should be carried out. That action could be many different things. We could use an intent to start an activity, to send a message to a broadcast receiver, to send a tweet or an email, or to make a phone call. The makeup of an intent can include a variety of things, but typically it includes some specified action and associated data to go with that action. So here are a couple of examples of common actions. So the action view. And when using action view, you might pass in some type of data for this representing, let's say, a person in the local database. So in this case, the URI for action view content://context/people1 is saying, give me the person, give me the contact in our phone with the ID of 1. And action view is going to say, I want to view that contact information. Similarly, if we pass in that same URI pointing to the person in our phone with contact ID 1, and we use action dial, we will tell the system we want to make a phone call to that person. Now, another common action could be action send, and this might be used in conjunction with extra data like an email or a subject to compose an intent that lets the system know that I want to send an email. So by combining actions, extra data, URIs, things like that, we can configure the action we want to take. Now there's two types of intents. The intents that we just saw, where we're specifying the action like view, dial, send, These are often what's known as implicit intents, but there's also an explicit intent, and we're going to talk about the difference there. Implicit intents describe an action, like action send for sending an email. They basically tell the system what you want to do, but then the operating system is free to choose what component to use to handle that. So that's why sometimes if you want to, let's say, send an email and you have multiple email clients on your phone, you might get an option to choose multiple clients to make that email. Similarly, if you want to send a text message, you might get multiple options like Facebook Messenger, WhatsApp, Google Messages, all of which know how to send and receive a text message. Now, on the opposite side, explicit intents, they explicitly describe a specific app component they want to interact with. So this is how we can explicitly tell the system we want to go from main activity to our new activity or to any other specific activity within our app. Now, implicit intents work off of intent filters, and we've already seen one example of an intent filter in this course. We've seen the intent filter for telling the operating system which activity in our app should launch when we click the app icon. So an intent filter is added to an activity or other app component tag within the manifest file. So we use an intent-filter tag, and within that, we can specify the action and the category that we want to respond to. So another example of an intent filter might be something like this. This could be an intent filter present in, say, an email app. So we might define an action of view some type of data or send to some type of data, and we might use a scheme here of mail to. So now someone could create an intent using send to, and as the extra data that's passed to that, it could include this mail to scheme. You can think of scheme kind of like a URL, but in this case, that URL will just point to an application component on your phone. So if we used this intent, we would likely get options on our phone such as Gmail or Outlook. Data with intents, and we're going to do that this week. So in the case seen here, we're defining an intent to go to our new activity class. We're then calling intent.putExtra and assigning key value pair data to be included with that intent. So in this case, we're passing a key underscore ID and then a string value of student 616. So that's going to say we put the value student 616 at the key of ID. And this is essentially just going into a map so we can get that key value access. Similarly, we're passing the name Peter Parker with a key of key underscore name. And then at the very bottom, we call start activity again, and we pass in the intent. So those extras then, when the intent is handled by a new activity, those extras will be available to us. This is how in our assignment this week, we will pass the weather forecast data from main activity into our new forecast details activity so we can display it on the details screen. Now let's talk about how to display menus and dialogues within our activities. To display a menu, we'll make use of a menu resource. Within that menu resource, we can add individual menu items. Those items are what ultimately get displayed on the screen, like in the screenshot here. Display units is a menu item within a menu resource. Each menu item can be configured, and you can add text and icons to configure the look and feel and the message you're trying to convey with that menu item. And then finally, we can respond to menu item clicks to perform whatever action we want. So to create a menu resource, we're going to create a new file. Menu resources should live within the res/menu directory. So this is similar to res/layouts or res/drawable. Menu is its own resource type that lives within that res directory. And then the individual menus are XML files. So in this case, we've created settings_menu.xml. And the XML for that is fairly straightforward. We have a top level menu tag. Then we have the sort of XMLNS app and Android tags. Those are the same as you see at the top of layouts or the other XML resources. And then below that, we have this item tag. And within the item, we've defined a menu item ID, which we can use to reference the individual item when responding to clicks. And then we've defined the title as well. And if we wanted to do an icon, this would be the place to define the icon. Now, to go ahead and display a menu within an activity, we can do that in the onCreateOptions menu method within our activity. Within that method, we get past the menu for the current screen, and we can use the menu to get a menu inflator and inflate our XML menu into the existing menu. So whatever items are in the menu will continue to be there, and whatever new items are present in settings menu will get added. And then we return true to let the system know, hey, yes, we want to show the menu. Now, once a user has interacted with the menu, it'll call this method on our activity called onOptionsItemSelected, and it passes in the menu item that was selected. So in that case, we can use the ID of the menu item to determine whether or not we need to handle that. So in our case, we are going to respond to the item click if a menu item with the ID of temp display setting was clicked. If that is not the item that was clicked, we will defer to the super.onOptionsItemSelected implementation. Well, we can create and show an alert dialog, which is a specific implementation of a dialog. We can use alertDialog.builder to customize how that dialog will look and how it should behave. We can update things like the title, the message, or the buttons in that dialog. And ultimately, we can respond to button clicks or even respond to the dialog being dismissed. We see in the screenshot here, we have created and shown a dialog, and it has a title of choose display units. We've customized the message to say choose which temperature unit to use for temperature display. And then we've customized a couple of the buttons to display Celsius or Fahrenheit, and we can respond to each of those accordingly. To show an alert dialog, like I mentioned before, we're going to create an alert dialog builder and then customize the properties on that builder. So in this case, I've created a variable called dialog builder, and I've assigned it the value of alertDialog.builder, which is a new instance of that builder class. And then we can call methods on that like set title, set message, and then ultimately the last two there, we see set positive button and set neutral button. There's also a set negative button, so you can have up to 3 buttons in your dialog by default. Set positive button and set neutral button let you configure the label and then also what happens when it is clicked. And in the code demo a little bit later on, we're going to get into the more specific implementation of how to handle that. Finally, at the end, you need to make sure you show your dialog by explicitly calling show on the builder. Once show is called, it will actually then show up on the screen. Okay, now let's talk about saving data with shared preferences. So when we're building our apps, one of the key questions is how to store persistent data. Well, we have a few different options that immediately come to mind when thinking about storing persistent data. We could use a database. We could use files, or on Android, we have something specific for this use case called shared preferences. Databases, you might already be familiar with. Databases on Android are great for storing large, complex data sets. particularly if you have data that needs to support complex queries. Maybe you need to page in data because you have so much you can't load it all at once. You might want to respond to data updates in a reactive way. All of these are good reasons to use a database, like a SQLite database. Databases on Android are often the go-to option for caching network data so that your app works when it doesn't have a network connection. Now, we could also store data with files, and many apps that we use every day do this. We store images, videos, maps, books, audio, etc. We could also use files to simply write out our own custom data. So we could save settings data to these files. We could save and cache JSON responses from the network using files. So really, we have a lot of flexibility with files. But most of the time we're using files for media because we have other options for saving settings and large data sets in the form of databases and then shared preferences. So shared preferences is kind of the default solution on Android for saving simple data. And specifically, shared preferences work using key value pairs. So these are great for storing things like simple local user settings. So like in our demo this week, we're storing a display preference for whether to show Fahrenheit or Celsius. This is something that is not a lot of data. It's not something that needs to be persisted across devices necessarily, so we can store it locally using shared preferences. And ultimately, shared preferences actually are using files under the hood, but the API is nice and it abstracts that away from us. So as developers, all we really need to do is set and retrieve key value pairs. So here's an example of how we can work with shared preferences. So first off, we have to get an instance of the shared preferences class. So here I've defined a variable called preferences, and I've used a context and called get shared preferences. The first argument here, which is a string that says settings, that's the file name. So we can define different sets of preferences that live in different files, or we could use the same file for all of our preferences. That's kind of up to you as a developer. So in our case, we're just going to use all of our preferences in this single settings file. And then context mode private simply says that we shouldn't let other applications use these preferences. So it kind of keeps these settings hidden and private to our app. Once we have the preferences file, we can edit or retrieve data from those preferences. So in this case, to retrieve a value, in this case, to save a value, we call preferences.edit. Edit basically returns us back an object that allows us to change the values that are present. So in this case, we've called putString, and we pass in a key, this time key temp display, and then we've passed in a value. In this case, I'm passing in setting.name. And then once I've added all the data I want to add in this transaction, I call commit, or you could call apply. Either one will work. That commit call is what's going to actually save out all of those key value pairs to the local settings file. Now to retrieve a value, we can say preferences.getString and pass in our key, and it'll go into that file and look for whatever value is there. If it doesn't find that value, we can specify a default so that we can have some type of default returned to us and know that we have something to work off of. All right. So that's the lecture content for the high-level concepts this week. Now let's jump over to Android Studio and we'll walk through the implementation of this week's homework assignment. Okay, we are back here in Android Studio and we're going to get working on adding our new activity this week. Now, before we get started, I'm going to come over to the left-hand side of the screen and look at the project pane here. Once again, I'm in Android view, but the same applies if you are in project view. So here I've navigated to the directory where all of our source code currently lives. And all of this code has currently been living in the same source directory. As we go forward this week, though, and further on in the course, we'll want to start thinking about how we can organize our code so that it's easier to navigate and manage as we continue adding to it. One way we can do this is by organizing things in packages. A package is simply a directory on your computer that stores source code. So in this case, I'm going to come here to the directory all the code is currently in, com.goobar.io 8340. And I am going to right click on that and select New, and then select Package. Now this will prompt me to create a new name for this package. And I'm just going to type details. So the full package name will be com.goobar.io 8340.details. And of course, yours will be customized based on whatever package name you have specified. The key thing here is to make sure that the last bit that we are adding right now is details. So once I've updated that package name, I'll hit enter. And you'll see here that it has created a new directory called details. Next up, we're going to create our new activity. To do this, we will right click on details, select new, then scroll all the way down to the bottom here where it says activity. And then in this little submenu, we will select an empty activity. Once I click empty activity, this new dialog pops up to create a new Android activity. So where it says activity name, we want to update this, and we're going to name our new activity forecast details activity. And we want to make sure the little checkbox is selected here that says generate layout file, because we do want and need a new layout XML file for this new activity. By default, it should pre-populate the layout name. You can do whatever you want here. Mine is going to be called activity_forecast_details. This is a pretty common naming convention for the layouts that associate with an activity. And then go ahead and leave the package name and the source language the default values, and we'll select finish. And then if you get prompted to add the files to Git, go ahead and select add. And so now this should have created a new details activity for us. And in fact, it likely has even automatically opened that details activity for us, as in the case here in my screen. Now, one small oddity of Android Studio to point out is, for some reason right now, it seems to not be automatically importing the resources for you when you generate your new activity. So here, even though I've just created this activity, I already have this error, which is frustrating. However, we can easily overcome this by putting our cursor over that R statement there and hitting Alt-Enter to automatically add the import. And just to point it out, the import here at the top is import and then the package name and then just .r at the end. So that's the activity. That's the first thing that was created for us, is this activity class. However, there's two other things that were done for us when we created that activity using Android Studio. The first is that it created this new layout for us. And so I'm going to select Command and then click on this layout file. If you're on Windows, it'll be a control click. And I'm going to open up into activity_forecast_details.xml. And so right now, this is the layout file for this new activity. And you see here in Design View, it's completely blank at the moment, which is no surprise since we selected the empty activity template. This is what we wanted. Now, the last thing that was done for us when we created that new activity was the manifest was updated. So if we navigate over to our manifests, so in Android View, this should be in the manifests directory at the top of the window there. If you're in project view, the manifest should live under app/source/main. In either case, once you've opened Android manifest.xml, you should have a new activity element in that manifest. Here, it's been organized as a single line of code, and so I'm just going to clean this up a little bit to make it easier to read. But ultimately, we have defined in our manifest a new activity, and we've indicated that the name of the activity is .details.forecastDetailsActivity. So this name, it requires us to specify the fully qualified package name. So if this had been in the top level package, like our main activity is, we wouldn't need any preceding package name here. But because this is in details, we add .details.forecastDetailsActivity. So that just lets the system know exactly where in our source code to find this activity class. So now, if we were to run this activity, we would end up seeing the same code that we saw at the end of week 3. But if we wanted to update this to launch our new activity, we could come down here to the main activity tag, and we could select this intent filter. Now, we mentioned previously that this intent filter is what indicates to the system that main activity should be what launches when we start our app. However, if we move that from main activity to forecast details activity, now when we run our app, it should run forecast details activity instead. And we will run this in our emulator. We go. We've seen now that that activity has relaunched, and we see before we had the list, and as soon as it relaunched, we now just see this blank empty screen, which is our forecast detail activity at the moment. So this is perfect. This is exactly what we would expect. So we're going to come back over now to Android Studio, and we're just going to revert that change and make the main activity the launcher activity once again. Now what we want to do is be able to actually launch forecast details activity when we click on one of our list items in the home screen. So to do that, we're going to go back over to main activity. And what we want to do is launch forecast details activity when we click one of our list items. So the handling of our list item clicks is down here when we are creating our daily forecast adapter. And currently we are displaying a toast message. So we are going to remove the displaying of that toast message. And we're going to replace this with creating a new intent and then using that intent to start forecast details activity. Now to do that, first we will create an intent variable. So we'll start off by typing val forecast details intent. So in this case, I'm including forecast details in the name of the variable to indicate that this will be an intent to launch forecast details activity. Now to create an intent, I type intent and then an open and close parentheses. Now I will need to import this. So again, I'll hit Alt Enter and that'll automatically add the import and fix the compile error. So now I am invoking the intent constructor. To make this an explicit intent, which remember we talked about means that we're going to explicitly tell it what component to launch, I need to do two things. First, I need to pass in a context. So I'll type this to pass in the main activity context. Next, I need to tell it what activity I want to open. So to do that, I'll start typing forecast details activity, : and then class.java. And I know that's kind of a weird syntax. There's really a syntax that is only used in this case of creating intents generally. Essentially, that is pointing to the actual generated Java class for this at the low level for the compiler. So in doing this, we now have an intent that when launched should tell the system that we want to launch the forecast details activity. To actually launch it, we can type start activity and pass in our forecast details intent. Start activity is a method on an activity that lets you go from one activity to another. So now, if we rerun this once again, we should be able to switch over to our new forecast details activity when we select an item. So if I type in a zip code and I select a list item, we're now taken over into forecast details activity. So we've now successfully navigated from one activity to another one for the first time. Now let's go back to Android Studio and let's make our forecast details activity layout a little bit interesting. So we'll go over to forecast details activity and we'll see here that currently we aren't doing anything. We're not customizing the UI in any way. It's just blank. So the first thing we want to do is update the name of this activity so that in our app bar, we have more of an indication of what's going on that screen. To do that, we're going to go to the left-hand screen over here into the Android or project window again. We're going to go to strings, and then we're going to create a new string resource called forecast details. So I'll type angle bracket string, and for the name, I'll type forecast details. So that's the resource name. And now for the actual string to display, we're going to type forecast details. Now we want to use this to change that activity title. So if I go back to forecast details activity, I'm going to hit enter a couple times to give me some space below the set content view call. And I'm going to type set title. Set title is a method on an activity that lets you do just what it suggests. It lets you set the title for that activity. And then by default, that title will get used in the app bar of applicable themes. So if I pass in r.string.forecastDetails and then rerun this, we'll be able to see that new forecast details title in the app bar here of our emulator. So if I go back over to Android Studio now, we're going to customize the layout of our activity forecast details XML file. So I've come over here into the XML, and I want to make sure I'm in the design view because we're going to do this visually. So the first thing we're going to do is come to the palette view here, click on the text option. You could also use the comment option here, either way, but we're going to grab a text view element and we're going to drag that into our layout here. And I'm gonna increase the size of this a little bit, make it easier to see. So I've just dragged a text view into our layout editor here. And the next thing I want to do is just kind of clean up some of the common attributes here. So by default, I don't want it to say anything because we're going to specify what it should say later. So if I clear out the text property here and hit enter, we'll see that it takes away the text. So this is a good thing, but it also is a challenge for us because now we don't know what this looks like. Well, there's a useful tool that we can leverage here to solve this problem, and it's actually called the tools text attribute. So if I go into this common attributes drop down again here, and I see the text attribute that we just edited, and then there's this other text attribute that has a wrench next to it. This is the tools attribute. And if I type 75.4 degrees and hit enter, we'll see now magically our text view has text again, even though the Android text attribute's not selected. I'm going to come over to XML just to illustrate again what this actually is looking like here. So we see this attribute right here that says tools text 75.4 degrees. This is different than the Android text attribute. Basically, some attributes like text have this tools attribute with it that lets you set how to preview that in the editor, but it won't actually be applied at runtime. It's just a useful way to help build your UI without having to remove that text at runtime in your code. So here again, we have our temperature text view, and we've set our tools text to some temperature preview. The next thing I want to do is make sure I have the text view selected, and I'm going to change the ID property to temp text. And we'll use that ID later when we reference this view to set the temperature ID. And now I want to make sure that this is properly constrained. So I'm going to grab the little arrow, constrain it to the left-hand side of the parent. Then I will also constrain it to the right-hand side of the parent and the top. And so by default, this is going to put it at the very top, and it's going to center it. Now I don't really want it centered. I don't want it to actually hug the left-hand side of the screen. So I've come here into the layout tab of the attributes panel. And down here towards the bottom of this little rectangle, there's this slider that indicates horizontal bias when you hover over it. This horizontal bias is basically there because we have constrained ourselves to the left and right-hand side of the parent. The bias lets us indicate whether we want to prefer one side or the other. Right now it defaults to 50, so we're right in the middle. However, if I drag this over to the left, we'll see that our view is going to drag over to the left as well. So that is what we want, because we want it to start from the upper left there. However, there's one other small problem here, which is that it's hugging the top and left directly. It's right up against the edge. And generally in good design, but specifically good like Android material design, we do not want to have our elements directly to the edge of the screen. What we want to do here now is add some margin. And we can add margin in a couple ways, but the easiest is to come over here again into the little layout panel here. And where we have this rectangle again, we see these little drop downs that all say 0. That 0 value right now is indicating that we have 0 margin between the edges of this element and the edges that it is constrained to. If I come to this little left-hand drop down here, and I select 16, we'll see that it pushes the text view away from the left edge by 16 dp. Now we can do the same to the top here. I'll select 16, and you see now it's pushed it down. And then I'm going to add 16 to the right as well, although we're not going to really see any visual indicator of that at the moment. So now our text view has some spacing between it and the edge of the screen. You could also set your margin in the XML. So if I come back to the XML view here, and I look at my text view, I see several attributes all mentioning margin. We see layout margin start, layout margin top, layout margin end. We could also set these all at once by just typing layout margin 16 dp. The layout margin will apply that same margin to each of the specific edges. If I come back over here now into my view or my design view, we'll see that I still have the layout margin here. Although you don't see the individual values anymore here in the layout panel. Although you do still see that down here, we have some margin along those constraints. So there's a little bit of disconnect there. What I would recommend is to just go with the design view on this one and leave the margin applied to the individual elements because it's more explicit and the tooling works better with it. You see, as soon as I added back those individual elements, I see my margin values back here in the visual editor again. So now that we have that text view sort of updated, we're going to walk through the same process again. We're going to add another text view by dragging it over. And we're going to, once again, clear the text property by coming down into the Common Attributes drop-down panel here. I'm going to clear the text property, and I'm going to update the Tools text property to say partly cloudy. So now I have a new text view that is going to contain the description of our current forecast item. Now, how do I want to position this on the screen? Well, I want this to align to the left-hand side of our other text view and be below it. So I will select the partly cloudy text view here, and I'm going to grab the little arrow on the left-hand side here and constrain it to the arrow on the left-hand side of the temperature text view. And then I'm going to grab the top circle here and drag that up to the bottom circle of the temperature text view. And so now those are constrained together. If I were to move around the temperature text view, we'll see the partly cloudy one would move with it. And just to kind of review what that looks like in the XML, we see here, this is our new text view, and we've said constrain start to start of temperature text, constrain top to bottom of temperature text. So if we go back over into the design view, we have now constrained this. We want to make sure that we apply our ID attribute. So the ID of this one is going to be description text, because it'll hold our forecast description. Now, this layout here, it's fine. It shows us the data, but it's not very interesting to look at. So let's change that before we move on. Let's go ahead and select the temperature text. And then we are going to scroll down to the Common Attributes panel here over on the right-hand side. And where it says Text Appearance, we're going to click this drop-down, and we're going to scroll down to the Display 4 option. And so you see that immediately makes it really, really big. In fact, possibly a little too big. So let's change and select Display 3 instead. And that's looking a little bit better to me right now. It's not quite so overwhelming. So next then, I'm going to click on the description text, do the same thing, come over to the Common Attributes dropdown in this Attributes panel here, go to the Text Appearance attribute, select the dropdown, and I'm going to select Display 1. And so again, it's going to automatically apply that text appearance style to that text view. If we were to look at this in the XML, this is what it would look like. Each of our text views now has this Android : text appearance attribute. And the style is referenced using @style textappearance.appcompat.display1 or display3. So those are predefined styles available to us from the appcompat library that was automatically added to our project when we first created it in Android Studio. Using these text appearance styles is a really nice way of leveraging sort of the default material design guidelines around text and really make your app look nicer when you are building your UI. A nicer looking and non-empty layout
file defined here. Let's redeploy and a non-empty layout file defined here. Let's redeploy this to our emulator and check it out on the screen. So I'll go ahead and click redeploy, and we'll switch over to the emulator. I will now enter my fake zip code, click on an item, and we are here in forecast details screen, but it's blank. Why is that? It's not blank in the design view, but it's blank on the emulator. Well, this goes back to that tools text attribute we talked about. So in Android Studio, again, we are seeing text on the screen because the tools attributes are defined, but the actual text attribute, which is the one that gets shown on the screen at runtime, that one is still empty. So to fix that, we need to go into our forecast details activity, and we need to actually set some values into those views. Before we can do that though, we need to reference our views like we've been doing in our other activity. So to start, we'll type val temp text equals find view by ID. And for the template, we'll type text view since that's the type of element we want to work with. When prompted to add the import, we'll go ahead and hit Alt Enter to automatically add the import up at the top. And now in the find view by ID parameter list, we will pass in r.id.tempText. So that gives us a reference to that temperature text view. And now we'll do the description view. Val find view by ID. We'll view by ID. We'll specify text view. And we'll pass in r.id.description text. So now we have references to both views. Let's just put in some placeholder text so we can see what this looks like on the screen. So we'll say temp text equals 81.2 degrees, and description text equals mostly sunny. So now let's redeploy this one more time. And I will enter my zip code. I will click an item. And now, finally, when we open up forecast details, we see some actual interesting information on the screen. It's not just a blank activity anymore. So that has been the first step in this process. We created our activity and we've updated the UI to be ready to display the forecast information. So now our next step will be to actually pass in the needed information from whatever item we clicked on. Now that we have successfully linked our list items to launching forecast activity, the next step is to actually pass the clicked item data over to that activity so we display the same information that we clicked on. So how do we actually go about doing that? We need to somehow pass that clicked forecast item to the new activity. So let's start by going over to main activity. We're going to kind of scroll down to the bottom. We're going to create a private method called show forecast details. And this is going to consolidate all the information we need to show that new activity with the required data. So to do that, we're first going to grab the intent creation and the call to start activity. And we're going to just move those into our new method down at the bottom. So it's just a simple copy and paste. And now here in our adapter click handler, we're going to replace those with the call to show forecast details. So now still, once it's clicked, we're going to come down here and it'll call show forecast details. So now we have our intent. We want to pass the temperature and the description along with this intent so that when forecast details activity is opened, we can display that on the screen. So to do that, we can use intent extras. To add an intent extra, we first reference the intent variable and we type dot and then put extra. And you see here that we have a lot of overloaded put extra methods here. So all of these work off of key value pairs. So we could use a string always for the key value, but then we could use things like integers, booleans, floats, strings. We can pass in a number of different data types as the value. So for us, in our first case here, we're going to pass in key underscore temp as the key. So this will be the temperature value. And now we need the actual forecast data. We need to know what it is. So we need to pass that from the adapter click listener to this method. To add a parameter to a method, we'll click into the parentheses there of the method. And we're going to first type the parameter name. So in this case, that will be just forecast. Then we'll type a colon, and then we need to specify the type of that parameter, which in this case is daily forecast. So remember, that's our model that we defined last week. So now we are passing in a forecast item. So in our put extra call here, we can type forecast dot temp. And now for the description, again, forecast details intent dot put extra. This time we'll use key underscore description for our key. And then we'll pass in forecast dot description for the value. Now, the only thing we need left to do is to pass that forecast item in from our click adapter. So we could do that by either typing just it, or we could be a little bit more explicit and we could come within our Lambda and we could rename that it receiver parameter to forecast. So it's more clear that this is a forecast item. And now we can type forecast here and pass that in. So now what's happening here is when you click on an adapter, we're being returned the specific forecast item that you clicked on. We're then passing that to the show forecast details method. And here we're creating a new intent. We're putting that forecast information into the intent as extras and then starting the activity. So now if we go to forecast details activity, how do we actually get those extra values out of the intent and into our text views? So if we come here into onCreate and we go a couple lines down below where we get the reference to our views, we can get access to that intent extra data. So to start, let's just show how you could use that to get the temperature. So we'll type val temp equals intent dot get float extra key temp, and we'll pass in 0 as a default. So this is the full line. Let's break this down a little bit. So first off, we create a temperature variable. Hopefully no surprises there. The next thing though is referencing intent. So forecast details activity have an intent. Any activity has an intent that was used to launch it. And we can reference that in Kotlin by simply typing intent. You could also replace this by typing get intent, but typing just simply intent is the preferred idiomatic way of doing it in Kotlin. This is what's known as property access syntax. Instead of using the getter called getIntent, we can just reference intent directly. So it's a little simpler. So we type intent, and then on an intent, just like we could put extras into it, we can get extras out of it. And so for us, our temperature value is a float. So we use the getFloatExtra method, and then we use the same key that we put the data in with to get it out. And then we pass in a default value just to handle that error case in case for some reason that property wasn't put in. So with this, we can get that temperature data and set it into our text view. So let's actually update that now. So down here where we had our temp text, we are going to create a new format string using Kotlin string templates. So to do that, I'm going to type $, and then open and close curly braces. Now within that, we will define the code that's going to get the temperature value for us. But to just complete the formatting, we're going to add the little degrees sign so that this will read as, whatever float value degrees. Now we're going to copy that code for getting the float extra and place it down inside that open and close curly braces. So this is going to take that float value, convert it into a string, and add the temperature value to that. Now let's do the same thing and grab the description. So we'll say description text.text equals intent got get string extra key description. And now we can redeploy this. So we will enter a zip code. We'll see here we're going to click on this item that says 74.87. And we see over in our new forecast details screen, we see 74.86745. So this is the same item, although the rounding is a little bit different. So let's go ahead and update how this looks. So we'll go back into Android Studio and to illustrate one other point that you might run into, we're going to go back to our layout. So let's set this to display 4 where the text was much larger, and redeploy this and see what this looks like. So again, zip code. So now with this really large text, having those extra decimal places has moved this onto a second line. Now, if you are on a really big screen, this might not be an issue, but this emulator of mine is simulating a much smaller screen, and so I'm running into multiple lines. However, I don't want this in my UI. So how could I go about fixing this? This is a very common problem in building UI for mobile devices. So to fix this, we have a few options. We go over to Android Studio, and we're going to go into the XML view for this layout, and on the text view attribute, we are going to add a new line here, and we're going to use this property called max lines and pass in a value of 1. And then we're going to use another attribute called ellipse size and pass in a value of end. So what this should do for us is say only make this line one line of text, and if the text can't fit in that single line, then add the 3 little dots for the ellipses at the end of it. So if we come back to the design view here, nothing has really changed. However, you could try and verify what this is going to look like by changing the device preview for this layout. So right here where for me it says pixel, I could scroll down to the bottom and you could customize or use these different device skins to see what it might look like on different device sizes. So for me, I'm going to use this custom one I have at the bottom that is for a smaller device. And we see here that it shows that the text is definitely larger, but because it's only 1 decimal place, I don't have a problem. To simulate the problem we're seeing on the real device, I could update the text to say something like 75.43212 and hit enter. And we'll see now that this has not wrapped onto a second line. It is thankfully still on just the single line here. However, it's not really honoring the ellipse size that we added. You also, and it might be hard to see here, but it's no longer respecting the margin that we had defined either. This is because of the way we have set up our constraints. So if we go to our layout tab here, we'll see that the width by default is set to wrap content. And many times wrap content is perfectly fine for working with text views, even within a constraint layout. However, if you have some text that you really do want to constrain to like a single line or a couple lines, and you want to make sure the width is roughly a static size, as in our case here, instead of using wrap content, what you want to do is use 0dp. 0dp will make sure that instead of scaling the text view to wrap the content no matter what the constraints are, it'll honor the constraints and limit the size. So as soon as I've done that now here in my preview, it has adjusted that to honor the constraint and show that margin on the right hand side. So if we now run this on our device, we should be able to see some of these effects taking place. And now we see our text view is no longer wrapping, and it's adding the 3 dots. We see our text view is no longer wrapping, and it's adding the 3 dots of the ellipses at the end to indicate, yes, there's some additional temperature data here, but we're not going to wrap onto the second line. So that's fine. That's one way we could solve this. However, we already saw last week that we can format the text to have just 2 decimal places if we want. That's what we're doing on the list value here. So let's think about how we might replicate that formatting and use it on our details activity as well. So go back over to Android Studio, and the first thing we should think about is, well, how are we doing this before? Well, for last week's assignment, we were formatting that data in our view holder. And we were using this line of code here. We were using the string.format method. So we're going to copy that method, and then we're going to go into our project view over here on the left-hand side of the screen, and we're going to right-click the top-level package, select New, Kotlin file, and I'm going to create a new file called forecast utils and hit enter. In this utils file, we're going to create a new function that will define this formatting for us, and then we'll be able to reuse that function in multiple places. So I'll create a function called fun format temp for display. And it's going to take a single parameter, which will be the temp value as a float. And then this is going to return a string. So we'll add colon string as our return type. And now within the function body, we will type return, and we will paste in that line of code that we took from the view holder. So we'll type string.format. We'll pass in our formatting string for 2 decimal places. And then we just need to update the temperature reference there. So now we have this reusable bit of code for formatting the temperature data. So if we go back over to the view holder here in our adapter class, we could make use of that by replacing the formatting function with a call to format temp for display, and we'll pass in daily forecast.temp. And so now we want to basically do that same thing, but in our forecast details activity. So here we'll create a new variable called temp, and we will get the temperature value out of the intent like we did before. So using intent.getFloatExtra. And then we can assign the value to temp text as format temp for display, and we'll pass in that temp value. So now if we rerun this, now we'll see that even in forecast details activity, we only have 2 decimal places. So this is nice. Now we're being consistent. However, one thing that's missing is we don't have the little degrees symbol after the value. Well, we can now update this for both screens in a single place since we consolidated that functionality into a single function. So if we go back to Android Studio, we go to forecast utils, I can come into my formatting function here and just add the little temperature symbol. And if I rerun this, now when I display the list items, we'll see that they all have the little degree sign. And now when I click in, it also has the degree sign. So consolidating that common logic into a single helper method is a huge win for us, because now anywhere we need to format this temperature data, we can do it in a single spot, which just makes it easier to maintain moving forward. Now that we are displaying the formatted temperature correctly, we want to dive into how to display a settings menu and how to display an alert dialog, and how we can use those working together to build some simple settings into our app. So the first thing that we want to do is create a menu resource directory. To do that, I want to come over to the res directory in my project. Once I've selected the res directory, I'm going to right click, go to New, Android Resource Directory. And where it says resource type, I'm going to select menu, and it should automatically then change the directory name to menu as well. And I'm going to go ahead and hit OK. So you see now underneath the res directory, along with drawable and layout, bitmap and values, we now have a menu directory. So now right click on that menu directory, select New, Menu Resource File. Once I've selected Menu Resource File, we're going to give it the name settingsmenu.xml. And I'm going to go ahead and click OK and add that file to Git. So this has now pulled open this design editor for the menu, and it works very similarly to how the layout design editor works. I have a palette here on the left side of the types of items that we can add to our menu. So I'm going to start, and I'm just going to grab the generic menu item, and I'm going to drag this onto the design editor here. And oops, it accidentally dragged 2 over, which we don't want. So there we go, just a single item over. And now if I click that item, I can update properties on it just like I can with a layout item. So I'm going to set this ID to temp display setting. And again, that's over in the comment attributes panel on the right hand side. And I'm going to set the title to display units. Now, ideally, this would be done using a string resource, However, I'm going to leave that as an exercise to you in the homework to implement this using string resource. So for now, I'm just going to define this using a hard-coded string. Now we're going to go open to our forecast details activity, and we want to inflate this menu when the activity is created. We want to be able to see that menu. To do that, we're going to come down and we're going to make use of a method called onCreateOptionsMenu. So if you start typing onCreateOptionsMenu, it should auto-populate that for you eventually. Within onCreateOptionsMenu, we're going to do a couple of things. First is we're going to get a reference to the menu inflator. And we can do this by typing val inflator : menu inflator equals menu inflator. So we can get direct access to the menu inflator from an activity. And the variable here is just helping us leverage that. Then we can type inflator.inflate. This is very similar to working with layouts, and we'll pass in r.menu.settings_menu, and then we will pass in the menu that we are getting as a parameter in createOptionsMenu. And then we will return true. Returning true here simply indicates like, yes, we've handled this. We want to show the menu. So now if we redeploy this, we should see our menu when we open up the details activity. And so see, we do. In the app bar, we now have the 3 dots, which on Android indicate that there's a menu. If I click that, we see the display units menu item that we had added. And if I click that, currently nothing happens. So let's fix that. We'll go back over to Android Studio. And to handle clicks on menu items, we want to use a method called onOptionsItemSelected. So the activity methods refer to options menu and options item. Those are essentially the items or the quote unquote options within the menu. So within onOptionsItemSelected, we're passed in a menu item, which is whatever item was clicked. So to handle item selection, we can basically check the ID that was clicked and respond accordingly. So to do that, I'm going to start off by typing return when item.itemID. So what this is saying is it's going to return the value of this when expression. This is very similar to a switch statement in Java. We've passed in item ID, so this is going to let us compare different values of the item ID. So the first case that we want to concern ourselves with is r.id.temp display setting. So now we have defined a case, which is if the ID is temp display setting, we will do something. Else, and in the else case, we're going to just return super.onOptionsItemSelected. So now, in the case where the user has selected our display setting option, for now, we're just going to show a toast. So we'll type toast.makeText this clicked menu item toast.lengthShort.show. And then we need to make sure that we return true to indicate that we handled the click. So if we run this now, when we click that menu item, and there we go, click that menu item, and there we go. So click the menu item, see a toast. So that's menus in a nutshell. We could use these for numerous things. Maybe you want to control whether or not you have dark mode available in your app, a display setting, any type of setting. A menu option could be a way to get the users to there. It's not the only way, but it is one way, and it certainly works. So now the next step in building up our kind of temperature display settings is to show a dialog that will let the user choose between Fahrenheit or Celsius. So to start with that, we're going to create a new private method on the forecast details activity. We're going to say private fun, and we're going to call it show temp display setting dialog. And now up here, instead of showing a toast, we're going to call show temp display setting dialog. So now we'll come down into this method, and we're going to use this method to display an alert dialog. Now, an alert dialog is a simple modal. It's a little tiny window that pops up over the top of your other content and lets the user select an option. You maybe enter some text, do some type of little one-off thing. So they're meant to be very kind of transient in nature, but they're a nice way to get contextual focus from the user. Now we can create an alert dialog by using what is called an alert dialog builder. A builder lets us kind of customize the dialog without having to know how it actually is built under the hood. So to start, we will get a reference to the builder by typing val dialog builder equals alert dialog dot builder, and we'll pass in a context. When you go to import the alert dialog, you might have two options. You might see android.app or androidx.app.compat.app. It's a good idea to go with the Android X version. So I'll select that and hit enter. Now we have this alert dialog builder. And now we can start to customize properties on this. So we could say dialog builder.set title for start. And for our title, we might say something like choose display units. Now that's not all the customization we're going to do, but let's stop there for a second and just see what this looks like. So to actually show our dialog, we need to say dialog builder dot show. And what that will do is actually create an instance of the dialog and call show on it for us. So if I run this and switch over to the emulator, I will enter my zip code. I will open up my menu item, and there we go. We see a simple and not very attractive dialog on the screen. So now let's continue building out this dialog so that it is more useful and appealing. So up here where we have our dialog builder, there's one small change we can make. So here we've called dialog builder.setTitle. And let's say we wanted to next do dialog builder.setMessage. And maybe our message is choose which temperature unit to use for temperature display. So we could continue customizing this dialog by referencing dialog builder every time. However, dialog builder has what is known as a fluent interface to it, basically meaning that we don't have to reference dialog builder every time. We could call set title directly and set message directly. And the way that this works is that alert dialog builder here, this constructor essentially returns an instance of the builder. And so then I can call set title on that like I would any other object. But set title also returns the builder. So then I can call set message. So it lets you chain these together which is why they call it a fluent API. It just makes it very easy and natural to write. So now that I have defined the title and the message, we're going to define what the positive button is going to look like. So to do that, I'll type set positive button, and I'm going to pass in F degrees to represent Fahrenheit. And then I am going to pass in a click listener for this. And to do that, we're going to do open and close parentheses. And then we're going to type underscore, comma, underscore, because the click handler for this typically takes 2 parameters. However, in our case, we're not going to use them. So we'll do underscore, comma, underscore. Then we'll type our lambda arrow here, which is just a dash and then the angle bracket. And now I can define what to do when we click the positive button, which for now is just going to be a toast. So we'll say toast.make text this, comma, show using Fahrenheit, comma, toast.length short, show. So that takes care of our positive button. Now let's do the neutral button. We could do negative button as well, but I'm just going to use the neutral button for now. So we'll say set neutral button. So the message for this will be Celsius degrees. Now, if we didn't want to use a lambda for defining the click listener like we did for the previous one, we could demonstrate what it looks like to do the full version, just to see how we're kind of saving ourselves some code. So this time we could type object colon dialog interface dot on click listener, and then we need to implement the on click method. So this is what we are essentially simplifying in the set positive version. So the set positive button, the set neutral button, they take in an instance of dialog interface dot on click listener. However, in Kotlin, we can simplify that using lambdas, which is why in the positive case, we just have the open and curly brace passed outside of the parentheses. So basically everything happening within these parentheses on set positive button is taking the place of all of this. So it's taking the place of the object colon dialog interface on click listener and taking the place of override fun on click. So if you want to use either one, that's perfectly fine. I'm going to go with the simplified version just because I like to have the less code there. And so in the case of the Celsius version, we're going to basically just show the same temporary message here for now. And I'm going to go ahead and rerun this once again just to check in and make sure everything is working as we expect. So I'll click my menu, and now we see our title, we see our message, and we see the Celsius and Fahrenheit option. So if I click that again, and this time let's say I click Celsius, I see the appropriate toast message being printed out to the screen. So let's go back over to Android Studio and kind of finish up this implementation. So one other thing that we want to do before we finish is to add a dismiss listener. A dismiss listener will let us do something whenever the dialog is closed. So in our case, we're going to tell the user that their display setting will take effect after they restart the app. So we're going to add the dismiss listener by typing .set on dismiss listener. And we're just going to add a toast once again. So toast.make text, pass in this. Setting will take effect on app restart. Toast.length short dot show. Show. So let's rerun it one more time just to check our work here. select Celsius. So first we see show using Celsius. Setting will take effect on app restart. So there, we're getting both the output messages that we would expect. So now that we have this user interface ready to go, we need to actually define the management of this temperature display setting. And so to do that, we're going to create a new class called Temp Display Setting Manager. So to do that, we're going to come over here again to our project window. We're going to right click on our package and select new Kotlin file or class. And we're going to just name this Temp Display Setting Manager. And so that has created a new Kotlin file for us. So within that, we're going to create a new class to match the name of the file. So class Temp Display Setting Manager. Now above that, we're going to create a new enum class called Temp Display Setting. And we're going to use this enum class to explicitly enumerate the different temperature settings available to us. So in our case, that will be Fahrenheit and Celsius. And so now we'll be able to use those values elsewhere to explicitly state whether we're using Fahrenheit or Celsius. So now we need to go ahead and implement this temp display manager. And temperature display manager is going to reference shared preferences to save the temperature display setting value. So to do that, we're going to need to pass in a context to this class because we need a context to get reference to shared preferences. So I will take in a context parameter, and then within my class body, I'm going to use that context parameter to get a reference to the shared preferences object. And I'll do that by creating a private property called preferences equals context.getSharedPreferences. When I pass in the name of the shared preferences file I want to use, I just want to call this file settings. And we're going to open shared preferences into mode private because we want these to be private to our application. So like we saw earlier in the lecture, this call to get shared preferences is essentially opening up a file on the disk or creating it if it doesn't exist. And it's going to allow us to write out key value pairs of data to this file using a very simple API. And this is kind of the default simple way of storing small bits of data that you want to persist across application restarts. So now that we have our reference to the settings, the next thing we're going to do is create a public method called update setting. And we're going to pass in a temp display setting value. So we'll call that parameter setting, and it will be of type temp display setting. So this is going to let us call update setting, and we'll pass in either Fahrenheit or Celsius to indicate how we want the temperature to be displayed. So when the user calls update setting, we're going to want to update our preferences with that setting value. To do that, we'll type preferences.edit. Edit will start us into an edit mode that we can use to edit the preferences. Once we're in that edit mode, we can type put, and you'll see that we have a number of different types of data that we can store with shared preferences. So in our case, we're going to type put string, and we're going to use a key of key temp display. And we're going to pass in setting, which again is either going to be Fahrenheit or Celsius. And we're going to pass in the name property. So any enums in Kotlin have a name property that will match how the class name is defined. So we can pass in setting.name. And then the last thing here is we need to call either commit or apply. Commit will immediately write our changes to the disk. Apply will do it in the background. However, in this case, because it's a one-off thing and it's a small piece of data, commit should be fine. So now that we have given the user a way to update the setting, we need a way to retrieve the setting. So to do that, we'll add a method called get temp display setting. And it's going to return an instance of temp display setting. So this will either return Fahrenheit or Celsius. Now, to actually get that value, we're going to create a variable called setting value equals preferences dot get string. And we're going to pass in the same key we used before, key temp display. And so now it's going to ask us to specify a default value. So for us, our default value is going to be temp display setting dot Fahrenheit dot name, because we need the string value as opposed to the actual enum value. Temp display setting dot value of setting value. Now, what does this do? Well, temp display setting dot value of is making use of the value of method of an enum, which basically says I can pass in a string to value of, and if that string matches the name of one of the enum types, in our case Fahrenheit or Celsius, then it will basically return you back the instance of that. So if I pass in the string Fahrenheit, I'll get back an instance of Fahrenheit temp display setting. So this is what is basically mapping the string version of the name of the setting to the actual static enum type. Now we have an issue here, basically saying required string found string question mark. So what does this mean? We haven't seen this question mark syntax. This gets into nullability in Kotlin. As a quick demonstration here, if I type val string equals some string equals some string, this is what's known as a non-nullable type. If I tried to assign the value of null here, like we might be used to in Java, this gives me an error. And basically the error says null cannot be a value of a non-null type. If I wanted to use null here, I could add the question mark after the type. So a question mark indicates that it is a nullable version of that type. So in this case, a nullable string. So down below here, this error on setting value is saying I expected a non-null version, but I found a value that might possibly be null. So basically what it's saying is that key temp display could actually return null, even though we have this default here. So the way we can handle that is by going to the end of the line, typing question mark, colon, and then basically just replicating our default value one more time. And I know that looks a little bit weird. Essentially what that's saying is that if everything on the left-hand side of the question mark evaluates to null, then instead of returning null, it's going to return what's on the right-hand side. This question mark colon is actually referred to as the Elvis operator. I'm not sure why. Always seemed like an odd name to me, but basically it lets you substitute out a null for some other default value. So as soon as I do that, settings value no longer has an error here. So now we know for sure that when we call get temp display setting, we're either going to get back Fahrenheit or we're going to get back Celsius. So now we can actually make use of these settings. If we go to our forecast details activity, we can update what happens when we click the button. Before we even do that though, we need to get a reference to a temp display setting manager. So we're going to come up to the top of forecast details activity, and we're going to create a new private late init var property called temp display settings manager. Now this is a different syntax as well that we haven't seen before. Late init var means this is a variable that at some point will be assigned a value, but it isn't going to be assigned one right now. So there's a contract here by saying before you actually use this, it needs to be assigned, otherwise your app will crash. But it leaves you free to assign it later. And the reason this is done a lot of times in Android is because a lot of things need a context, and your context isn't value until onCreate has been called. So for us in onCreate, we can initialize temp display settings manager in onCreate by invoking the constructor and passing in this. So now any point after this, we can safely use temp display manager. So now if I come down here to our alert dialog, when I click the positive button, I can call temp display setting manager dot update setting, and I can pass in temp display setting Fahrenheit. And now in the neutral Celsius case, I'll do the same, but I'll pass in Celsius instead. So now we have a way of actually retrieving and saving the temperature setting of Fahrenheit or Celsius. And in response to our dialog button click, we're actually updating that value accordingly. So now we need to actually make use of that and use that to change how we display the temperature. Well, remember earlier we created a forecast utils file. And in that file, we are passing in the temperature in Fahrenheit and then formatting that to 2 decimal places and returning a formatted string. So we're going to update this to take in a temperature display setting of either Fahrenheit or Celsius. And we're going to then make any necessary conversions, format the string, add the degree symbol to it, and this will let us update how our temperature is displayed. So to start, after we pass in the temperature, we're going to pass in a temp display setting. And now in our implementation, we're again going to use a when expression. We're going to type return when temp display setting. So because we have 2 different possible display settings, we're going to use a when expression based off of that temp display setting. And now we want to make sure we handle all the cases. And so if we put our cursor on when, we see this little red line prompting us that we need to handle each branch. If I type Alt-Enter, it'll show me some options, and one of those options will say Add Remaining Branches. So I'm going to hit Add Remaining Branches here, and it's automatically going to prompt me to handle both the Fahrenheit and the Celsius case. Now in the Fahrenheit case, we're going to do the same thing that we did before. So we'll pass string.format with 2 decimal places, and we'll pass in our temperature value. So that one is fairly straightforward. In the Celsius case, we need to do a bit more. So we're going to add open and curly braces here because we need multiple lines of code for this. And so the first thing we need to do is to actually convert our Fahrenheit temperature data into Celsius data. And so to do that, we will type val temp equals temp minus 32. We want to make sure this is a float value, so we add the little f. So in this case, that lowercase f means float, not Fahrenheit, times 5 float divided by 9 float. And then we're going to return string.format %.toF Celsius degrees and pass in temp. So this should now format our temperature properly based on the current display setting. So if we go to forecast details activity, we now need to update our invocation of the format temp for display function. So we can do that by passing in temp display setting manager dot get temp display setting. And now if we go ahead and go over to our daily forecast list adapter, we'll see that we need to do the same thing here in our view holder. So we could just create a new instance of temp display setting manager for each instance of the view holder. That would be the easiest way to go about this. However, it would be less efficient as well because we'd be creating many instances of that object when we really only need one. So what we're going to do instead is create a temp display setting manager variable in main activity, pass it to the adapter, and then the adapter will pass it to the view holders. So if that sounds a little bit complicated at the moment, don't worry, we're going to walk through each step right now. So to start, we're going to add a new property here for daily forecast view holder. So it'll be a private val temp display setting manager property. So now that we have that, we can come down here into our bind method and pass temp display setting manager dot get display setting. So now this should properly format it to display Fahrenheit or Celsius. So we just need to continue passing that display setting manager to the appropriate places. So we have it in the view holder. The place where we create the view holder is our adapter here. So we're going to need to do the same thing in our daily forecast list adapter. We need to create a private val property for temp display setting manager. And now that we have that, we can pass that into the daily forecast view holder constructor. So one last place then to update this is to go to main activity, and we need to pass an instance of that temp setting display manager to forecast list adapter. So once again, we're going to create a private latent var temp, whoops, clicked on the wrong thing there. Private latent var temp display setting manager. And just like in the forecast details activity, and at the top of onCreate, we will say temp display setting manager equals temp display settings manager this. So we've created our new instance of that, and now we can pass that into our adapter. So now if we run this, our code should compile. If we go over to our emulator, by default, it should be showing Fahrenheit temperature data displayed to 2 decimal places. If I go to our menu now here, I can select Celsius. And if I restart the app, and again, display some temperature data, now we see that things are showing in Celsius. And that is exactly what we would expect here. Now, one small thing to notice here is that in our forecast details, we're properly seeing a single line, but we're still seeing the ellipsis there. So we're not actually seeing that this is temperature data. So let's go adjust this real quickly, just to be a little bit nicer looking moving forward. So again, forecast details activity. We're going to open up into our activity forecast details layout. And so because this ends up being quite large, even though we're formatting it to 2 decimal places, what I'm just going to do here is change this back to a display 3, so it's a little bit smaller. And then I'm going to remove the ellipse size property there, just because sometimes the ellipse size requires its own length and can truncate the last value possibly for you. And so if I run this one more time, it should look a little bit nicer for us. There we go. So now we're still have a lot of emphasis on the temperature, but things fit on the screen a little bit better. So at this point, we now have a working settings function. We can show a menu, we can click the display setting item, show a dialog, and get input from the user as to whether to show things in Fahrenheit or Celsius. And then on app restart, that setting takes place and we're updating to display using the selected setting. So one challenge with this though is that we can only access that menu currently from the forecast details screen and not from main activity. So let's quickly walk through how you could essentially copy the same implementation over to main activity so that we can have the same functionality on both screens. So if we look at forecast details activity and we just revisit what we did for the menu, remember the first thing we did was implement create options menu. The next thing we did was select on options item selected and implement that. And then we implemented this method to show the temp display settings dialog. So if we want to copy this over to main activity, we can actually simply copy and paste those 3 methods over to main activity. And if we do that and then select all of the imports, we should be able to rerun this. And if we switch over to our emulator, we now see that we have the menu on the main activity screen as well. So now this just gives us a more consistent experience across both screens in the app and makes it easier for us to update that display setting value. Now, if we wanted to manage this a little bit more easily, you might notice that our logic for how we are handling the temperature display setting dialog is duplicated in multiple places. We're doing it in both activities. So we could think about creating a helper method for this, similar to what we did for the temperature display formatting. So to start, I'm going to copy one instance of show temp display setting dialog. I'm then going to go over to our forecast utils function here, and I'm going to paste in that show temp display settings dialog method. And we should see a couple errors here. The first being that we don't have a context anymore because it's not within an activity. And the second being that we don't have an instance of a temp display settings manager. So we can fix both of those pretty easy by adding those as parameters to this function. So first, we'll say that we need a context. And then next, we will say that we need a temp display settings manager. And then instead of saying this when we need a context, we will pass in the context directly. So now we have a function that still will show this dialog and update the setting when needed. The only other thing we need to do is make sure that it's no longer private and instead is public. And now we can update both of our activities to use it instead of their own implementation. So I can delete this. And here in on options item selected, I can call that same function, but now the one that's in the utils file. And I can pass in this, comma, temp display settings manager. And if I go to forecast details, I'll delete the specific implementation that was there. And I will paste over the same line of code we had before. And if we run this once again, we see that we still have the working dialog on both screens. So that's just one more way in which we are able to consolidate commonly used code into a utility function or some common class and then reuse it from multiple places.
Hey devs, and welcome back to week 5 of mobile application development with Android. And this week, we're going to be refactoring our app's UI to be a little bit more composable. And the way we're going to go about that is using fragments. Fragments are a means of encapsulating parts of our user interface and being able to reuse them down the line. And we'll get into more explanation a bit later. So as usual, we're going to start off here with a project demo to show how we will be updating our weather app this week. And then we're going to dive right into fragments. And specifically, we'll look at how you can build composable UI using fragments, what their use case is, what problems they solve, and how to get started using fragments in your own application. So for our project demo, we will go ahead and switch over to our emulator and take a look at what we'll be building this week. So here we have our weather app that we are familiar with at this point. And as usual, we'll go ahead and enter in a zip code here. This time, however, when we enter the zip code, we'll see that our forecast data is now in a full screen list. We still have our nice touch feedback here. The UI is updated a little bit, nothing too major there. However, we do have this little floating action button down at the bottom. If we click that floating action button, we'll be taken back to the location entry screen. So we have a nice separation between these two components of the UI. And if we click on one of these list items, we're still taken to the forecast details screen. So this doesn't look all that different. However, the way that these screens are implemented under the hood has changed quite a bit. And that's what we're going to be really focusing on this week. The list screen here and the location entry screen here are both now implemented using fragments, which lets us encapsulate all that code that we before were putting into our activity, and now it is being put into a fragment, and we can compose multiple fragments together in a single screen or add and swap fragments out of a single activity. So it gives us more flexibility in how we build our user interfaces. So as part of our demo here, we'll just outline some of the key points here one more time. We're going to create a location entry fragment to store the location entry screen that we've been used to. We'll also create a current forecast fragment to display that list of forecast data. We're going to create an app navigator interface to help us navigate between these fragments on different button clicks and such. And then we'll add a floating action button in the bottom right corner of the screen so that we have a means of getting back to the location entry screen after we've shown some forecast data. So that's the high level points of what we'll be working on this week. Like I said, not a lot of visual changes or feature changes, but underneath the hood, the code will change a fair amount, and it's going to set us up nicely for next week, which will be leveraging fragments quite a bit more. So, what exactly are fragments? Well, a simple way to describe fragments is a means of reusing pieces of user interface. So for example, in our weather app, we have our screen that has our kind of our icon, our label, and then the edit text to enter the zip code. Now imagine if we wanted to reuse that on multiple screens. Rather than having to re-implement that from scratch each time, we could put all of that UI and logic into a fragment and then reuse that fragment on different activity screens. Is a reusable portion of UI that can be composed together within a single activity.
Now there's kind of three main concepts here with fragments. So there's the fragment itself, which has its own layout file, very similarly to an activity. And a fragment also has its own lifecycle, which again is very similar to the activity lifecycle that we're already familiar with. You can add a fragment to an activity using XML, or you can programmatically add and remove fragments from an activity. But as we learned before, an activity is that high-level container for what's on the screen. So an activity is what will ultimately be containing these fragments. Now we also have what's called a fragment manager. This is a class that the activity is in control of. And the fragment manager helps us add and remove fragments and helps us ultimately control which fragments are visible on the screen at any given time. And finally, when we are controlling what's on the screen using the fragment manager, when we are adding, removing, replacing a fragment, we do this using what's called a fragment transaction. So any individual sort of update to what fragments are on the screen are encapsulated into this fragment transaction. And this is actually very straightforward. There's not a lot of code involved with this, and we will see how to do this a little bit later on. Now, to help illustrate the concept of fragments and this composable UI, let's look at this little diagram here. So imagine we have a simple screen here. And we might have it broken down into several individual fragments like this. We might have one larger fragment that is controlling everything on the screen. That fragment might then itself be showing different fragments. It might be in a list, maybe a horizontal pager, but each of those individual elements could be its own fragment. So you can have one activity that has a single fragment, or it could have multiple fragments. And really, a fragment can have its own fragments internally. Now that gets a little bit complicated. We're not going to really get into that in this course, but it just goes further to illustrate the concept that fragments are very composable, meaning you can group them together in different combinations depending on which screen you're on, which use case. You may even want different fragments depending on whether you are on a phone or a tablet. That's actually a very common use case for fragments. In fact, that's why fragments were invented in the first place. Because on a tablet, maybe you want one fragment that shows a list of emails, and you want another fragment on the screen in a larger portion of the screen that shows the individual email that is currently clicked. This is referred to as a master detail view. So the main point here that I'm just trying to drive home is that fragments encapsulate individual pieces of UI. They encapsulate the logic for controlling that UI, and then you can add and remove fragments as needed based on current configurations and requirements. So to add a fragment to a screen, there's a couple options. We can do it directly in XML. So imagine we are in our activity main XML here. We could add a fragment element like this. We would give it an ID. We would then specify the name of the fragment class that should be instantiated for that XML. And then, of course, we need to give it a width and height. So this would add a location entry fragment to our activity main XML file. And we'll see what this looks like in code a little bit later on. Next up, we could add a fragment programmatically. And so this demonstrates both the fragment manager and the fragment transaction. So within main activity or any other activity, we could get a reference to the support fragment manager. Then we'll call the begin transaction method. Now everything that is happening after begin transaction is then defining that individual transaction. So in this case, we are going to add a fragment to the container that has an ID of root. So fragments have to be added to some type of view group, just like any other view. So by defining the container and then the fragment, we've now said we're going to add this piece of UI to our screen. And then finally, once we've defined what will be in that fragment transaction, we will call commit. And this essentially processes the transaction and starts the process of adding or removing any fragments to the screen. Fragments have their own life cycle. And so here is their own life cycle. And so here is a very overwhelming diagram of the activity lifecycle
put next to the fragment lifecycle. And so I highlight this simply to show that there are a lot of similarities between the two life cycles. They mirror each other in many ways. However, this is very overwhelming, and I don't want to get too caught up in the details of this large diagram. So we're going to pare this down and look at just some of the most relevant fragment lifecycle methods here. These are some of the ones we're going to look at in our code this week. So for a fragment, the first potentially relevant lifecycle method is onAttach. This is called when our fragment has actually been added to an activity. Now, the next one that is relevant to us is onCreateView. This is going to give us our chance to inflate the layout for our particular fragment. So this maps quite closely to what we usually think of in activities onCreate. Then, just like in an activity, we have onStart and onResume methods, and those have essentially the same meaning as they do in an activity. When a fragment is coming onto the screen, we're getting started, and then when it's active, it's in the resumed state. And now again, going backwards, if a fragment is moved out of the screen, we have onPause, then eventually it's stopped. We then have a destroy view when the fragment view itself is actually destroyed, meaning it's unlikely to quickly come back into the screen. And then if the activity itself is actually being destroyed, we have onDetach, and this is called when the fragment is being completely removed from the activity. So these are very similar to the activity lifecycle, but slightly different named. And we will get into the actual usage of some of these lifecycle methods in the coding demo for this week. To that coding demo, before we jump over to the code, just a quick demo. Before we jump over to the code, just a quick reminder, of course, like every week, assignments and additional lecture resources will be available in Canvas. So check there for those resources, any announcements. And with that, we will jump over to the code and see how to start using fragments in our weather application. Okay, so here we are back over in Android Studio. To get started, we were going to create our first fragment. To do that, I'll come over to the left-hand side of the screen into the project pane. I'm going to right-click on my package name, go to New, Package. And I'm going to create a new package called Location and hit Enter. Now, within that location package, I'm going to right-click, go to New, and then scroll down to the bottom where it says Fragment. And I'm going to select the Fragment Blank option. When I do that, that will open this new dialog that says New Android Component. I'm going to name this new fragment Location Entry Fragment. Now I want to make sure that the Create Layout XML option is selected, and I'm going to deselect the option that says Include Fragment Factory Methods. And then we'll go ahead and click Finish. It's called Location Entry Fragment. It extends the fragment class. It's called Location Entry Fragment. It extends the fragment class and an entry fragment. It extends the fragment class, and it automatically generated an implementation of the onCreateView method. And we'll see in onCreateView, it is inflating a layout called Fragment Location Entry. If we click into Fragment Location Entry, we can see what the layout looks like for this. Right now, it's a simple frame layout with a single text view. If we open this up into our design editor, we can see what this looks like here. Nothing overly exciting about this. Now, just to make this a little bit more interesting, I'm going to go ahead and add a background color to this. And I'm going to assign it color accent. And this is just so that we can better understand where this fragment is being drawn in our next section here. So now that we've seen how we can create a fragment very quickly, let's look at how we can show a fragment on the screen. And we can do this in a couple ways. activity main file in the left-hand side of the screen here. Once we have activity main created, we are going to add the fragment directly to this layout. So I'm going to come down here below the constraint layout tag, and I'm going to add an angle bracket and type fragment. For layout width, I'm going to say match parent. For layout height, I'm going to use a special constraint that will make it fit to 30% of the screen. So to do that, I will start by adding the height as 0 dp. And then below that, I will say constraint height percent and type 0.3. So this should make the height of this fragment be 0.3 or 30% of the height of the screen. Sure that the name attribute, which is Android:name, points to the fragment that we just created. This will indicate which class needs to be instantiated. It's done. I'm going to add an ID to the fragment here. I'm going to add an ID to the fragment here of location entry fragment. All right. Go and look at how this is looking in our design view. So you can see here that we have a fragment. However, we'll notice the little error in our component tree here indicating that this fragment is not yet constrained. So let's go ahead and make sure that that is constrained right now. So I'm going to constrain this to the parent at the top, the left, and the right edges. So to do that, we can say constraint start to start of parent, constraint end to end of parent. So now that should constrain this properly to the top of the screen. So now that fragment is going to be correctly placed. However, the rest of the content is still going to be overlapping that. So let's update our edit text, which is what the rest of the layouts are based on. And let's make that be constrained to the bottom of our fragment. So instead of saying constrain top to top of parent, we're going to change that to be constraint top to bottom of. Visualize this. We'll come back to our design view. So now we can see that enter zip code here is connected to our fragment. So that'll ensure that all of that content is pushed down below the fragment. Now there's one other small little thing to point out here. Notice here that our fragment just is this little gray box that says fragment. This tells us that a fragment will be there, but it doesn't really show us what that's actually going to look like at runtime. So there's actually something helpful we can do with this. So if we click that fragment and we come over into our attributes panel over here at the right-hand side, we can come down to the all attributes section here next to it because it's a tools attribute. We can define at tools attribute. We can define at layout / location entry, fragment location entry. So you see, as soon as we specify that, we now are seeing what that layout will look like as this fragment. So just one more time, if we go to what this looks like in the XML, we'll come up here to the fragment definition, and we'll see this attribute, tools:layout equals at layout / fragment location entry. So we're basically telling the design editor that the layout that will be used for this flat fragment is fragment location entry. And this is the same fragment we just defined for our fragment. So that's the connection there. That's how they know how it's going to look. So now if we just run this real quick, we should be able to see what our app is looking like. Now we see that our new fragment is being displayed at the top of the screen, and the rest of the content is being pushed down below that. So this is our first kind of example of how we can compose fragments together. We can have multiple fragments on the screen at the same time, or we can combine fragments on the screen at the same time, or we can combine fragments with other views. So let's go back over to Android Studio now, which is fine, but that's not how we'll do it most of the time. So let's remove this, So let's remove this from our XML. Let's redeploy this real quick, just to make sure that everything's going to be fine. Oops. You also need to make sure that we reconstrain the edit text to the top. So again, we'll come down and specify constraint top to top of parent. So again, that's in our location or our zip code edit text, excuse me. If we go to the design view, just one more time, it should look like this, like we're familiar. So if we redeploy and come back to our emulator, we see now our layout is back to the way it was before. So this is what we would expect. So now, once again, this time we are going to programmatically add a fragment to the root view of our activity. So we're going to open up main activity, and we're going to scroll down to the bottom of onCreate after we've initialized everything else. And we're going to call support fragment manager. Gives us back a fragment transaction class. Within that fragment transaction class, within that fragment transaction, we can define which fragments are added or removed. So after that, we can type add, and I'm going to type location entry fragment. So I'm creating a new location entry fragment. See, we have a small error here, basically telling us that we need to provide a string or some other argument here. We can't pass just a fragment in. So in this case, I'm just going to pass null here. We're going to update this in a moment, but we'll go ahead and run this now and see what this looks like by simply just adding the fragment to the root view. The emulator here, we can see that nothing has actually shown up on the screen. So let's go back and fix this. Come to Android Studio. Again, we need to come back to this add call. Simply adding a fragment is not enough here. We need to tell it where to add the fragment. So let's remove this call to the tag here. And we're going to come back to the add call. And if we look at the different implementations of add available to us, we see we have a few options here. The first one takes a fragment and a tag screen. That's the one we just used a second ago. That's not what we want in this case though. The next two each take an ID resource specifying the container view ID, and then take a fragment. So this is telling us that it wants to know what view group to add this fragment to. Well, in our case, to start, we want to add this fragment to the root of our activity. So if we come to activity main XML again, remember this is our main activity file. If we go over to the XML view, scroll to the very top, we're going to give
the top level constraint layout an ID. And we're just going to call this root. So that's Android:ID equals @+ID/root. Now, if we come back to main activity, within this add call, we can type r.id.root, comma, location entry fragment. So now what this is saying is we're going to get the support fragment manager. We're going to begin a new fragment transaction so we can add a fragment. We're then going to specify an add call, and we're going to say create a new location entry fragment and add it to the root view group of this layout. And then we're going to commit that fragment transaction so that it actually shows up on the screen. So if we go ahead and run this now and switch back over to our emulator, now we can see that that fragment is actually showing up on the screen. Now this might look a little bit odd because the fragment is covering some things, but not other things. That is likely because of the elevation. The submit button has an elevation on it as part of its default styling, and you can kind of see that as you click that button, the elevation changes. So that's why you see that. But the key thing in here is that we were able to add the fragment to our activity. So now let's add this fragment to a specific container instead of adding it to the root layout as a whole. Again, come over to Android Studio, and we want to go over to activity main once again. And so this time we're going to come below activity main here, or excuse me, below the constraint layout within activity_main. And we're going to create a new frame layout to act as the container for our fragments. So for height and width, we're going to do a width of match parent and a height of 0 dp. And once again, we're going to do a height % constraint of 0.3, which means 30% of the height of the screen. Of fragment container, so that it's very clear that this frame layout is going to contain our fragments for us of the parent. So again, we'll do constraint top to top of parent. So again, we'll do constraint top to top of parent, constraint end to end of parent, and constraint start to start of parent. To our design view then, that we have the fragment container sitting here kind of behind the enter zip code elements. This will look very similar to what we did in the first example of adding it directly. So again, let's update this zip code edit text here to sit below the fragment container instead of being aligned to the parent. So to do that, I can right click on that top constraint and click delete. And then I will drag that up and have that connect to the fragment container. In that layout section, I want this to sit essentially right up against the top. So I'll drag the bias up to the very top, and I'll add a margin of 16 dp. So that should make the elements sit up here close to the fragment. However, you see that while the edit text is below the fragment, the rest of it is not. So let's go ahead and bring that back down there. Now everything should be sitting below that fragment. So now if we go back over to our activity main XML, again, just to double check, we have our new frame layout called fragment container.
and it is constrained to the top of the screen. So we should now be able to add our fragment to this container and have it sit just at the top of the screen instead of filling the whole screen. So if we come back to main activity here, we'll come down here to our add call, and instead of passing r.id.root, we'll type fragment container. And now let's go ahead and redeploy this. Fragment being placed in the top, being added to our fragment container view. This demonstrates to us that fragments can be used as composable UI containers and can be shown on the screen in a variety of ways. This can help developers build flexible user interfaces that adapt to different screen sizes and configurations. Okay, so let's go back over to Android Studio now and finish implementing our location entry fragment. So we're back over here in main activity. If we open up location entry fragment, we'll see here that there is nothing really going on. At the moment, all it does is display that single text element. What we want it to do is provide all that same location entry functionality that we've had in main activity. So to implement this, we're going to start by going into activity main XML, and we're going to basically copy all of those location entry elements. So the title, the icon, the edit text, and the enter button. We're just going to highlight those into the fragment location entry XML file. So we'll paste those in, and we'll need to update this in a couple ways. So we'll convert the frame layout to a constraint layout, number 1. Then we'll need to make sure that we have the app tools attribute here. So come over to main activity, go to the very top and find where it says xmlns:\app, and simply copy that, and then paste that over here into your constraint layout. And so now if we scroll around, and if we look back at our design view, we should see that this is looking mostly correct. However, we see that our elements are all here constrained at the bottom of the screen. So let's click on the zip code again, and let's constrain this to the top of the screen. And we'll see then that it immediately bounces right back up to where we expect it to be. And now, because we're not really debugging this anymore, let's go back to our XML mode, and we will remove that background color. And so now let's go ahead and redeploy this and see what happens. So I'll click Run App, switch over to my emulator, and this, we see that we get a crash. So what's happening here? Well, we'll come back over to Android Studio. Let's open up our logcat here. Scroll up. We're going to see this error message here, and you should see something similar that says illegal state exception, find view by ID, zip code edit text must not be null. And this is coming from our main activity class. And so what's happening here is that inside of main activity, and specifically inside of main activity on create, it's trying to find references to those views, but they don't actually exist anymore because they've been pulled out from the they've been pulled out of main activities layout file and into the fragments layout file. So just real quickly to try and fix this, we're just going to kind of comment out these elements, you can do that by typing command / or control / I believe on Windows. So this simply comments that code out. So it won't be run or anything when the app is actually deployed. So let's run this one more time. Switch over to our emulator once again. And now this time we see correctly that our new layout is on the screen correctly. However, it's kind of situated not quite how we would want. It's pushed much too far up to the top. So let's again go back over to Android Studio and let's update the fragment container within Android or within Activity Main. And let's update that container so that it fills the screen instead of just being constrained to the upper 30% of the screen. So again, we'll say 0dp, 0dp. We will remove the constraint height %, and then we'll make sure that this is constrained to the bottom by adding constraint bottom to bottom of parent. This is now filling up the whole screen. So if we redeploy this whole screen. So if we redeploy this one more time, go back over to our emulator. Now we see a UI that looks pretty much the same as it did at the start of our demo here. If we try to do anything with this, we see that nothing actually happens. That's because we're not actually getting any references to those views in the fragment. We're not connecting the button. So let's finish translating this implementation over to the fragment. So if we go over to main activity, let's grab that code that we commented. We'll first uncomment it, then we will copy it, and then we're going to delete it. Then we're going to come over to our fragment. And there's one thing we need to do here first in onCreateView before we can copy this code over. So we see that onCreateView, it returns a view. It needs to return the view that you want to show on the screen. So by default, it simply returns the view that is returned by the layout inflator. However, we need a chance to be able to update that as we are filling out this implementation. So we're going to modify this simply. We're going to create a variable to store the view returned by the layout inflator. And then we'll hit return a couple times and we will return that view. So now in between those lines of code, we can update our UI, get view references, do anything else we need. So this then is where we're going to copy that code that we just pulled over from main activity. Now this should present a couple of errors to you. The first being find view by ID. It says unresolved reference find view by ID. Now why is this? Well, activities have a method called find view by ID. However, fragments do not. To do this on a fragment, we need to get a reference to view because that is the parent that was inflated. And then just type view.find view by ID. So again, for this one, view.find view by ID. So what this is doing is it's referencing that layout that was inflated and using that to look up the views. The only other thing we need to update here, actually I take that back, one of the other two things we need to update is we don't have a forecast repository at the moment. So we're going to comment that out. And instead we're going to replace it with a toast. So we'll say toast.makeText. Now this requires a context. Now in the activity, we would pass in this as our context. However, fragments do not extend context, so they are not a context by default. However, they do have a convenient method for getting a context, which is called require context. So we'll pass in require context, and then we will just pass in a string that says something like zip code entered toast. And now we need to update the previously existed toast. So we'll go up the previously existed toast. So we'll go up a couple lines and replace this with require context. Now we should be able to deploy this. If this now makes all of our elements interact how we would expect. Enter a zip code, and I hit submit. I zip code, and I hit submit. I can now successfully see the toast that I would expect. And if I enter an invalid zip code, I see the invalid zip code as well. One other little piece that we might want to consider here. And we go into the layout for main activity, activity underscore main, into the layout for main activity, activity underscore main. Now, essentially has two items. It has a frame layout, and it has a recycler view. Now, the way that views are typically drawn is there's an implicit Z order, meaning generally anything you define after a previous element will draw on top of it. Now, what this means is that in some cases, if both your recycler view and your frame layout were being drawn on the screen, the recycler view might prevent the frame layout from being interacted with. So just to be safe, we're going to grab the frame layout and we're going to put it below the recycler view here. And just one more time, let's deploy this and make sure everything is working as we expect. All right, so here we go. We'll interact with this and we see the toast. So that is working correctly for us. So now we're back over into Android Studio and we want to work on loading the forecast data when our button is clicked. We want to get back to that functionality, being able to actually see that weather data. So we are going to create a new interface by right-clicking the package, going to New, Kotlin File or Class. We're going to select Interface, and we're going to name this App Navigator, and hit Enter. So this creates a new interface for us called App Navigator. So this is going to signify a way for us to indicate if we want to navigate from one screen to the other. Within that interface, we're going to define a single method for now. So we'll type fun to indicate that this is going to be a function. And then we'll type the name of the function, which will be navigate to forecast. And then we're going to pass in a zip code. And that zip code will be a non-nullable string. Implements this and defines this behavior so that if we call this method, we actually navigate to our current forecast. So for us, our main activity is going to be this class that navigates App Navigator. So we'll scroll to the top of main activity here. After the app compat activity call, we are going to add a comma, and then we're going to type App Navigator. So now this makes main activity implement App Navigator. And as soon as you add App Navigator, you should see a little squiggly line indicating there's an error in main activity. And it's going to tell you main activity is not an abstract class and does not implement navigate to current forecast. So basically this is telling you you either need to make this class abstract or you need to implement that method. So we're going to scroll down to the bottom to area after on options item selected on navigate to forecast. So on navigate to forecast. So forecast. There we go. So we see here we type override fun. So we see here we type override fun, navigate to current forecast, and again we're taking in a zip code there. Navigate to this forecast. How do we actually show that data? Well, to this forecast. How do we actually show that data? Well, as we were doing that previously, we were using the forecast repository dot load forecast, and we would pass it in a zip code. So now in the activity, whenever navigate to current forecast is called by some external class, we will call load forecast on our repository, which will then ultimately show that weather data. So how are we going to actually call this method then? Well, for that, we're going to go to location entry fragment. So location entry fragment is now the controller for this location entry. It's the thing responsible for showing the layout. It's also the thing responsible for handling the click, and will be responsible for telling the activity that we should navigate and show the forecast data. So how do we actually get a hold of this app navigator so that we can indicate back to the activity? There's a few different ways we could go about doing this. Some of them involve dependency injection, which we'll not be getting into right now. However, there's another common pattern for doing this within a fragment. So to start, go to the top of your location entry fragment, and we're going to type private latenit var app navigator : app navigator. So this is defining a non-nullable variable called app navigator that will be initialized before we ever use it. The reason we need to make this latenit is because we need to initialize it within on attach. If you just start typing on attach and hit enter, Android Studio will automatically implement the on attach method. Now, if you remember from the lecture notes, on attach is one of the lifecycle methods. It happens very early in the fragment lifecycle, and essentially this is when the fragment is added to the activity. So this is really our first point where we can get some type of reference to the activity or the context. Now, because fragments have to live within an activity, we can take advantage of that fact. And because we expect our activity to implement this app navigator interface, we can assume that this context is our app navigator. So to do this, we can type app navigator equals context as app navigator. This as keyword here is how we cast a variable to another type. Here is that we want to assign app navigator the value of context. So for us, that means that app navigator will now have a reference to our activity. If for some reason our activity doesn't implement app navigator, let's say we forgot to add it, this would crash when you tried to run it. So it would quickly tell you that you missed something in your code. Down here to our button click, we can remove this toast. And here where we used to call into the repository, we can say app navigator dot navigate to current forecast, and we pass in the zip code. And then I'll go ahead and delete this commented outline. When we click on the button, it's going to call navigate to current forecast on the app navigator interface. That is then going to come into main activity and come into this method, which will then trigger the load forecast call on the repository. So we have essentially the same flow of data that we had before,
but now it's starting in the fragment and being handled ultimately by the activity. If we run the app, we should see that it is now much more functional than it was a few minutes ago. If we enter a zip code, click Submit Code, we now see that we have our list again. Although we also see that our UI is a little bit messed up, but don't worry, we are going to fix that next. Now it's time to create a fragment to display our forecast data. So to do that, to start, we're going to come back over to our project pane on the left-hand side of the screen. Once again, click our package name here, go New, Package, and we're going to type this one out as Forecast, and then hit OK. So again, we're going to create a new fragment by right-clicking that new forecast package, going to New, Fragment, and we're going to select a blank fragment. We're going to name this one Current Forecast Fragment. And once again, we will let it create the XML layout, but we do not want it to create the factory methods. We'll click Finish, and then we'll go ahead and click Add once again to add the files to Git. So just like before, we now have a current forecast fragment with onCreate view implemented. And again, we're going to update our onCreate view implementation to assign the inflated view to a view variable, and then return that view later on in the method. Well, let's go to activity main. And this time we are going to grab the recycler view. We're going to copy that, delete it from activity_main. And then we are going to paste it in over here in the newly created fragment current forecast.xml file. We're going to click on one of the little app attributes there, which is giving us an error. And then we will hit Alt-Enter to fix that issue. And then we will convert our frame layout to a constraint layout. And now just to double check that this looks correct, let's go to our design view. And we see that our daily forecast is not taking up the whole screen. It's actually sticking just there down at the bottom. Why is that? Well, back over in our XML, we can see that our constraints are not quite right. We'll see that we have constrained the top of our constraint layout to the bottom of Enter button. However, Enter button doesn't exist in this layout. So let's fix this. We'll add constraint top to top of parent. Now, if we go back to our design view, we see a preview of what this list will look like, and it's filling the whole screen. However, it looks a little bit odd because we have this margin on the left, the right, and the top. So let's come over to the layout attributes panel here, and let's just change those margins from 16 to 0. And now this still looks pretty good because each individual item view is applying margin on its own. However, also we have this gray background on the item views. So let's just quickly go to our item view, which again is called item daily forecast XML. And we're just going to remove that gray background property. _current_forecast.xml. We see now that forecast.xml. We see now that we have this nice white looking list. So this is going to look very natural within our existing UI. We scroll up to on create. We have all this implementation here for the recycler view. Well, that's going to break as soon as we try to run this again because the main activity doesn't have a recycler view. Our new fragment that we created. And so really this is our new fragment that we created. And so really this is going to be this whole block of code here. So from creating the recycler view, creating the adapter,
and observing the repository for new data. So I'll copy that. We'll go over to our current forecast fragment, down into onCreate view, and we're going to paste that in. And just like before, we're going to need to update this a little bit. So our find view by ID call, we just need to update to view.findViewById once again. And hit Alt Enter, and then import the Android X.enter, and then import the Android X.lifecycle observer class. Other little issues here. So we are missing a forecast repository. We are missing a temp display setting manager. We're missing this method call called show forecast details. And we have this issue with passing this in as a context. This one is easily solved for us by, again, passing in require context as a method call. If we go over to main activity and we scroll down, we can copy this show forecast details function. Let's bring this over into our fragment. So that's a simple copy and paste. However, within that, once again, we need to replace the call to this with require context. So now we're down to just the two errors here. We're still missing a temp display setting manager. So let's go to main activity. The initialization of that from onCreate. And down here in onCreate view at the very top, we will go ahead and initialize this. So this time the initialization will say temp display settings manager equals temp display settings manager, and we will call require context to pass it the context. Now notice there that in main activity, we didn't delete temp display manager because in main activity, we still need it for our menu to work. So we just copy and pasted it to simplify the adding of it to our fragment. And now the one last thing that we can bring over is the forecast repository. And again, we paste it over here into our new fragment. We'll go back over to main activity, and we'll see here that now in our navigate to current forecast method call, we have a problem. We no longer have the forecast repository, so we can't load that data. Now what we want to do instead is we want to actually show the new fragment that we've just created. So now our current forecast fragment is going to be responsible for loading and showing the data. So all main activity has to do is add that fragment to the screen. So to do that, we will type support fragment manager dot begin transaction dot replace r dot id dot fragment container, comma, and we will create a new instance of a current forecast fragment. Main activity has been properly updated. Let's go back and just double check on our current forecast fragment. And we'll see here that we have fixed all the errors. So let's go ahead and run this and see what happens. So I'll redeploy, and we will switch over to our emulator. So far, so good. Nothing has crashed. It's still working as expected. And if I enter a zip code and hit enter, we see that the screen has updated. However, we don't see any forecast data. Well, why is that? Well, if we go back over to Android Studio, if we go to main activity, Let's navigate to current forecast. We used to be loading the forecast data. However, now all we're doing is adding the fragment. So if we go to the fragment, we'll notice that we do have a reference to the forecast repository. However, we're never actually calling load on the forecast. And part of the reason for that is that the current forecast fragment doesn't know anything about the zip code, so it wouldn't even be able to call load forecast. So what we need to do is somehow provide a way for us to pass the selected zip code to current forecast fragment. Now, to do that, we're going to come down to the bottom of current forecast fragment, and we're going to create a companion object. Object is an object scoped to an instance, of current forecast fragment in this case. Ultimately, what that means for us, if you're familiar with Java, is that by creating a companion object, we can replicate the same type of behavior that you're used to with static methods in Java. And we'll see what that looks like in just a moment. So within companion object, the first thing we're going to do here is type const val key zip code equals key underscore zip code. So this is creating a simple key constant for us, because we're going to effectively pass in a key value pair to this fragment and use that to get access to the current zip code. Now, how are we going to use this? Well, we're going to create a method called new instance for this fragment. Creating a new instance method is a common pattern for fragments on Android. Essentially, the new instance method becomes a factory method for the fragment that takes in any arguments that fragment needs to operate correctly. So in our case, it is going to take in a zip code, and then we can use that zip code to load the required data. So we will start off by typing fun, again, because fun indicates we're going to define a new function. We're going to type new instance as our function name. We're going to define an argument called zip code of type string. And then we're going to define the return type as current forecast fragment. In that method body, we're going to start off by creating a new instance of our fragment. So we'll type val fragment equals current forecast fragment. Val args equals bundle. Now a bundle equals bundle. Now a bundle is a fairly simple class defined to store key value pairs in Android. And you can use bundles to pass things to intents or to pass them around with fragment arguments. So now that we have this bundle, we can put the zip code into it. We'll type args.put string key zip code. So we'll pass in that zip code constant. So we'll pass in that zip code constant that we used. And then we will pass in the zip code value that was passed to this method in that bundle. And then now we set the bundle into our fragment by typing fragment dot, and as the very last thing, we will return the fragment variable. So how we are going to now pass this data over. The next thing we need to do is actually get this data from the arguments when we call onCreateView. This is in top of onCreateView here. We're going to call val code equals arguments dot get string And again, we can reuse that key underscore zip code constant here. So this will ensure that we're using the same key. And in this case, we can simply type arguments, and that'll give us access to the bundle that was passed into this fragment when it was created. So essentially, we are down here in new instance, we are creating the bundle, putting the zip code into it, and assigning it to the fragment. Now, and up here, when the fragment is creating its view, we're getting that bundle and looking for the value in it. Now, there's one little thing to point out here. We have this little error here saying that only safe or non-null calls are allowed here. Basically, what this is telling you is that you have no guarantee that the value you want is going to be here. And so this might end up returning null. For us, since we expect that value to be there, we can fix this by adding 2 exclamation points. Essentially what this will do is, if for any reason arguments is null, which it shouldn't be in our expected case, then it'll crash, and it'll crash specifically telling you, hey, this was null when you didn't expect it to be. At the bottom of onCreateView, we can call forecast repository.load forecast. On create view, we can call forecast repository.load forecast, and we can pass in that zip code. Although now if you look at this, it's going to give you an error here saying a required string found a nullable string. So we can just kind of quickly work around that by going back up here to our arguments call and using the Elvis operator again, which is $:. And if for some reason the call to get the zip code returns a null value, we'll pass in an empty string here. So this will prevent anything from crashing and makes the call to load forecast happy. So now our fragment is ready to go. The last thing we have to do is go to main activity, and we actually need to pass the zip code in. So here, where before we were just creating a new instance of that fragment directly, now what we want to do is type current forecast fragment dot new instance. So this is going to call that new instance method from the companion object, and we will pass in the zip code to see that loaded forecast data. So I'll enter a zip code, I'll hit submit, and as we expected, we now see our forecast. However, we don't see any obvious way of entering a new zip code, which is a problem. And if we hit back, it simply closes the application. So let's fix that, and let's add a way to show the location entry fragment again if we need it. So we'll come back over to main activity here. And what we want to do is come over to current forecast fragment. And then we're going to open up the layout for current forecast fragment. Add a floating action button to this layout. To do that, we'll come over here to our palette. And we're going to click on the buttons section. And down at the bottom, we see this item that says floating action button. I want to drag that over into our UI. When we do that, it's going to ask you for a resource to use as the icon for that button. Because this is showing that location fragment, I'm going to use that same location icon that we're using when we enter a location, and I'll hit OK. Now this is going to ask you if you want to add a new dependency to the project because the floating action button is part of a different library. This is a good thing. This is nice that it's asking us for this. So we'll go ahead and click OK. And this is going to add a new dependency, which might take a minute to update. And you should ultimately see a new item added to your build.gradle file. So if I open up my apps build.gradle file and I scroll down to the bottom, you should see something like this. It should see Google Android material material 1.1. So this is a library filled with widgets that adhere to Android's material design principles. So once that's added, if you open up current forecast fragment again, we'll go back to the layout. We see here that our floating action button now appears on the screen. However, this doesn't quite look how we would expect it to. And if you look in the component tree here, we actually see that we have a little error here. Again, it's not constrained. So let's use the design editor here, and we'll connect this to the right-hand side of the screen and the bottom of the screen there. And we want to add some margin here. So we'll add a bottom margin of 16 and a right margin of 16. So that's looking a little bit better. XML, and let's just look at how this is being laid out in the XML. So we see that it is a floating action button right here. It has an ID of floating action button. Let's go ahead and update that ID to something more useful, like location entry button. The icon is black. However, I want that icon to be black. However, I want that icon to be white because it's going to match the rest of our theme a little bit better. So what I'm going to do, instead of creating a white version of the icon, I can use the Android tint property, and I can pass in the white color. To pass in white, which is a default color available to you, you can type at Android color/white. To the design view, now we can see that icon appears as white instead. See what that button is looking like so far. So we'll enter a zip code real quick here. We'll click submit. And now we see we have a floating action button down in the bottom of our screen. For the first time, the action button now actually looks correct in the design editor as well, which is a very nice touch. Gives you a better sense of what the UI is going to look like. So now we have a button. The next thing we need to do is define a means of indicating that when that button is clicked, we want to navigate to a new screen. Now, hopefully that sounds familiar. That's basically what we did before with our app navigator. When we clicked the load forecast button, we created a method that indicated that we should show a new fragment. So we're going to do the same thing here. Again, we're going to open up app navigator. This time, it's going to be called navigate to location entry. And because this doesn't require any special parameters or anything, we don't need to pass any in. Over to main activity. And again, if we scroll up to the top, there should be an error again saying we need to implement navigate to location entry. So we'll come down here to the bottom, and after navigate to current forecast, we will implement navigate to location entry. This time it's going to look very much the same. So we will type support fragment manager dot begin transaction dot replace r dot id dot fragment container. And this time we'll simply create a new fragment and pass that in. So location entry fragment dot commit. Our current forecast fragment, and actually connect this on click listener so that when you click it, something actually happens. So let's go to on create view. We're going to get a reference to the floating action button. To do that, we'll create a variable called location entry button equals view dot find view by ID
Something got messed up there. Let me retype that so that it's a little bit more clear. My apologies. So again, we'll create a variable called location entry button of type floating action button. And I'll hit Alt Enter to import floating action button as a type, equals view.findViewById r.id.location entry button. So now that we have a reference to that button, we'll add a click listener. Location entry button dot set on click listener, which is just the same as with a regular button. And now we will use app. We don't have a reference to app navigator. So again, we want to do the same thing as we did in location entry fragment. We're going to grab the same implementation of app navigator and on attach, copy that, come back to current forecast fragment and paste that in. Now, when we come back to our on click listener, if we type app navigator dot navigate to location entry, everything should work correctly. In our fragment again, so this is our location entry fragment, which is added the first time our activity is created. We will enter a zip code and click submit. That call to submit is using the app navigator to tell main activity that it should show the current forecast fragment. Current forecast fragment shows that displayed weather data and also provides a button here to, again, go back to enter a new zip code. In Android, and lets us have more control over where our logic is encapsulated. So in this case, displaying the list data was encapsulated into one fragment, getting the location encapsulated into another fragment, and interacting between the two is handled by the common parent, which is the activity. So next week, we're actually going to walk through a more advanced and kind of the new Google recommended way of handling this type of fragment navigation. But it's really good to know the basics here because they are fundamentally what the more advanced version is doing. So next week, we are going to continue to build on this. We are going to create a couple more fragments next week and show you another way of navigating between them. So hopefully you can stay up to date, get these fragments created, and next week we will build on that and really start to make our app look and feel more like a modern weather app. As always, if you have any questions or anything, you can reach out to me by email, and I will see you all in the next lecture. Hey devs, and welcome back to week 6 of our ongoing Android application development course. This week, we're going to be taking a look at navigation within our app. Specifically, we'll be diving into the Android navigation architecture component, and we will be refactoring our app to use the navigation component to navigate between the different screens in our app. Along the way, we'll take a minor detour into material design and give you a quick overview of the Material.io website that you can use to find information about specs, sizing, user interactions, and different things to give you a nice consistent UI and UX within your app. And we'll tie it all back together by showing how the navigation component can work with some of the material design elements in our app, such as the app bar and bottom navigation, which we will be implementing in our app towards the end of the demo. So as always, we will jump over to the slides, and at the end of the lecture, we will have the demo code walkthrough and update our app for bottom navigation.
All right, let's go ahead and jump into our week 6 lecture then. So as usual, we will start with our project demo to give you a quick look at how we will be updating our app this week. Then we're going to dive in and explore the navigation component from Android Jetpack. And then towards the end, we will discuss material design a little bit and how we can get consistent UI styling and consistent user interactions using some of the principles found in material design. So for our week 6 project updates, there's a few key things we'll be doing. We're going to be implementing app navigation using the navigation architecture component. So that's going to be the big change for this week. As we do that, we will also be adding a weekly forecast fragment that eventually will display the forecast for our location for the next 7 days. We're not going to get into loading that data this week, but that will be coming. And then we will be adding bottom navigation to our app as a means of navigating between these different forecasts that we have available. So if we want to jump over to our emulator, we can take a peek at what we'll be building this week. So you see right off the bat, we have a little bit different of a project structure here. Down at the bottom, we see that we have this bottom navigation view. We'll also see that we immediately start out in a forecast screen, and we can tab between these bottom navigation tabs to switch which forecast data we're viewing. So eventually this will display the current forecast for this day and then the weekly forecast. And now we still can click into an individual list item and see the details, and we can go in and update our zip code if we need to. So that's a look at what we're going to be doing this week, and all of this is really going to be built on the Android navigation architecture component. So let's start talking then about navigation in our Android apps. How do we move between screens in our app? Well, Android Jetpack has brought with it a new means of doing that, and that is the navigation architecture component. The architecture components themselves are a collection of libraries meant to make different architectural things easier within Android. So navigation being one of the key things among that. So what exactly is the navigation component then? Well, the navigation component does a number of things for us. It manages fragment transactions so that we don't have to do things like get a reference to the fragment manager, call begin transaction, call things like add, replace. We don't have to do pops. We don't have to manage the backstack. The navigation component does all of that for us. The navigation component also provides us a navigation graph that is an explicit representation of what screens and destinations are available in our app and how they interact with one another. As part of that graph, we get a nice visual editor that lets us actually visualize this in a really nice way and edit this visually like we've done with, let's say, constraint layout. We also get a nice plugin for managing safe arguments between fragments. So when we start a new fragment, we can specify what data that fragment needs to run properly, and we can enforce that in a compile time way, which is really nice. And there's some others that we will be talking about later on in the lecture. So that's all well and good, but what problems does navigation actually aim to solve? As we've seen in this course, navigation can be fairly straightforward. So what types of things make us actually want to use the navigation component? Well, there's a number of things that the navigation component gives us, which are pretty nice. So one of them is that we just get this nice visual representation of our app's navigation. And we'll see an example of that in just a moment. Again, compile time validation of destination transactions is really nice. Being able to know that we have the right data when we're going from one fragment to the next is really helpful. Deep link routing is another feature that is built right into navigation component. It makes it very easy to specify which deep links a particular fragment needs to handle. And the navigation controller, which we'll talk about in a minute, can handle those deep links and route them to the proper fragments as they are received, which is really, really helpful. Simplified animations is another thing that's really nice. Now, we haven't really delved into animations in this course, but specifying animations between fragment transactions or even between activities can be a bit of a chore. It's often a fair bit of little boilerplate code, a lot of the same kind of simple lines added here and there. And a lot of times it just feels like more work than it's worth. Well, with the navigation component, the visual editor makes specifying basic animations really, really easy and goes a long ways towards making your app feel more polished without a lot of extra effort. And then again, we'll just call it out one more time. Compile time validation of fragment args is super helpful. So here's an example of a navigation graph. We'll see here that we have a number of screens, and then we have some arrows specified kind of between the screens. So let's break down what we're actually seeing here. So each of the screens on here represents a fragment in our app, and these are referred to as destinations. These are places we can navigate to that will actually be visible on the screen and that the user can interact with. The arrows represent actions, and an action is essentially a transition from one destination to another. So if we look here, we can see that we can go from the title screen to the register screen. We can go from register to match to in-game, and then from in-game, we can go to game over or results winner. And then from either of those screens, we can go back to match. So these actions can move linearly, or they can provide loops to help you jump back to other spots in your navigation graph. And this visual editor is really one of the key parts of navigation that make it a pretty large departure from how navigation has been handled on Android in the past, but also a pretty awesome new feature, because this is something that we've never had before, and there's a lot of benefit to something like this. So we've talked about a little bit about conceptually what navigation can do. What functionality does it actually provide for us? Well, it manages fragment transactions. It provides us that visual navigation graph. It will automatically generate the action classes that specify how to go from one fragment to another. It provides built-in APIs for animating between these transactions. It has automatic support for routing deep links to the necessary fragments. And it also integrates with material design UI components in our app. And we'll look at this later, but can help us automatically update things like the app bar at the top of our screen or the bottom navigation view down at the bottom of the screen. Now, to provide this functionality, there's three key classes or components here. We have the navigation graph itself. The navigation graph is an XML resource document. So you think of it very similarly to how you might think of a layout or a menu. All of these destinations and actions will be defined in XML. That XML is then what powers that visual representation that we just looked at. We then have a nav host, and the nav host is very similar to having a layout to display your fragments. Basically, the nav host is a location where the nav controller will place new fragments when they need to be added or removed. And then finally, the nav controller, it is this element that actually manages the transactions from one destination to another. It takes in actions, it takes in URIs, it takes in deep links, and then routes to the proper fragment and places that into the nav host. Now, to make all of this work, there's a few dependencies that we'll add to our project, and we'll see that in the demo. The first one here is optional, which is the Navigation Safe Args Gradle plugin. However, because as I've mentioned, I think that the Safe Args feature for parameters, which means it validates that we're passing the right data to our fragments, I think that's really powerful. And so we will be using that in our demo this week. Then in our apps build.gradle file, we'll be adding the navigation fragment.ktx dependency and the navigation UI KTX dependency. So these will give us all of the APIs and classes needed to implement navigation in our apps and some nice Kotlin helpers to make that a little bit easier to do. So how do we actually go about implementing navigation in our app once we've added these dependencies? Well, there's a number of steps here. So we'll walk through it kind of one by one at a high level. And then in the demo, we'll actually get in and do these things in our code. So to start, we will create a nav graph. And the nav graph, like I mentioned, is a XML file where we can define destinations, actions, arguments, animations, things like that. Then within that graph, we will add a start destination so that the graph knows which fragment to show when it is started. Then we will add our nav graph to the nav host so that we have a place to put these fragments. And in our app, that nav host will live within our main activity layout file. Now, once we have the graph set up and we have a start destination, we can start to add more destinations. So if we only had one destination, there'd be no reason to use the navigation component because there wouldn't be any navigation. So we will add some more destinations within our nav graph XML file. We'll then connect those destinations with actions, and that action can then be used by the nav controller to navigate between destinations. So now let's talk a little bit about material design. So what is material design? This is something that maybe you've heard of, maybe you haven't heard of. So I think it's good to talk about it for a minute because it is pretty important in the world of Android development. So material design is a design language developed by Google. Google released their first version of material design back in roughly, I think it was 2014-ish. Basically, material design came with the Android Lollipop release, and it was kind of revolutionary at the time because at that point there wasn't really a consistent design language for Android apps. I mean, there was, but not a lot of developers or teams were really sticking to it. There was a lot of their own stuff, which is why a lot of old Android apps looked very different from each other, and some of them, frankly, did not look very good. So material design was really Google's first major attempt here to help standardize how UI elements should look, the sizing, the styling, even the interactions. You know, how should a button respond when you click it? Should there be a ripple? Should it increase its elevation a little bit? You know, how should animations between screens be done? Basically, it's just a whole set of guidance around colors, typography, elements, sizing, transitions, stuff like that. And ultimately, it simplifies design for developers. It's really, really nice for app developers because it gives us some nice baselines to fall back on. If we don't have a designer with us or our designer is busy, we can fall back on material design for things like how large should this text be? How much spacing should I have between these elements? What should the feedback look like when I touch a list item? And we've already actually touched on some material design in this course without necessarily knowing it that much. You know, as we have seen earlier, as we click on a list item in our app, we get that little ripple color. That ripple, as we touch on an element, is an element of material design. Same thing as we click our fab. The elevation on that button changes a little bit, and we see that little ripple as some touch feedback. Those are all elements coming from material design. And so it really is something prominent to Android. And thankfully, a lot of the components these days build in these elements of material design so that if we set up our theme properly, these elements will look and feel a way that is in accordance with material design without us having to do a lot of extra work. So if you want to learn more about material design, which I would encourage you to do if you're going to continue on with any type of app development or web development, material.io is the best resource to start. So this is the website for material design. And here it's chock full of resources. They have design guidelines for individual elements. They have documentation and specs for individual components. They have icons available to you that you could download and use. They have accessibility guidance and strategies for testing and implementing that. And then a bunch of tutorials as well. And so one of the really useful, interesting things here is the component library. The component library defines different types of elements on the screen and then provides documentation and actual implementations of these for different platforms. So you see here we have app bar on the bottom or app bar on the top, and then we have links for Android, iOS, or Flutter, or even the web. And those links will take you to specific implementations and guidance for those platforms. We also have the bottom navigation there down in the bottom middle. And again, that is something we'll be implementing this week. So as far as material design components go, this week we're going to be touching on two of them. We're going to be looking at the app bar, which is the little bar at the top of our app. Often people will refer to it as the toolbar as well. And then we have the bottom navigation, which will sit down at the bottom and let us switch between screens in our app. So the app bar here, again, it sits at the top, and it's typically a place to display actions and information related to the current screen. So we might have the title of our app or the title of the screen. And then we might have a menu button and some different actions associated with that menu. You might also have a back button or a button to pull open a navigation drawer. You see in the Material IO specs, we also have a lot of good guidance here for how large an app bar should be. How big should the icons be? How tall should the bar be? Thankfully, if we just add a toolbar into our app, a lot of this stuff will come for free. Same thing if we inflate a menu, a lot of the stuff comes for free. So this is where the components we have implement a lot of this stuff for us, but if we ever have questions or we ever need to do something custom, we can fall back on the material design specs to get some nice guidance to make that look good by default. Next up, we have bottom navigation. So bottom navigation sits at the bottom of the screen like you might expect. Really, bottom navigation has been adopted more recently because it's easier for people to access with their thumbs, which makes switching between top-level destinations of your app a lot easier. So generally, each tab in the bottom navigation view is going to have an icon and a label. This might change depending on how many elements you have down there and what size of device you have, but in general, you'll have both of those elements. It's possible to also show notification badges down in the bottom navigation view, although we won't be getting into that in this course. And then with the bottom navigation view, you can listen for things like selection of an element or reselection of an element, and you can respond to your screen accordingly. One example of this could be that you might want to listen for when you select, let's say, the Places tab in this example, and you might then want to update the title of your app bar to reflect the screen that you're currently viewing. And again, Material IO has nice specs for how the app bar should look as well. Now, I just want to call out one particular doc here on Material IO, which is their Understanding Navigation document. I will include links to this in the lecture notes, but this is a really nice read to understand some of the concepts behind navigation and how to think about building navigation into your application. So this is a good resource for you to just review and help learn a bit more about how you could think about constructing the flow of your app. Now is the color tool here. So this is at material.io color tool here. So this is at material.io/resources/color. And this is really nice because it provides the kind of standard material palettes for all of the different colors there. It then also lets you select a primary and a secondary color, which, remember back to our theme in our app, we have a primary color, an accent color, and like a primary dark. Well, so these are stemming from that. So secondary color is essentially equivalent to the accent color here. Primary is the same as primary. And as you select different colors for those, it will show you how those colors can look and interact across different types of kind of mock designs. It also has tools for checking the accessibility of your colors, which is really, really helpful when choosing your app theme. So this is just something to look at if you want to update how your app looks, or you're looking for a color scheme for, a presentation or something. The color tool here is a nice resource available to us. Alrighty, so we've covered what navigation architecture component is, the problems it's trying to solve, kind of the functionality with it. And we've also talked a little bit about material design and how that starts to play into bottom navigation and navigation as well. So now we'll go ahead and jump over to Android Studio, and we'll start our code demo as we update our app to implement a navigation, and specifically bottom navigation. As we start off building out our app towards using the navigation component, we're going to need to first start clearing out some of the existing stuff we have in our app towards showing fragments on the screen. So to start with that, we were going to open up main activity. And we're going to start removing some stuff from the screen. So one thing we're going to remove is to come down to main activity.onCreate, and we're going to remove, and by remove I mean delete, this fragment transaction to show the location entry fragment. So we'll go ahead and delete that. Then we're going to want to open up our layout file. So we'll open activity_main. And here we're going to want to delete this frame layout that we were using as our fragment container. So again, we'll go ahead and delete that as well. Then if we come back into main activity, we'll see down at the bottom we had these navigate to current forecast method and navigate to location entry method. Those currently rely on that fragment container. However, we're going to be replacing the logic for how we navigate to things to make use of the navigation component. So for now, we're going to just highlight these lines of code and comment them out by hitting either Command/ or Control/. So here I've commented both of those out, and now we're just going to redeploy our app to see how it looks. And now, as you might expect here, we have just a blank screen. We have nothing on the screen. And honestly, that is exactly what we want right now. So let's jump back over to Android Studio. Now we want to add the navigation component dependencies to our app. So to start with that, I'm going to go into the left-hand side of the screen into our project window. And we're going to navigate to our project level build.gradle file. So as I open that up, I'm going to be looking for this build script section right here towards the top. And specifically, I'm going to be looking for the dependencies section. And you'll notice a couple of lines already exist here. They both start with the word class path. So we're going to add another item here. So we're going to start off by typing class path, then two quotes, and then we're going to add Android X dot navigation colon navigation dash safe dash args dash gradle dash plugin, and we're going to be using 2.2.2 as our version. And now, just to double check that we are that we imported this properly, we'll go ahead and click the Sync Now button. And this should perform a Gradle sync for us. And it looks like that worked properly. So now this has added the Safe Args Gradle plugin. So this is what will enable Android Studio to generate actual class implementations that enforce the arguments we need to pass into fragments. So if we need a fragment that requires a zip code to load the forecast data, using the Safe Args plugin will help us enforce that parameter is present at compile time. Now, to actually apply this new plugin to our app, we need to open up our app level build.gradle file. And up at the top where we have these other apply plugin lines, we're going to type apply plugin : quotes again, Android X dot navigation dot safe args dot Kotlin. And now we're going to scroll down to our dependencies block within the same app level build.gradle file. We're going to come down here somewhere in the middle where we have these other implementation lines. And now we're going to add the dependencies needed for the navigation component itself. So again, I'll start with implementation. And then in our quotes here, we're going to be using Android X dot navigation : navigation dash fragment dash ktx : version 2.2.2. And then one more dependency that we need here is implementation, double quotes again, Android X dot navigation : navigation dash UI dash ktx : 2.2.2. So now we should have the navigation component. We should have some navigation helpers in Kotlin to help us set the component up properly. And we have applied the safe args plugin. So now let's go ahead and sync this again. So you could use the sync button in the upper right of the screen, or come up into your menu, find the button that looks like an elephant with a down arrow, and click that. Either way, it's going to resync the project with Gradle. And thankfully here, it looks like everything has worked. So now we need to do sort of one more set of configurations to make sure that everything is going to work properly down the line for us. So again, within the app level build.gradle file, we're going to scroll up a little way. So you should see that we have an Android block with some curly braces, and then a dependencies block with some curly braces. Within that Android block, we're going to click in and create a couple lines. So this should be within the Android block here. And now we're going to type compile options with an open and closed curly brace. And now in here, we're going to tell Gradle that we want to use Java version 8 when it compiles our app. This is necessary for the Safe Args plugin to work properly. So to do that, we can type source compatibility equals Java version dot version, and it should start to pop up with some options here. We'll go ahead and navigate to version _1_8. And now we want to essentially duplicate this line, but instead of source compatibility, we want to define target compatibility. So now both our source and our target compilation options will be using Java version 8. And now one sort of extra piece here that we need to do is now we want to update our Kotlin compile options. So we'll come right below compile options and we will type Kotlin options, once again, open and close curly brace. This time we'll type JVM target equals, and then once again, it's going to be Java version dot version _1 _8. All right. So one more time, let's do a sync to make sure everything is proper. And all right, it looks like we are good. So now it's time to go ahead and add our navigation graph to our project. So to add a navigation graph, we're going to come over to the left, go to our project pane, and under the res directory here, we're going to right click, go to new Android resource file, And we're going to choose navigation from the resource type. And we're going to give this a name of main_nav. And then go ahead and hit OK. And then if it prompts you to add the file to Git, of course, say yes to the add. So now we actually have a navigation graph in our app. So let's go ahead and start adding some destinations to this graph. Now by default, it has opened me up into the XML view. But just to call out, this is just like working with layout files where we have an XML view and we have the sort of design editor view. So if you open up into the XML, just like we do with layouts, go up to the upper right and open up the design view. Now, right now, because we do not have any destinations added to our project, this view does not look very exciting. So let's go ahead and add our first destination to our navigation graph. We can do this by clicking the little green plus icon, which stands for new destination. So if I click new destination, it's going to open up a list of fragments that it recognizes in our app that we could use as destinations. So we want to add the fragment location entry as our first option here. So if I select that, it's now going to bring in a little preview of the location entry fragment. And this is now our first destination in our nav graph. And by default, you'll notice this little home icon next to the name. This is signifying that this is the default start destination for the graph. Now let's take a look at what this looks like in the XML. So in the XML view, we see here that we have defined a fragment. It's automatically given it an ID of location entry fragment. The name property here is the fully qualified name of the location entry. So you see it's the full path to where that class is found within our code base. The label is a label that might get displayed, let's say in an app bar, depending on the configuration of your project. And then the tools:_layout attribute here is what is letting us visualize what that fragment looks like in the editor. So now we need to go ahead and add a nav host that will store this nav graph. So to do that, we're going to open up activity_main.xml. And now we're going to add a fragment container view that will act as our nav host. So to do that, we'll type an open bracket here, and we'll type androidx.fragment, and you should see fragment container view pop up. So go ahead and hit enter to complete the fragment container view. And then we're going to give it an ID of nav_host_fragment to give it a name. Give it a name of androidx.navigation.fragment.navHostFragment. For layout width and height, we're going to use 0dp for both. 0dp for width, 0dp for height. Oops. There we go. Now to constrain this, I'm going to jump over to my design view here, and I'm just going to drag the constraints to the parent edges. There we go. Back over to the XML just to double check. So now we have bottom to bottom of parent, and XML just to double check. So now we have bottom to bottom of parent, and end of parent, start of parent, top of parent. All right, that looks perfect. So now the interesting stuff. Now that we have this fragment container view that fills the screen to act as our nav host, we need to actually specify it as the nav host. To do that, we type app default nav host equals true. And then we'll enter a new line, and then we're going to do app navgraph equals at navigation / main nav. So this is pointing the navigation graph that we just created to this fragment container view, so that when activity main is loaded, fragment container view is going to load that nav graph for us. So if we go ahead and redeploy the app now, we should see this redeploy, and we should now see our fragment is visible on the screen. This is because our navigation graph is inflated and it finds the default destination, which is location entry fragment, and automatically places that into the screen for us. So now let's go ahead and return back to Android Studio. And now we want to work on building out this navigation graph. We want to make it look a little bit more interesting. So let's return to our main_nav.xml file. I'm going to return to the design view, and I'm going to click add destination again. And this time I'm going to select the current forecast fragment. And so you see now it's added that preview of current forecast fragment. Now that both fragments are in our app, we'll still only see the one fragment. In fact, we could do that real quick again here. Deployed, and yet we still just see the location, entry fragment. And that is because while both fragments are in our graph, it's only showing one at a time, and we have not defined any type of way of getting from location entry fragment to the current forecast fragment. So we need to connect these two destinations in our graph so that we can navigate between them. Now there's a couple ways that we could add a destination. To start, we could click on location entry fragment. We could right click on it then and select add action, and then select to destination. You see, when I do that, it brings up this dialog here with a number of things for us to fill out. So by default, it's going to ask us for an ID, and it can generate that ID for us. The from field is specifying what destination we're navigating away from, and then we have to add the destination we want to navigate to. So in this case, we'll go ahead and select the current forecast fragment as our destination. And now below that, we could enter in some animations if we wanted to, or the pop behavior, launch options. We're not going to worry about any of those for now. We're just going to go ahead and click add. And we'll see that when we click add, we now have this arrow going from location entry fragment to current forecast fragment. So this represents an action we can take that will navigate us from one fragment to the other. So that has been kind of one way of creating this. It's a little bit more verbose way. If we want to delete this action, we can just click on the arrow and hit delete. So now let's specify an action in a way that's a little bit more straightforward. If you move your mouse over location entry fragment, or the other fragment for that matter, you'll see a little circle pop up. This little circle looks a lot like constraint guidelines in constraint layout. So if you grab that little circle and you drag from one fragment over to the other, it'll create an action for you, and it will pre-populate some of those fields with reasonable defaults. So if you look over to the right in the attributes pane, you'll see that it's automatically created an action for us going to current forecast fragment. It's left all the animation stuff by default, and then it's applied some defaults to the pop behavior and launch options as well. So this is the easiest way to create an action. It's the way I would recommend for most simple cases. If we open up into the XML, we can see here what that action looks like. So we'll see that the action is added within the XML of the fragment it's navigating away from. So in this case, location entry fragment now has an action with an ID. There's a very long ID that specifies very explicitly where the action is going, and then the destination. Have this action defined. We want to go ahead and reconnect the fragment navigation within our app. So we're going to navigate over to main activity. And we want to scroll down to the navigate to current forecast method here. So this is one of those methods at the beginning that we commented out. And we commented it out because we were going to be replacing the old way of manually adding the fragment with the new, simpler way of using the navigation component. So now we're going to use the nav controller to navigate to our desired fragment. So if we delete this commented out code, the first thing that we need to do is define the action that will be used by the nav controller to decide what fragment to show next. So to do this, I'm going to create a local variable called action equals, and then we want to get access to the generated actions class. And so what we want to access here is location entry fragment directions. However, as you can see here, it's complaining. It's saying this class doesn't exist. So this is an important thing to keep in mind when you're working with a navigation component. Action classes and a safe argument classes, those are generated by the plugins in the compiler. So if you try to access one of these and it doesn't exist, it's likely because it hasn't been generated. So in that case, go up to build and rebuild. That rebuild will trigger the compiler to generate the options needed. And so now I'm being prompted to import this class. And now I do have access to location entry fragment directions. So this directions class will contain all of the actions that have been specified in the nav graph. So you see here, I can add a reference to action location entry fragment to current forecast fragment. So you see, that's a very long name, but it's very clear what this action is doing. It's going to go from location entry fragment to the current forecast fragment, which is exactly what we want. So now that we have this action defined, how do we actually navigate to it? How do we make use of this action? Well, what we want to do is call a method called find nav controller. This is a method on an activity to let us get access to a nav controller within the activities layout. And so here we're then going to pass in the ID of the nav controller, or of the nav host, our id.nav host fragment. So now we have access to the nav controller. Now remember from earlier in the lecture, the nav controller is this class that manages the fragment transactions for us. So now we have access to that. We're going to call navigate, and we're going to pass in the action. Once we've done this, we can redeploy our app. And once this is redeployed, we should be able to go to our current forecast fragment once again when we enter in a zip code and click submit. So that's the first step. That has been our first case of implementing an action going from one fragment to another fragment. So now let's continue on. Let's make it so that we can go backwards if we needed to. So let's once again open up main nav.xml. We'll look at our nav graph here. And now we want to create an action that goes from the current forecast fragment back to location entry fragment. So once again, I will drag from current forecast fragment over to location entry fragment. Then we're going to just go ahead and do a preemptive rebuild to regenerate the required directions class. Then we're going to once again open up main activity. Now I'm going to go back down to our navigate to location entry method that we had commented out before. And once again, I'm going to implement this to navigate to the desired fragment using the nav controller. So in this case, once again, I'm going to use val action equals, this time it's going to be current forecast fragment directions dot action current forecast fragment to location entry fragment. And then once again, find nav controller r.id nav host fragment navigate action. So once again, let's rerun this. And so now, if I enter in a zip code, we're now getting our details here. If I click the floating action button here, we'll see it navigates me back to the location entry screen. So now both of those actions are implemented and we have two-way navigation within our app. So now if we enter a zip code, we show our forecast here. If we click into one of these items, we'll see that we're still showing the details. And currently our forecast details is still being implemented using a separate activity. Now, using the nav graph, it's nice to try and include as many things as fragments into the graph as you can. So what we're going to do is integrate forecast details into our navigation graph. And the first thing that we're going to need to do here is to convert our location details activity into a fragment. So let's go back to Android Studio, and I'm going to close all of these files, and then I'm going to open up location. Oops, I'm going to open up location. Excuse me. Sorry. I'm going to open up forecast details activity. I had the wrong thing written in my notes. So forecast details activity here. And now we want to convert this to a fragment. And so we can do this fairly easily. And we're just going to walk through it step by step. So the first thing that we want to do is to right click on the class name, go down to refactor, and then select rename. And then we're going to enter in forecast details fragment as our new class name, and then hit enter. And now when you do that, notice it changes the class name here in the code. It also renames the file, and you can see that over on the left-hand side of the screen in the project pane. So that's the first step. Next, that we want to go and update the layout. So I'm going to click into Activity Forecast Details XML. I'm going to go over to the left-hand side of the screen, right-click on the file name, again go to Refactor, Rename. And then I'm going to just replace the activity with fragment. So it should read Fragment Forecast Details. And then I'll hit Refactor. If I go back over to the fragment class, I should see now that the call to set content view has automatically been updated for us. Now there's one other quick change we need to make. We need to go into our manifest file, and we need to delete the addition of that fragment because it's no longer an activity, so it no longer has any business being in the manifest. So I'll delete that line, go ahead and close the manifest. Now we have some more work to do here in this new fragment class. So to start, even though we changed the name to fragment, it still extends an activity, which means it still is an activity. So we're going to highlight app-compat activity here and replace that with fragment and hit enter. As soon as I do that, it's going to show me a number of errors here. Basically, it's going to point out that there's all this stuff in here related to activities that's no longer applicable. So we can start fixing some of these by simply removing these two methods at the bottom related to the options menu. We're not going to be using either of those anymore. So we'll delete that. And that has greatly reduced the number of errors we have in this file. Next, here we have onCreate. Now in fragments, remember that typically we're doing all of our setup in onCreate view. So I'm going to generate an implementation of onCreate view. And then we're going to just set this up like we have with our past fragments to get a reference to the view and return that. So I'm going to type val layout equals, and then I'm going to return layout. Then where it says layout equals super.onCreate view, we want to replace this with inflator.inflate r.layout.fragment forecast details. Then we're going to pass in the container and pass in false. So now onCreate view is ready to accept our setup logic. The line for temp display settings manager. And we're going to paste temp display settings manager. And we're going to paste that into onCreate view here. Then, where it is complaining about referencing this and needing a context, we'll update that with require context. Then we're going to come down here to where it says bind forecast data. And again, we're just going to grab all of this. We're going to copy it, delete it. We're going to delete the whole bind forecast data method. And then we're going to paste that up here within onCreate view. This is just to kind of simplify our setup a little bit. Now here where it says find view by ID, this is an error, and we talked about this last week. Fragments don't have find view by ID. You have to use the fragments layout to find the view. So in this case, we'll type layout dot find view by ID, and once again, layout dot find view by ID. And then for now, we're just going to comment out this code here for getting the extras for the data to display. And then we can go ahead and simply delete the onCreate method now that we're no longer using it. So now we should have forecast details fragment set up and ready to go. The next step is going to be to add location details, or excuse me, forecast details fragment to our navigation graph. So go ahead and open up main nav.xml. Destination, this time forecast details fragment. Forecast details fragment. So we see again, it's added our little preview. So now we want to connect the current forecast fragment to our forecast details fragment. So I will select current forecast fragment, and I will drag an arrow over to forecast details fragment. And just for good measure, once again, let's do a rebuild so that it generates the required action class. There we go. So now we're going to open up into current forecast fragment. We want to do this so that we can update how we're going to navigate into our forecast details screen. So if we look at the show forecast details method here, we'll see that we were previously updating this using an intent and then starting the activity based on that intent. However, this doesn't work anymore because we are using a fragment. If we tried to start this fragment with an intent, it would fail. So we're going to go ahead and delete this for now. Now we're going to open up our app navigator interface. Remember, this is the interface we've been using to communicate back to the activity to determine how we want to navigate between screens. So within App Navigator, we're going to add a new method. That new method is going to be called Navigate to Forecast Details, and it's going to take in a forecast parameter. If we go back to current forecast fragment, we're then going to type app navigator dot navigate to forecast details, and we're going to pass in that forecast object that we have. So now this is telling the app navigator, hey, we want to show the forecast details. Current forecast fragment doesn't currently know anything about how that will happen. It just knows, hey, I want to show forecast details now. So to actually show the details, we need to go to main activity once again. Now, if you look at the name of main activity, it's complaining that we do not have all required implemented methods. This is because we have added that method to App Navigator, but we haven't added it to main activity, which implements App Navigator. So we're going to come up down here and we're going to generate the navigate to forecast details method. And now we are free to implement this once again using the nav controller and the generated action class. So I will type val action equals current forecast fragment directions dot action forecast details fragment, and we will once again do find nav controller r.id nav host fragment dot navigate and pass in action. And once again, let's navigate our app and see what that has done to the navigation structure. So here we're location details, location entry. I click submit. I now have my list here. And if I click on an item, we see that we have definitely done something. We've navigated to this blank screen. Now, what is wrong with this? Why do we have the blank screen? Well, it's because we have not actually passed any data to that fragment. When we commented out the code that would pull that data in and set it to the layout. So that's why it's empty here. There's one other issue you might notice is that we have no back arrow here to indicate that we even went anywhere. In fact, if I hit back, we do in fact go backwards. But there's no indication of that when you're just on this blank screen. So that's another issue that we are eventually going to look at. However, we're going to start by fixing the empty fragment. So we're going to come back to Android Studio, and we're going to return to forecast details fragment. And you can see here that, again, we commented out the code that would update the UI for the data that we would need. So how can we pass that data over now that we're not using intents? Well, this is where we're going to use the safe args plugin that I talked about previously. So let's go back to mainNav.xml and our nice navigation graph here. we're going to click on forecast details fragment. I'm just going to reorganize these real quick. So click on forecast details fragment. We're going to go over to the right-hand side of the screen into the attributes pane. And you can see here where it says arguments. If I expand that drop down, it says nothing to show. So I want to go to arguments on the right-hand side, and I'm going to type or click the little plus icon. And this is going to pull up a dialog that will let me add a new argument required for this fragment. And so for the first one, I'm going to type temp. I'm going to make it of type float, and then I'm going to click add. So that will give us that temp argument that we need to show the temperature. Once again, let's go over to the arguments tab in the attributes pane, click plus. This time I'm going to create an argument called description. It's going to be of type string, and then again I'll hit add. Now let's open up the XML quick just to see what that has done. So down here at the bottom, we see our forecast details fragment. And within that fragment tag, we now have these two argument tags that really are pretty simple. It's an argument type, and it is a name and a argument type, so float or string. So that's how it is going to know that this fragment needs arguments of this type to properly to work. Now, how do we actually pass the data needed for these arguments? Well, once again, these safe-args compiler plugin here works by generating code for us. So we need to rebuild our project before we do anything. And hopefully this works pretty quickly. And now as soon as I do that rebuild, you see I'm getting an error here. It's telling me no value passed for temp. And it's automatically shifted me over to main activity. So this is where I was previously defining that transition into the forecast details fragment. And previously we didn't have any data being passed to that. However, now that we've added arguments to that fragment, the compiler is enforcing that we need to pass in a description and a temperature value. And we do that using this action class that was generated. So to make this happy, I'll type forecast.temp, forecast.description. So that should go ahead and make it happy at this point. Now let's go ahead and redeploy the app. I'm gonna enter in a zip code once again. I click in a zip code once again. I click on a forecast item and shoot, we still see this empty screen. Well, why is that? Well, we go back over to forecast details fragment, and it's because we have not actually taken those values that were passed in and put them into the UI in any kind of way. So how do we actually go about doing that? Once again, with the idea that we're no longer using an intent. How can we grab the arguments when using the safe arguments plugin? Well, there's actually a pretty convenient way of going about doing this. If we go to the top of forecast details fragment, we're going to add a new property. It's going to be a private val, and we're going to call this args. And it is going to be of type forecast details fragment args. Again, this is a generated class. As soon as we added the argument values within our navigation graph and we rebuilt it, it generated this details fragment args class. Then we're going to get access to these using a delegate. A delegate is a special Kotlin feature. We're not going to get really into it now, but to use the delegate, we simply type by nav args. And then it's going to ask you to import it. So we'll just hit Alt Enter, and it should import that nav args delegate function. Essentially what this is doing is the nav args is acting like a function there. So whenever we access the args property, the first time we do, it's going to use that nav args function to look up those args and get the data for us. So now that we have the arguments available to us, we can come back down to onCreateView and we can uncomment this code. And now we can update this to actually display the temperature data. So I'm going to delete this first line here because we're going to be able to do this all in one line. So now here, where before we were passing in temp, we're going to type args.temp. We'll see that we actually have a generated class, which is that fragment args class, and we have statically typed argument values. So we're no longer looking things up by key. We're actually looking them up with compile time validation. And so then down on the next line, where we are passing in the description text, we can type args.description. So now, finally, if we deploy our app once again, we should be able to enter a zip code, click on a forecast, and now finally we see the forecast data, and it's all working with the navigation component behind the scenes. Okay, now we're ready to update our app to include bottom navigation. Now, before we really do that, there's a few housekeeping things we need to do to make sure our themes and stylings are up to date. So the first thing that we're going to do is go over to the left-hand side of the screen, navigate to res, values, and then open up our styles.xml file. And here where we have our app theme, currently it is theme app compat light dark action bar. We want to update this to be no action bar. This is because we're going to provide our own toolbar within main activities layout, and that toolbar will be used as the app bar instead of the one provided by the theme. So let's now go over to activity main, and we're going to go ahead and add a toolbar that will be used as the app's app bar. So to do that, I'll start typing toolbar, and I want to use the Android X app compat widget version of toolbar. For the width, we'll pass match parent. For the height, wrap content. For the background, we want to use our primary color. So we're going to do $attr/color primary. And then we're going to go ahead and close that off. And then we're going to open up the design view. And now we want to constrain it. So I'm going to select the toolbar. I'm going to go over to the attributes pane on the right, and I'm going to click the top, left, and right to constrain this to the parent on the both left and right and top sides. Now I want to update the nav host fragment, and I want to update this so that it is constrained to the bottom of the app bar. So I'll go into the XML. I'm going to come down to the fragment container view, and where it says constraint top to bottom of toolbar, you'll notice that it is giving a complaint here. It's saying the ID toolbar not defined anywhere. So all we need to do to update our constraint properly is type ID @+ID toolbar. So now if we go back to the design view, we should see that we have a toolbar at the top and our nav host fragment below that. Now, while we're here in the main activity XML, there's one other small change we need to make. Fragment container view, even though it is what is recommended by the Android Studio IDE, there's actually an issue with this that will cause your fragment not to be shown up on the screen correctly in some cases. So we're going to replace this with simply fragment. Now notice again, if you hover over that, it'll say replace fragment with fragment container view. That is a bug, unfortunately. You do not want to do that. So replace it with fragment and things should work as expected. So now it's time for us to actually configure our app bar and connect it with our navigation graph so that it updates as our navigation changes. To do that, we'll open up main activity. We're going to go into onCreate, hit enter a couple times, give us some space to work. And we're going to start by getting a reference to the nav controller. So we'll create a variable called nav controller equals find nav controller r.id.nav host fragment. And now we're going to create an app bar configuration. So again, we'll create a variable called val app bar configuration equals app bar configuration. And we will pass in nav controller dot graph. So that's going to create an app bar configuration based on our navigation graph. And now it's time to connect them. So we'll first get a reference to our toolbar by typing find view by ID. We have to pass in the toolbar type here within the brackets. Now we'll pass in the ID of r.id.toolbar. And now that we have a reference to our toolbar, we can call .setup with nav controller, and we will pass in our nav controller and our app bar configuration. So now if we deploy this, our app bar will change in response to whatever fragment we're currently showing. And notice it's also now giving us the nice back button and even a little animation when the back button goes away. However, notice that the labels for this are not very nice. So how can we change that? Well, if we open up our navigation graph, if we look at the XML view, we'll see that each fragment has a label defined. However, by default, the labels are not very attractive. So we could replace these with better labels. So we could just type location entry fragment here to start and current forecast fragment. And then for the last one, forecast details fragment. Now let's redeploy and see what that looks like. So there we go. That looks a little bit better. We at least have sort of reasonable capitalization and spacing. However, to the user, they really don't care that these are fragments at all. So one thing that we could do here to just give us a nice consistent look is instead of individual labels, we could just have our app name. So we'll type this by doing string/app name, and we'll do that for each fragment. So now that each fragment is using app name as the label, our app bar should look consistent as we are navigating between screens. So this is something you may or may not want. That'll kind of depend on the design of your app. But for us, for this app, I think having that be consistent for now is a nice step. Navigation really works if you have at least a couple of screens that you want to show at the top level. So for us, we're going to create a new forecast fragment, and we're going to call this weekly forecast fragment. To start, we're going to close all of our existing files. Then we're going to go over to the left-hand side of the screen into the project pane. We are going to right-click on current forecast fragment. We're going to click copy. Then we're going to right-click again and we're going to type paste. And this is going to copy current forecast fragment for us. And it's going to ask us to enter a new class name. And we're going to update the name to be weekly forecast fragment. And then hit OK. Next up, we want to go to the layout file for fragment current forecast. And once again, we're going to duplicate this. So I'll do a copy and then a paste. And this time I want to name it fragment weekly forecast. Once again, I'll hit OK. Now I can go ahead and close that, close the other layout. Now back here within the weekly forecast fragment, I want to update the reference to this layout to be fragment. Whoops, something went wrong there. r.layout fragment weekly forecast. I think Android Studio is a little confused, so I'm going to do a quick rebuild. For some reason, it is still confused here. Let's try a deploy, see if that unconfuses it. So now we want to add weekly forecast fragment to our nav graph. So weekly forecast fragment to our nav graph. So I'm going to open main_nav.xml. Go to our design view here. I'm going to add a new destination, this time weekly forecast fragment. We'll see by default it has an unavailable preview, so it doesn't know really how to show this for us. So I'm going to open up the XML, come down to the very bottom where it added that element, and I'm going to say tools layout equals fragment weekly forecast. And if we go back into our design view here, now we see the nice preview. And we're going to go ahead and connect weekly forecast fragment to the details fragment and to the location entry fragment. So now let's rearrange these a little bit so it makes a little bit more sense. So we're going to put the forecast fragments on the left, the details and location entry on the right. And we'll see here we have this nice sort of balanced navigation graph, except that we have this action going from location entry back to current forecast. We're going to go ahead and delete that for now because we're not going to need it anymore. So I'll select it, hit delete. And once again, because we have modified our graph and we want to generate the proper action classes, we're going to do a rebuild. Longer exist. That's what we expect since we removed an action. And if we scroll down, And if we scroll down to where that was being used, we're just going to comment that out for now because we will update that here in a little bit. So now let's once again do a rebuild. And there we are. Okay, so now we're ready to actually add the bottom navigation view to our main activity. So let's open up activity main.xml and scroll down to the bottom. If we open up the design view, if we go to containers in our palette, we'll notice we can find bottom navigation view. And we're just going to drag that to the bottom of our screen. And then let's go ahead and constrain this. So we'll go to the layout pane on the right-hand side of the screen, and I'm going to hit the bottom add, the left, and the right. There we go. We're going to make sure that there is no margin attached. For layout width, we're going to do 0 dp. And for height, wrap content. Now let's go back to the XML just to double check how this is all looking. So constraint bottom to bottom of parent is correct. Constraint end, we want to be aligned to end of parent. There we go. I think that was causing the problem with mine. And start to start of parent. So there we go. Now we see that we have this black bar down at the bottom of the screen. So now we want to update the nav host fragment to sit on top of that. So we'll do that. We'll click on it. we'll grab the little bottom arrow and we'll drag it to the top of the bottom nav view. To this, to our navigation graph eventually. Now, just for some styling things here, we're going to update the background color of this to be white so that it looks nice with the rest of our theme. So we're going to add the Android background property, select at color, select at Android color/white. And now if we look at the design view again, we'll notice that it's white down there at the bottom of the screen, which is what we want. Okay. So now the next step is we need to create a menu that will define the items shown in the bottom navigation view. So again, go to the project pane on the left-hand side of the screen, go to Res, go to Menu, right-click, New Menu Resource File. We're going to name this main_nav since it will mirror our navigation fragment or our navigation graph. And I'll go ahead and hit OK. I'll add. And so now we're going to define menu items that will configure the tabs in our bottom navigation view. So to start, we will create a new item. Then we're going to add an ID. The ID for this first one is going to be current forecast fragment. We want to make sure that the ID used in these menu items matches the IDs in our navigation graph. So here I've used current forecast fragment. And if I look at my navigation view and I look at the current forecast fragment, it has the same ID. So I've passed in the ID. Now for the icon, I'm going to use the same location icon that we've used elsewhere. And now I can pass in a title. Now for the title, we're going to create a new string resource. So I'm going to go to my strings.xml file. I'm going to create a new string. I'm going to call that string bottom nav label today. And I'm going to give it the value of today. Go back over to main nav here and go at string/bottom, string/, why is that not recognizing the string? Oops, that's because I selected a style, not a string, excuse me. So string name, bottom nav label today. There we go. Bottom nav label today. And then we'll finish off that item with the closing tag. So that will be our first menu item. Now we're going to select a second menu item, and this will be to show the weekly forecast. So again, item ID equals weekly forecast fragment this time. Now it wants an icon. So this time I'm going to create a new icon. So I'll come over to the left side of the screen, go to Res, Drawable, right click on Drawable, go to New, Vector Asset. And I'm going to look for this icon here that is, it's a cloud. So if I type cloud, I'll see we have a number of cloud looking icons here. I'm going to select this one that's just WB Cloudy here and hit OK. Then we'll go ahead and hit finish, and then we'll click finish and hit add. So now for my icon, I can select drawable, IC WB Cloudy Black. And for title, we're going to go back to strings and we're going to create a label for the weekly forecast. So again, I'll select a string resource, name equals bottom nav label weekly. And I'm going to pass in the label of weekly. We'll go back to our menu, at string bottom nav label weekly, and we'll close off that item tag. So now that we have our menu, we need to connect this to that bottom nav view. To do that, we'll go back to main activity, come down to the bottom where we have our bottom navigation view, and we'll type app : menu equals at menu main nav. So now that is going to inflate that menu into the bottom navigation view, which will give us the icons and labels. So now we need to connect the bottom navigation view with our nav controller. And we'll do that very similarly to how we connected it to our toolbar. We'll go to main activity, up to the top. After the line where we're getting access to our toolbar, we're going to do something very similar. So we're going to type find view by ID, bottom navigation view, r.id.bottom navigation dot setup with nav controller, and we're going to pass in the nav controller. Now let's go ahead and run our app. And now let's see how this works. So notice down here at the bottom, we have our today fragment and we have our weekly fragment. If we tab between those, we'll see that we are getting that nice tab behavior. It's switching between the fragments, although the app bar is still updating, and it's updating in kind of a weird way that we don't really want. We want that to just stay consistent. So let's go back to our main activity, and we're going to change our app bar configuration. Instead of calling set up with nav controller on our toolbar, we're just going to call set title, and we're going to pass in r.string.appName. And now let's run this again and see what that has done for us. Now, as we switch between these tabs, the app bar is not updating. We're just getting the nice, consistent name, which in this case is what we want. There are other designs out there where maybe you would want it to update, but for us, we just want this consistency. However, you might have noticed that it still wasn't quite right, because when we opened our app, it showed location entry fragment instead of the forecast fragment. So what's going on here? Well, if we look at Android Studio again, we go back to our navigation graph. If we go back all the way sort of the beginning here, remember location entry fragment was specified as the start destination. It's got this little home icon on it. This isn't really right anymore because that's not our home destination. Location entry fragment is not an entry point. It is somewhere you navigate to. So let's select current forecast fragment and then go up to the little menu right above here and click the house icon, which says assign start destination. Once I've done that, if I redeploy the app, it should now open up properly into the current forecast fragment. So now as I tab back and forth between the icons, it looks as expected. So now we're really down to sort of one final piece that we want to update. And this is to just kind of consolidate and simplify how the navigation is being done. So specifically right now, when we click a button, we're telling App Navigator, hey, we want to go show this thing. And then ultimately main activity is the one using the nav controller to go to different navigation locations. We can actually simplify this a little bit further because fragments can actually get access to that same nav controller. So I'm going to start by just closing all of these files here. And then we're going to remove the App Navigator interface from our project. And we're just going to do this kind of fragment by fragment. So I'll open forecast details fragment here. And we'll see that it is not, it's not using the app navigator in any way. So this is not a problem for us. Go ahead and close that. Next up, we'll go to current forecast fragment. It is using the app navigator. So I'm going to highlight that app navigator property and the onAttach method. And I'm going to delete that. And as we scroll down, we'll see that we basically now have two errors. We have an error when we try to go to location entry and an error when we try to show forecast details. So instead of using the app navigator, we're going to use the nav controller directly here. Private fun show location entry. Show location entry. And then I'm going to replace this call within location entry button set on click listener to call into show location entry. And now right here, I'm going to use the same pattern we've been using in main activity. I'm going to get a reference to an action and use the nav controller to navigate to that action. So I'll type thou action equals current forecast directions dot action current forecast fragment to location entry fragment, such a long name. Then we can call find nav controller dot navigate and pass in our action. So now we're able to navigate to location entry fragment directly from current forecast fragment using the same nav controller that the activity was using. Now we can update this show forecast details method to do basically the same thing. Thou action equals current forecast directions dot forecast details, and we'll pass in forecast.temp, forecast.description, find nav controller dot navigate and action. Fragment should be good to go. So let's close that. Should be good to go. So let's close that. Let's open weekly forecast fragment. And essentially we're going to need to do essentially the same thing. So we'll delete the references to app navigator. Scroll down here to show forecast details. Once again, create a new method called private fun show location details. From location entry button on click listener, we're going to call show location details. Location details. So once again, thou action equals, this time weekly forecast fragment directions dot action weekly forecast fragment to forecast details fragment. Let's see, I misnamed that. This should be show location entry. Excuse me. There we go. I apologize. So we created a new method called show location entry, and we're calling show location entry when the location entry button is clicked. So here, the action that we want is to show location entry fragment, and then we'll call find nav controller dot navigate action. Then we'll go down below. Thou action equals weekly forecast fragment directions dot action weekly forecast fragment to forecast details fragment. We'll pass in forecast.temp and forecast.description. Then we'll call find nav controller dot navigate, and we'll pass in action. So let's go ahead and close that. We'll come to location entry fragment. So once again, we're going to remove any reference to the app navigator. So for us, that means the property, we can remove the onCreate method and the onAttach method. So now down here, we just need to define what happens when we click the submit button with a successful zip code entered. So previously we were calling navigate to current forecast. Now all we want to do is tell the nav controller that we're no longer needed and they can remove us. So again, we're going to type find nav controller, and this time we're going to type dot navigate up. Navigate up is essentially like navigate back. It's just going to pop this off and go back to whatever was there previously. So now we can go to main activity. We're going to go up to the top and we are going to remove the app navigator declaration in our class declaration. So we're no longer implementing app navigator. And then we'll go down to the bottom and we're just going to remove these three methods that we previously were using in main activity to navigate. Now let's go ahead and go to app navigator and we're just going to right click on that and we're going to delete. Now that we've done all of that, we should be able to do a rebuild. Rebuild, let's go ahead and do a redeploy. Deploy. And here we are. So we start on our current forecast fragment, go over to weekly fragment. We can go to the location entry. If we enter a zip code and hit submit, it'll enter that and go back to before. And we can go to our details and we can click back and it takes us back to our main screen here. So this is now a fully featured implementation of navigation. We're not making use of every feature, but we are now using the navigation controller to navigate to all the different screens in our app. Again, walk through kind of what we've done, here. So let's look at our main nav class. We've used the navigation component from the Android architecture components to define a navigation graph. That graph defines sort of two top-level destinations, which is current forecast fragment and weekly forecast fragment. We were then able to use the visual editor to define how we go from those fragments to location entry fragment and our forecast details fragment. We were able to use our activity main XML file to provide a toolbar to respond to app bar changes in our theme. We have a nav host fragment to hold the fragments that are specified by the nav controller. And we have this bottom navigation view that provides sort of nice bottom navigation implementation from material design. It lets us quickly switch between our top level destinations, and it responds as we click with nice touch feedback and with labels and icons and such. So it gives us a nice look forward towards material design. So again, just notice, the colors change. We're getting ripple effect. And then again, the fragments are changing. And as we saw, we could update the app bar to change as well. However, in this case, we want it to just consistently have the app title. So this has been a good overview of navigation and what we can accomplish with it. So as we move forward, we're going to continue with this model of navigation within our app. Any other navigation between screens will be done using this. And as we move forward towards actually differentiating the data shown by each of these fragments, it'll become more and more apparent how this visual editor makes it really nice to use when visualizing the navigation hierarchy in your project. So as always, if you have any questions, feel free to email me, and I will see you all in the next lecture. Hey devs, and welcome back to week 7 of our mobile application development with Android course. This week, we're continuing to build on our ongoing weather application, and we'll be actually loading real weather data using the Open Weather Map API, and we'll be using a library called Retrofit, which is very popular in the Android world. We'll be using that library to load the data from the Open Weather Map API, bring it into our app, and then we'll be updating our UI to display that real weather information. So as usual, we'll start off with the lecture, and then we'll jump into the code at the end and walk through the updates for this week's assignment. All right, let's go ahead and jump into our lecture then. As usual, we will start off with the project demo and give you an idea of what we will be building on this week and what concepts we'll be exploring. Then we're going to dive into how to make remote network requests on Android. Specifically, we'll be loading remote data from the Open Weather Map API. Then we're going to take a look at how to load remote images as well, and at a couple different libraries we can use to load those remote images and place them into our UI efficiently. And project demo, what are we going to be building? Well, we're going to be focusing on 3 main things. We're going to be looking at how to load current forecast data from Open Weather Map API so we can actually see what the weather is in our entered location. Then we're going to load the 7-day forecast data from Open Weather Map API, again from that same entered zip code location. And then finally, we're going to load and display forecast icons from a remote URL so that our list items actually show icons relating to what that current weather looks like. So before we jump further into the lecture, let's jump over to our emulator. Look at what that is looking like. So here I have opened up my application and I have already entered in a zip code previously. You'll see that because I've loaded the zip code previously, it's actually remembering that on load. So that's going to be the first step this week, is to remember the zip code when we enter it. Then when we open the app, it's going to load data from the Open Weather Map API. You see here, I've loaded the weather data for Seattle, and it's giving me the forecast for the next week, and it's also including icons for each of those forecast items. Zip code is something else. Go ahead and click submit. We'll see this time it loads new data. And we have a different forecast here, and you can see some of the different icons available. If I close my app and open it up once again, we see here again, it has remembered that previous location, and we automatically are shown forecast data when we open up the app. So that's what we will be working on this week. Now, the key part of this, or the biggest change here, is learning how to make network requests from our Android app and to hit a remote data source. So the key question here is, how do we load data from a remote data source? And maybe before we even go too much farther, what is a remote data source? The loading of this data, we're going to be using a specific library that's extremely prevalent in Android. It's pretty much an industry standard. It's called Retrofit. And Retrofit is an HTTP client for Android and Java. And it's an open source library from Square. And Square is, again, super prominent in the industry. They put out many, many great libraries, Retrofit being chief among them. So now back to our idea of loading remote data and even what is a remote data source. So a remote data source is really just any server out there, any type of mechanism that can serve out data to you. So that could be something like a server running on Amazon Web Services or Google Cloud Platform or Heroku. It could be something like Firebase serving out data to you. It could also be a static JSON file hosted on your local machine. Basically, it just means any data that's not really pre-packaged with the app. And in modern apps these days, loading remote data is pretty much essential. It's pretty much any app is going to have to load some type of dynamic data from some type of source. And we really have this two-way street here. We have requests going out to the remote data source. And the data source then sends us back responses. And it's this request and response pattern that Retrofit is really, really well suited to help us with. It simplifies both ends of this process and makes consuming responses and making requests very straightforward for us, whether you are in the Android world or the more generic JVM world. Now, when we're working with Retrofit, there's sort of three key concepts that we'll be taking a look at. To define the API interface that we'll be calling, so this is, think of as the functions of the remote server that we'll be calling. We will define a simple Kotlin interface or Java interface if you were working with Java. This interface will define the methods that we can call, and these methods should correspond to different API endpoints on the backend. We'll then use a class called Retrofit Builder. The Builder class will generate an implementation of our API service. And it's this generated implementation that we can use to actually interact with that remote service. That generated class handles a lot of the boilerplate stuff that we might otherwise have to write ourselves. It knows how to do things like add headers for us, deserialize things, or gives us a place to customize how we might deserialize things. It really does a lot of things for us, and it's largely why it's so popular to use Retrofit these days. And then lastly, we have this class called call. And call represents the request. And we can use call to make either synchronous requests for data or asynchronous requests for data. And we'll take a look at the difference between those in a little bit. When we are getting started with Retrofit, is define the model. And this is the model for the data in the response. So this is an example of the current weather model that we'll be using this week. And this is what we will use to capture the current weather data for the location we have entered. Our interface for working with that backend. So we're going to be creating an interface called Open Weather Map API Service. And on that, we'll have an interface method that looks like this. It'll be called current weather. And we'll have some annotations here. The get annotation is signifying that this is going to be a get request. If you're not familiar with HTTP or a simple like REST request, get is basically a simple request that says, hey, I'm going to ask you for some data, and then I want you to hand me back a response. Each of the query param annotations here signify a different query parameter in the request. All of these query properties here, the zip code, the API key, and the units, those will eventually get appended to the path specified in the get annotation so that it matches the path in the comment at the top of the file here. So ultimately, we want to hit the API that is at http api.openweathermap.org/data/2.5/weather. So all of that is essentially the Open Weather Map's weather endpoint. Everything after that are the query parameters that we're going to specify. So in this case, I have specified a query parameter for 98119 zip code. I want imperial units, and then we have to pass an API key to differentiate our app from someone else's. We can use that Retrofit Builder class to create a retrofit object builder class to create a retrofit object and then use that to create that generated instance of our API class. It's in this builder process where we also have an opportunity to customize how our requests will be made. So in this case, I've specified a base URL of api.openweathermap.org. I've then added a converter factory. This is a converter factory from a library called Moshi, which basically does JSON serialization, and it works particularly well with Kotlin, which is why we're going to be using it this week. But that'll essentially make it so we can take the JSON response from the API and then map it into those model classes that we saw a couple of slides ago. We did implementation of our API service, we can make use of it like this. So in this case, I'm calling weather service.currentWeather. I'm passing in a zip code, an API key, and the units, and I'm getting back a call object. We can then use this call object in an asynchronous fashion by calling enqueue and passing in a callback. What this will do is load the data on a background thread and then call us back on the main thread, and it'll let us know if there was any type of failure, or it'll give us back the response that we got back from the network. Then we can get a hold of the response, check if it's null or not, and then do anything else that we need with it. Move on to anything else, we really should take a closer look at threading on Android. So as a quick refresher of threads in general, a thread is an independent path of execution within your code. Within a thread, instructions are run one by one. So these instructions are literally just lines of code. The same way we think about stepping through our code visually, we might look at line 10, line 11, line 12. That's very much the same way in which a thread is going to run each of those instructions within your code. So as we're running these instructions one by one, an instruction can't start until the previous one is finished. In this case, the second instruction is considered to be blocked by the first. Particular challenge. Android apps run on what is called the main thread by default. That means by default, everything you do in your app runs on the same thread. So all of our activity on create function, on resume, on start, everything we've been doing is all happening on the main thread by default. The challenge is that drawing the user interface also happens on the main thread. And to help ensure performance and smooth UI, that main thread is going to draw that UI every 16 milliseconds if it can. This means that we have to do all of our work, all of the responding to any type of event, click, interface, loading data. We need to make sure that every 16 seconds our work is done so the main thread is free to draw the UI. If we block the main thread, we will cause slowdowns in our app and jank in our UI. You might see stutters. You might see the UI completely freeze. And in fact, if you block the main thread for too long, you'll receive an activity not responding dialog in your app. These are also what's known as ANR dialogues. And these are bad. These are things you really want to avoid. So it becomes really, really important in the world of Android to avoid blocking the main thread. It should be run on some type of a background thread. And there's a lot of different options available to us for running things on that background thread. We have threads themselves. We have executors. We have runnables. We have abstractions like async task, high-level libraries like RxJava, coroutines, work manager. And honestly, we haven't talked about most of these, and I don't want you to worry about most of them. Some of them have their place and are still popular in the world of Android. Others are maybe more deprecated, not used as much. Not important so much for our task right now. I just want to illustrate that there's a lot of ways to go around this because it is a complex problem. For us, thankfully, and for this week's assignment, we can rely on retrofit because retrofit has mechanisms for handling this built into it. The retrofit call class enables us to asynchronously load our network requests. We can pass the callback to the request. The work will be done on the background thread for us, and then we will be notified on the main thread. So this really takes care of most of the work to make sure we're not blocking our main thread and that our UI stays nice and responsive. Just to refresh and to kind of bring it back, as we saw before, we're creating our call class to our weather service in this example here. When we call in queue, we're then passing in that callback. So the work of enqueue is going to say, hey, some other thing on a background thread, make this API call to load the current weather. We're going to do this work on a background thread, and when we're done, we're going to take this callback, call it on the main thread, and let the caller know that we either have the weather or there was some type of failure. So this type of callback pattern is very common in many types of libraries, and it's a good way to help ensure that we're not blocking the UI or just any other thread in general. This week, so I want to take just a second and examine that a little bit more. So we see here, this is a picture from the API documentation for Open Weather Map. And they have a number of different ways of getting data. Each of these, it can be considered to be its own endpoint. Essentially, this is a different remote function or remote URL that we can call, and will hand us back different types of data. And each of them will also take different types of data as parameters so we can customize the request and get custom responses back. We're going to be working specifically with the current weather data endpoint and the one call API endpoint. We found it openweathermap.org/API. That's where you can find map.org/API. That's where you can find more information about it. And in the demo later on, we will actually be showing how to create your free account and get a hold of your API key. The two endpoints we're using, one is /weather that will return us the current weather. We'll also be getting a lat long location from that endpoint. And then we have the one call endpoint, which is kind of their new one-stop shop endpoint that can return a lot of different things, but we're going to be using it to get a hold of the 7-day forecast for our specified location. Another type of remote data that we might have to load is actually images. App resources can't be